Subscribe now and press the bell icon. Never miss an update.
So what is SQL? SQL, or SQL, as some people call it, is an abbreviation for Structured Query Language. It does a lot more than querying, but that's what it stands for, Structured Query Language. It's generally pronounced SQL, as I've been doing, instead of SQL. SQL is a unified language for defining, querying, modifying, and controlling the data in a relational database. SQL itself isn't really software. It is a standard specification for which companies like Oracle use and then develop software based on the specification. The reason they develop the software is they have to develop it so it will work with their database management system and their hardware. Microsoft or another company would have to do the same thing. They have to look at the standard specification and develop things to run with their database management software and hardware. SQL itself is a specification that's agreed to by standards bodies. Standards bodies tend to move kind of slow compared to commercial institutions. They lead the standard, the commercial institutions, by extending SQL to meet the needs of business. Fortunately, these standards bodies meet every 3 or 4 years or so, and the major players like Oracle, Sybase, Microsoft, IBM, they get together and they try to incorporate things that they found to be useful into the standards if they can. And often the standards will evolve over time and become more useful and hence more standard across the different platforms. Fortunately, when you learn one form of SQL, you should have not a big problem moving to another form. 90% or more of it's going to be the same. Certainly the fundamentals are almost exactly the same. There's a couple of little quirks here and there, but it's not much different. Oracle does provide some Oracle-specific extensions that we will be learning about in this class, and Oracle SQL is probably the most called for database in the market today. This is on interactive SQL. What I mean by that is we're going to be using a tool. I'm going to recommend that you use something called Oracle Apex. There's a free online version you can use and set up an account for no money. And it's software that runs over the internet that allows you to type in and practice Oracle statements. You type them in and press a button to run them, and then you see the results. The exercises that we do in this class, we're going to be using this interactive SQL. Embedded SQL, which is SQL that's run inside of a computer program, is not covered in any detail in this class. I will touch on it from time to time and show you a few small examples, but it may be of interest to you with languages like Oracle's PL SQL. Most interactive SQL in the real world ultimately ends up in a computer program. Whether you're the person to develop that program or not, who knows? There are other tools like Crystal Reports, ReportSmith, that are heavy users of SQL, but they extend it to give you better reporting capabilities. And knowing the fundamentals and the statements of SQL can help you use those tools as well. Now, the SQL language, it's not a natural language in the sense that the way I'm talking to you now. It's non-procedural, which means you're not going to have to set up a recipe for what has to happen. You don't have to say, well, first go over here and get this, and then show me that data over here, and then put that data and compare it to something else, and go through logical steps to get to an end. Languages like PHP and Java, to some extent, have procedural aspects to them where you have to do that. SQL doesn't have that. It has a definite syntax, but it's a way of asking a question of the database or instructing the database to do something. And so it's declarative in nature, not procedural. The database management system will figure out all the steps that are necessary to take to get what you asked it to do to be done. So SQL is free form. You can go over lines and extend it that way as much as you want. But there are individual clauses in the language that have to be in the proper order. You can't put one before the other if it doesn't go there. You'll see an example where we have a select statement. Well, the select has to be the very first word. And then we have from, where we give table names. You can't put the from before the select. You have to follow that order. Fortunately, you'll pick up a lot of this just by osmosis in the demonstrations. I'll show you the syntax for each statement as we develop it. But be sure to follow these clauses in the order that they're presented. SQL may not be able to do everything that you want in a single statement. You might need to run more than one statement to really get a true answer. For example, you might be looking for detailed information about your employees, and then you might be looking for some summary information about your employees, and that will often require two separate SQL statements to run. We've been talking about relational database and how SQL works with that. It allows you to do everything with a relational database. So what exactly is a relational database? To make something relational, there's a few rules that need to be followed, and I'll go through them here. For example, all the data is stored in something called tables. The mathematical term for these tables are relations. It's a grid-like format. It's similar to a spreadsheet conceptually, but it's not a spreadsheet. Same idea though, it's a regular grid. You'll have the certain number of rows and you'll have a certain number of columns. Each row will have the same number of columns, always. The logical representation of data is separate from its physical storage, which basically is saying you don't have to worry about it. You don't have to think about what row goes where. Oh, this employee is stored on this part of a file or a directory and this other employee is stored someplace else. It's not something that you ever concern yourself with. The Oracle Database Management System will handle it all for you, or any database management system. There is one high-level language that is provided for structuring, querying, and changing information, and that, of course, is SQL. To continue with this discussion on relational database management, they support concepts of selection, projection, and joins. Now, this is not something that you're ever going to have to think of again, probably after this class, but it's just the idea that you can select what information you want to see. You can project what kind of information you want to see in terms of the criteria that brings back rows of information, and you can join information together. I mentioned that everything is stored in a table. Well, if you imagine again that table to be like a spreadsheet, and you have another spreadsheet that has some information you're interested in that kind of goes with the first one, you have to have a way to pull that all together so you can report on it. If it sounds confusing now, don't worry, this will be cleared up as we go along. A relational database management system supports the concept of null values. And null values essentially are missing pieces of information. For instance, if you didn't know my phone number, you wouldn't put a space in where the phone number goes, or you wouldn't put a 0. You simply wouldn't enter information, and the database will see that as null, meaning not filled in, missing completely. And it has a way of tracking these null values, and you, as a SQL developer or SQL user, will have ways to interrogate about the nullness of the various information on a database. Another thing a relational database allows is something called a view. It's a view into the data. There are ways to look at the data and view it that weren't part of the original intention when they built a table with, say, 20 columns. You can create a view that maybe only looks at 3 columns of that table, for example. SQL and the relational database provides mechanisms for things called integrity. This is the consistency and logical consistency of your database. Recovery, to get information back should there be a system failure. Authorization, which is security. And something called transactions, which are situations where you need more than one SQL statement to run correctly for it to be considered a logical unit of work. What are tables? I said they're like spreadsheets. They are. They have rows, they have columns. A set of related tables is called a database. You may think, oh, well, Oracle's a database, isn't it? No, not really. We might talk about it that way, but Oracle is a database management system. A database is something like a payroll database, or an employee database, or a vendor database. They're a set of related tables. What makes them related? You do. You, the designer, the company, the organization, decides what kind of information needs to be stored together in the same database. So database is something that someone like you, as you learn SQL, can create. A database management system is a completely different skill set altogether. Now, tables are separate but equal, in that there's no inherent hierarchical ranking. There isn't one table owns another table. You can force the issue, as you'll see later, but generally there is nothing inherent. It's not like putting a folder in Windows where you have a folder, then you stick another folder inside that folder. You don't do that with tables. They all live out in space, all by themselves independently. There's no necessary physical relationship to each other. If you have an employee table and you have a department table, you do not have to care about where this all resides on the database. It will handle it for you. What are entities? This concept of an entity is something that becomes important to someone putting together the database. And there are things that generally become tables. I like to think of an entity as a person, place, or thing to hold information. Something you got to store. You got to keep track of something. An employee isn't a person, and you want to keep track of your employees. So you have an employee entity. A table is a collection of separate occurrences of an entity. If you have an employee table, the employee is an entity type, and each row is an occurrence of that type. So each row on the table is one employee. Imagine, if you will, again, the spreadsheet model. Row number 1, employee Steve Perry. Row number 2, Jane Smith. So forth and so on. All the separate characteristics of each occurrence of an entity, in other words, for each employee in this example, will have characteristics, and each column holds a characteristic. For example, an employee has a name, an address, a phone number, etc. And instead of, like you might see in a spreadsheet, you'd see the columns labeled A, B, C, D, here you might see the columns labeled name, address, phone number, etc., something like that. A row is a single occurrence of an entity, and each column describes one characteristic of that entity. This ends part 1 of our discussion about relational databases. The next lesson will pick up where we left off. This lesson begins part 2 of our discussion on relational database management systems. So this is the last slide we were on, talking about rows and columns, and that a row is a single occurrence of an entity on a table, and each column describes one characteristic of the entity. So here is an example table. Entities tend to become tables. Imagine, if you will, that this information in red at the top, last name and city, are column names. They describe characteristics of this table. This is an exceedingly simple table, not very practical at all, but it will give you this beginning idea. So we have Perry, last name, Smith, and Jones. Perry lives in San Diego, Smith lives in Los Angeles, Jones lives in Los Angeles. Last name and city are columns. Each different person is represented by their own row of data. Now here I'm introducing the concept of something called a primary key. You may have noticed in that last table that there was no row number. There was no like row number 1, row number 2 like you might find on a spreadsheet. So we have to have a way to keep track of the uniqueness of each row in a table. So there is this concept of primary key. Now that is defined as any column or combination of columns that can be used to uniquely identify a particular row within a table. So if we have a table and it has a social security number on it, well, the hope is if you know my social security number, you get my rows of data and no one else's. And there's ways to enforce that with SQL. In this example, a ridiculously simple one, we would say that the last name can be used to ensure uniqueness. Now, in the real world, of course, this would be a terrible choice. If you made the last name the primary key, then you could never have another Perry, another Smith, another Jones. And if this were an employee table, that could be a problem. You don't want to do that, but this gives you the concept. You need some value in some column or some combination of columns. You could use first name and last name, but that's not a good choice either. You'll see as we go through the class that there are much better choices used for primary key. There are two types of tables, if you will, two categories of tables. There's user tables. These are the ones that you can define. I'm going to show you how to do that, or have been defined for you by somebody else and you're just using them. Interestingly, a relational database management system creates tables to keep track of tables. Matter of fact, there's a table of tables. Anytime a user creates a new table, I'm going to create an employee table. Well, the table of tables keeps track that you kept track of that table, or that you created that table. There's a table of table columns, which will track all the columns that you decided to put in that table. So there is metadata, if you will, data about data that's kept in these system tables. And this just happens automatically and is managed by the relational database management system. A little bit more about SQL. It's considered a very high-level language. You do not have to break everything down logically. You don't have to tell it what to do. You just simply find the right way to state what you want done, and it figures out how to do it. Now here's three academic categories that SQL tends to be broken down into. There is the data manipulation language, or DML, and that's what we use to query or search for data that's already in the database, and what we use to update, delete, change, or insert new data. So the next broad category definition is the data definition language, or DDL, and it defines objects in the database. Primary object is a table. So you will use SQL to create new tables and define them, what they should look like. What are the column names? What can go in there? Text, dates, numbers, that kind of thing. So that's the data definition language. Now the last one is called data administration language. It's DCL, which stands for data control language. That's what you use for a whole variety of data administration tools. The main one is to control access to the data. Who gets to do what? Who gets access to it? Who gets to change it? Who gets to create it? SQL will handle all of that for you. So on this slide, we see a breakdown of data manipulation statements. There is the select statement, which displays information you want to see from the database. This is a very powerful statement. We'll spend about half the class on this. There are many options, there are many complexities that can help you get data out of a database. The insert statement allows you to add rows to the database. The update statement allows you to change existing column information on one or more rows. The delete statement deletes rows of data. The data definition language has two main statements. There's the create statement, which will allow you to create tables, views, and something called indexes that help speed up queries. The drop statement allows you to remove tables, views, and indexes. You create database objects and you drop them to get rid of them. Personally, I would have picked the word destroy as an opposite of create, but that's what you have to do. Drop is the key word. It means to remove a database object completely from the database. Now the data administration or data control language statements, the primary ones are grant statement, which allows you to define what user IDs have access to what tables and columns. Once they have that access, you may want to take it away, so you can use the revoke statement to remove user ID access to various tables and columns. This lesson is on how to query data. The select statement is what we use, and this is your introduction to the select statement. So the next series of pages will show you sample tables and data that we'll use to illustrate the select statement. So here is an example table structure. There's two tables here. The first table is the employee table, and it has three characteristics. It's got the last name, first name, and city. And then I have something that I'm going to just call the zip codes table. It has a city and a zip code. So that's the structure, the basic structure of these tables. Let's look at data in these example tables. So you see we have across the top, the last name, first name, and city are the column labels. And now we have whole names now this time. So we have Steve Perry, Will Smith, Tommy Lee Jones, and the cities they live in, San Diego and Los Angeles. The bottom part, the second table, what I call the zip codes table, shows the city, San Diego having a zip code of 92001 and LA 90211. Clearly, both these cities have many more zip codes, but let's just pretend for this example. Let's talk about projection. Projection allows us to see what columns we want to see. We don't have to see them all. We can see the last name and the city from employee. Look at the results. I have last name and city, and I have Perry Smith Jones and San Diego and Los Angeles. That looks just like the sample table that I was using before. One thing that's particular about SQL and relational databases is not only is the data stored in a relation, that is a regular grid where you have the same number of columns on every row, so are the results. Every time you run a select statement, you will pull back another regular grid or relation that has that characteristic. You'll never have a last name and nothing in the city. There won't be a city column, and then a last name, city, and a zip code on another row. It's always going to be just the last name and just the city on all rows. So the selection part of it is where we specify some criteria. We say, I'm a large company and I have lots of employees and I don't want to see them all. I only want to see the employees that live in San Diego. So here the select statement says select last name, city from employees where, this is a new clause, where city equals San Diego. Now notice I put that in single quotes. That's what I need to do with text data in SQL. So the results now on that table, the table still has 3 columns and 3 rows, but I'm only bringing back 1 row and 2 columns. I'm bringing back the last name and the city, and I'm only bringing back the rows where the city equals San Diego. So I've only got 1 row. If I were looking for where the city was Los Angeles, I would have brought back 2 rows, the ones for Jones and Smith. Alright, so now we get to the concept of something called joins. Unlike spreadsheets, you generally don't take information from one spreadsheet and then match columns with another spreadsheet and pull it all together. But you do that all the time with a relational database and SQL. There's a joining criteria. I'm going to show you an old school way to do it here, but I'm going to show you a better way when we get into the lessons on joining. Here, I am selecting the last name, city, and zip code. And you're going, wait a minute. The last name, city, and zip code's on one table, and the last name's on another. I gotta get all that stuff together somehow. The from clause allows us to do that. I'm showing you here where we use from employees, comma, zip codes. Those are the 2 tables. And I'm still doing where city equals San Diego, but now I say, and the employees dot city, that's the city column on the employees table, equals the city column on the zip codes table, or zip codes.city. So this is one way we can join tables together. And once we do that, we can pull this information back in a result row. Now the result row has information from 2 tables. You can do this as much as is necessary. You can pull information back from 20 tables if it makes sense to do so, and put it all on one row. As you'll see with relational databases, things are broken up. One of the things that one tries to do with a relational database is reduce data redundancy, and this causes information to be spread out across multiple tables. Well, that's nice for data redundancy reduction, but when you're trying to find out some information, you often need to get this stuff back together for presentation. Now remember I mentioned null values before, that a relational database must support that. So null means unknown, missing, or not applicable. It does not mean 0 or blank. For instance, if I wrote a book and we had a column in the table that said how much money they were going to give me before I wrote my book, it would probably legitimately say 0. They're not going to give me anything. I'm not famous. If Bill Gates writes a book, they'll probably give him $1 million. So 0, in my case, is a legitimate value. It's not like, well, we don't know, so we'll just put a 0 there. No, if they don't know what they're going to give me, then they leave that column null. They don't fill it in. And the database has a way to track that null or missing information. We deal with integrity, security, and transactions. Integrity ensures consistency and accuracy of the data. Security ensures the proper authorization to view and or update the data. and transactions allow data to be saved to the database as a logical unit of work. SQL views are derived tables. They allow a different view of the data stored in existing tables. They're not actual copies of the data. They actually are a stored select statement that gets run when you call the view. It runs a select statement and brings the information back the same way as if it were a table. Remember earlier in this presentation, I ran a select statement that just brought back 2 of the 3 columns that was originally in the table. Well, I can name that as a view and pretend it's its own table for purposes of selection. If this is confusing you now, don't worry about it. We're going to have a long chapter on views and how they're useful for both security and reducing complexity. This is kind of known as a virtual table. This lesson is on the difference between SQL and PL SQL. What is SQL? Well, we've already covered that, but as a reminder, SQL is a unified language for defining, querying, modifying, and controlling the data in a relational database. So what is PL SQL? That's usually the way we say it. Well, it stands for Procedural Language / Structured Query Language. It's kind of an odd way to do it, but it is the procedural language that Oracle has developed for issuing SQL and dealing with the Oracle Relational Database. So what does that mean? It means that PL SQL is a programming language. It may issue one or more SQL statements from within the code of that language and deal with the results by storing them in program variables. It doesn't have to issue SQL statements, not required to, but it may, and it knows how to deal with it if it does. Now, PL SQL is just one of many programming languages that can issue SQL statements. It happens to be Oracle's language for doing this. So again, PL SQL is a programming language. SQL itself is not like a programming language, not at all. You just make a statement about what you want to do with a relational database with SQL. But with PL SQL, you must use programming constructs like variables, if statements, loops, etc. to control the flow of program logic and the intermediate storage of data. You don't do any of that with SQL. Here's some example SQL that we're going to be working with interactively. We have a statement, select last name, comma, first name from author. So that's going to give us a list of all the authors we're keeping track of, their last name and first name. Get a whole list, however many rows, how many authors we'll have that many rows of information. When you run the statement interactively, you just see that list. Here it is with PL SQL. Now this is a program issuing a statement just like what we did interactively, only handling it through a program logic. You've got some keywords here. Declare cursor. Okay, what's a cursor? You'll learn a little bit later. Cursor author is the name we gave this cursor. It is defining a select statement. Cursor author is, third line down, you see select last name, comma, first name from author. That's what we typed in before. Now we have a begin and end block. You can see the big words begin and end at the very end. And within that block, we have a for statement, which goes through the select statement of cursor author and runs it and brings back one row at a time in the row index, or uses the row index to track one row at a time. And then we have a loop and an end loop. So we're going to do this over and over again until we run out of rows that were brought back from the results of the select statement we issued. That line within the loop, between loop and end loop, is just a way of putting a line out onto a report. It shows us the last name, comma, and first name for the particular row that it happens to be processing in this loop. So you can see this is not SQL. There's a little SQL in it, but it's a programming language that has many more constructs. You do not need to know how to do that for this class. Fortunately, if you do want to know how to do that, Infinite Skills offers a separate class in PL SQL. And you can see the link for it down below there with the infiniteskills.com PL SQL, and take that class after taking this one if you'd like to extend your skills. This lesson is on how to set up a free Oracle Apex account. Oracle Apex will allow you to use the web to submit your Oracle SQL statements and see the results. Oracle allows these free accounts to be set up for students, which is nice. There are alternate ways to run Oracle. You can install a version of Oracle SQL Developer on your computer and work with an interface to try to get that to run, but it's very cumbersome and takes up a lot of hard drive space. So I prefer the online account. It's free. You can use it for as long as you'd like. The first thing you need to do is you need to type in the URL to begin this process. And it is apex, A-P-E-X, .oracle.com. Hit the enter key and we're brought to the basic page, browser-based development. What you want to do is you want to request a free workspace. So let's click on that button. And now we're brought to another window where you get a little bit of explanation, but what we want to do is just get started. So the big blue buttons are usually the buttons you want to click in this process. Okay, so we're going to deal with names. Steve Perry. And for my email, I'm going to use a college email. Now you have to use the correct email address because you're going to have access to it. They're going to send you information that you're going to need to get set up, so don't put in a bogus email. So there's the big blue button. We'll hit next. Now it says workspace. Your workspace has to be uniquely identified from anybody else's workspace, but you don't know what workspace they have. So I usually set things up with a combination of the first part of my email, in this case S. Perry, and I'm going to just put S. Perry Skills, kind of short for Infinite Skills. And I'll click the next button. Now it says to enter the name of the Oracle database schema. This is just pretty much the name of the database where you're going to create tables. So what I do is I use the workspace name, and there it is, Steve Perry Skills, and I just add test to it. You can do anything. This is just my little technique to try to keep track of what I'm doing. So S. Perry Skills, test, and then the big blue button for next. So they're going to ask you a series of questions here. And so you can put anything you want to. Student, they're not really going to check. New to Apex. You can answer any questions. I'm just not even reading the questions right now, but you can go through and give them an accurate answer. So would you be interested in learning about the cloud service? And I'll just put yes. You've got that filled in. You click the next button. One error has occurred. What's the largest number of users? So I left something off the form. Here it is, and we'll say 11. Click next. Why are you requesting the service? I am a student learning Oracle. Press the big blue button. Here's the infamous license agreement that you get everywhere. You scroll down, read it if you wish. Whether you read it or not, you have to go down and tell them that you accept the terms. Click the big blue button for next. You can print this out if you want to help remember. Don't print out mine. You'll need to do your own information. I recommend printing this down or writing it out so you make sure that you've got the right information to log on with later. We've got to do this verification code. They want to make sure that you are not a computer. So we'll go down. And I'll now submit the request. Now this might take a moment. That wasn't too bad. So it says S. Perry Skills has been requested. Once this is approved, your username and password will be emailed to this email ID, whatever you provided. In the past, I've actually gotten 2 emails. I get one and I get all excited and I try to log on and I realize I don't have a password yet. Well, they usually send you another one shortly after the first. So I'm going to go over to my email account and we'll see if things are there. I am in my email account. It took about 3 minutes or so. My workspace, S. Perry Skills, and my username is my email ID. So it says click the link below to complete the approval process. So I'm going to click this link and it's going to create the workspace. This message took about 2 minutes to come back to my computer, and it says workspace creation status. Your request for a workspace has been approved And the credentials, that's your logon, have been sent to the email address that I provided during registration. So let's go over to my email again. Alright, I'm back at my email, and you can see that it's giving me for my workspace sperryskills, my username of sperry@palomar.edu, and a password that I'm going to copy and then we'll paste in. So they give us a link. Type in the correct username that they gave me, and then I'm going to paste in that password. Now the big blue button to log in. They gave you a generated password. You're supposed to change it to something that you'll remember. So I repasted the password they gave me in there, and now I'm going to select my own password and put it in twice, and then we'll go ahead and click to apply the changes. So that's good. Big blue button for return. And it brings me back to the logon window. This time it remembered the correct user ID for me, so I'm going to type in the password I selected. Blue button to log in application. So I am here. This is good. What you have to do now is you have to load the database. It's not there automatically. We're going to have to load the tables and data that we're going to use for this class. Go up to SQL Workshop and select SQL Scripts. This is the one window where you're not going to hit the big blue button. Instead, you're going to hit Upload. I have a file in your working file areas called oracleapex.sql, and that's what we want to get. So I've already downloaded it to my hard drive, and I'm going to navigate to it there. Click the Upload button. It brings me to another window where I actually do the browsing. So I'm going to browse the hard drive. I'm going to go to where I put this. And there it is, oracleapex.sql. You'll have one in Chapter 1 Working Files. Open it up. I still have to give it a name. So I'm going to call this OA1. So I click over here. It's a little bit to the right. It's the Upload button. So click on that. It says it's uploaded. Now, we haven't run anything yet. It's just uploaded to their system. So we click on the script to edit or run it. Well, we want to run it. Over here, you see the name OA1 and all the other information. We go over to this little run button, and I click the right arrow. Interestingly, you think that I would have run it, but no, I have not run it yet. I've just kind of run it into their system. So now we have to run in background. You don't want to do run now. That doesn't usually work. Click run in background. Now the code should actually run. Okay, so it says it's been submitted for execution. Click on the script icon to view the results. So close that. Here's the script icon. And I kind of took my time doing this because I find if you click this thing 1 second later, it might not be ready. It's probably done now, so I'm going to click on the View Results button. One of the problems with this is it just shows you 15 rows by default or 10, and I might want to see more. So I'm going to go ahead and select 200, and I'll put Go just to get more results display. Now it says it's reporting to me that these table or views do not exist. We have a statement here at the beginning row called drop table author and drop table book. These are the tables that we're going to need to run our SQL, but the first time through they're not there. So they come up as errors, but that's okay. They're not supposed to be there until you run it the first time. You see down below that these tables are created right after that. So if we were to run this script again, we wouldn't get these errors. Again, those errors on the drop statements, that's not a problem. First time through. So it goes through, you see things are inserted, the data's there, tables are created, rows are inserted. There's no other errors, so this is good. So the only ones that were errors were the drop table statements, which I said, again, you don't have to worry about the first time in. It's not a problem. Once we're here, I like to run a test statement just to make sure that everything indeed was loaded. So I go to SQL Workshop, and I click SQL Commands. So I'm going to select that, and I'm just going to type in a very simple SQL statement. Select, and put an asterisk, from author. That's one of our tables. I click the Run button, and I see that data has come back. So I've got some confidence. This lesson is on how to use the free Oracle Application Express account you set up in the last video. So here are my credentials. The workspace, you have to specify S. Perry Skills. Username is my email at Palomar College. And I'm going to put in my password. Log on button. And we're into the basic interface. So I'm just going to show you a few things that are useful. Most of what you want to do is going to be under SQL Workshop. Let's take a look at this tool here called the Object Browser. Let's open that up. Now you may recall that we loaded a database when we opened up the account, and then we uploaded a file. So these things are just tables that were there with the $signs. We don't need to worry about them. But the tables that we loaded, author, book author, editor, these sorts of tables, these are legitimate ones that we're going to use in the class. These demos were there before. We didn't do that. We didn't do department, editor, or imp. Publisher is one of ours. So how do we know which tables are ours? In the upcoming lessons, there is a database diagram that will show you the tables that you need to be concerned with as we proceed through the lessons. And I show that diagram to you throughout, and it's in a working file folder as well. As we go through the class, I'm only going to use a few tables at a time, and I'm going to build up from there. So you'll have a different database diagram as needed. So look in your working files area and you'll see a database diagram or DB diagram, might say part 1 or part 2 as we proceed through the chapters. So you can see the tables, how they're laid out, and what columns are members of the tables as we go into them. So that's one way to know what you need to use. It'll be very obvious as you proceed through the lessons. We're in this object browser. Let's take a look, for example, at the book. I'll click on the book over there. And now we have the table. This is the structure of the table. This shows us how it was created and what are the column names and what are the data types of the column names. So ISBN, varchar 2, 13. So it's 13 characters. It's the maximum value you can have. Nullable means it's required field. It's a required column. It has to be in there for you to even get this row in the database. So the title of a book also is required because it's not nullable. Everything else is nullable. So we could add just the ISBN number and the book title, and we could get this book into this book table, should we choose to. So let's go back to the top here. We can click on this data link, and you can see the data that's in the table just by using the object browser. Now clearly you can go in, you can edit the row within this interface, and you can delete records, rows. I believe you can delete them by clicking on the edit icon, and then you can override the fields, and over here there's a delete button. This forms-based method of manipulating the data is convenient if you know what you're doing. However, you don't want to do it this way. You're trying to learn SQL, and I'll be showing you the proper SQL statements that will do the changing, the deleting, and the inserting of rows into the database. So that's part of this class. So nice to know if you need to get something fixed fast, but you're here to learn SQL, so do it the way we show in the lessons. Indexes have to do with speed, if there are indexes built on that. And here this shows that the ISBN number, the column, must have a unique value across the table. You can play around with these various links here that bring you to different tabs and show you information about the table. So this can be a bit handy. Where you're going to spend most of your time is in something called SQL commands. You can either click this icon here to get to it, or under here you can click SQL commands. There's a little box where you can type in a SQL statement. This interface only allows one SQL statement to be written at a time. You can't run 2 select statements. There is something called a terminator that you put at a statement, which is a semicolon. So if I do select star or asterisk from book, I put a semicolon there, I run it, I'll see results. Theoretically, I should be able to do another statement here. I'll select from another table right after it. So I'll select from author. So when I try to run it, I get invalid character. You'll get that error for almost anything. It's not really a good explanation of what's going on. It really should say you can't run more than one select statement or something like that. If you get in the habit of copying and pasting statements from Notepad or TextPad or something like that, another text editor, it's usually good to make your statements be flush left. We often put each clause on a separate line, select and from, and then the new clauses you'll be learning. And so it's good to have it flush left, because if there's a tab character in there in front of your statement, you'll often get this invalid character message again. Now you run this again. So see, it works. It's okay to wrap lines like that, but just don't have things in front of it in general. So if you get that invalid character message, make sure things are all the way flush left. So one other thing to look at is, well, we looked at it already, the SQL scripts. If you need to run more than one statement at a time, you have to create that statement in a text file, upload it, and then go through that whole routine we did when we ran our OA1 file, that file that was uploaded from the Oracle apex.sql file that I had you upload. You can create your own and do it manually on the fly, but it's a bit of a pain if you make a mistake. So it's probably better to put it into a file, upload it, and run it there. There's nothing in this class other than the loading of the database with Oracle apex.sql that will require you to use this to run scripts. I'm just letting you know if you're going to play around and try to experiment with a database either during or after the class, you still have this area. It's a free account, and as long as you keep using it, every few months or so, Oracle will send you an email if it doesn't have activity telling you that you need to start using it soon or they're going to delete it. Other than that, I've had an account open for years with them. This presentation is on Assignment 1. Now, you don't need to run any SQL statements to answer these questions. This is just a kickoff to test your initial understanding of the concepts. So in your own words, what is an entity? Question 2, what is the purpose of a primary key? And question 3, what does a null value represent? So just write this out in your own words as best as possible. I won't be watching, so it is open book. These are important concepts to have in your mind as you begin this class. See if you can help set them by writing down what they do. This presentation is on the suggested solution to Assignment 1. As a reminder, we didn't need to run any SQL statements to answer these questions. So what is an entity? An entity, conceptually, is a person, place, or thing for which you want to hold information. That's what we're going to store in the database. Ultimately, entities have characteristics, but persons, places, and things are the things that have those characteristics and hence are entities. Entities will become tables. Question 2 is, what is the purpose of a primary key? It is what is used to uniquely identify each row in a table. A primary key is any column or any combination of columns that can be used to uniquely identify a particular row as being different from any other particular row. And in question 3, what does a null value represent? Null means unknown, missing, or not applicable. It's simply not filled in. It's a value that's not put in for a column on a row in the database. Null does not mean 0 or blank. 0 and blank, or spaces, is a particular value. You only use a 0 or blank if you mean it, if that's what you want the value to be, not as a placeholder for something missing.
Greetings and welcome to your Infinite Skills training course. This movie is going to help you find and easily access your working files for your Infinite Skills course. The working files are designed to allow you to work alongside the author as they're teaching the course material. And in most cases, the author will announce whenever they have provided a working file. Please note that the courses seen in this video may not be the same as the course you are currently learning. This video is meant only to demonstrate how to get your working files. If you are a subscriber to our learning library, you will see a Download Working Files button once you get into the details of the course. To download the working files, simply left-click on the Download Working Files button and your browser will automatically download the working files as a zip file. Once the working files have finished downloading, you can simply extract the downloaded zip file and place them directly onto your desktop. It's as easy as that. If you have downloaded this course from our website, then you will have gone to a download page that looks like this. And you may see that the working files are a separate download file. Once you have downloaded the working files, you can extract the downloaded zip files and place them directly onto your desktop. From the player, you will see a menu bar located up here with various buttons just above the video. From the player menu bar, look for this button. When you move your mouse over it, a label will show up that reads Open Working Files. Left-click on this icon and a window will open up to show you where the files are located. You may see multiple files as the working files are organized within them. To make things easier for yourself, we suggest copying all of these working files to the desktop of your computer. Please note that if you downloaded the working files separately, as we mentioned earlier, you will not see them here. However, you should already know where they are, as you should have extracted them and placed them somewhere on your computer, well, like the desktop. If you are watching this from the DVD, there are a couple of ways to access the working files directory so you can open up your files. Now, you will only be able to open these files from the DVD. If you make some changes and would like to save them, you will need to save them onto your computer. Copy the working files to the desktop, as we have shown earlier from the player. This way you can find them quickly and easily because they are located on your desktop, and you can open and save any changes as you work along with the lessons. You can also find the working files by going directly into the Files folder. To get to this folder from your DVD on your PC, go into your computer, find your DVD drive with the disk in it, and select it. You will see that there will be a Working Files folder on the disk that you can drag and drop to your desktop. You can also copy this to your desktop by right-clicking on the folder and selecting Copy, then right-clicking on your desktop and selecting Paste. If you are on a Mac, click on the DVD icon for the disk on your desktop. A window will open and show you all the files on the disk. You can then drag and drop the working files to your desktop. You can also copy this to your desktop by right-clicking on the folder and selecting Copy, then right-clicking on your desktop and selecting Paste.
This lesson is on retrieving all the data from a table. One thing I'll point out here is in each one of these lessons, I have an area over here on the left that shows the lesson title, Retrieving All Data from a Table. Now you'll find in your working files, this file that I'm going to present here, it'll be called Retrieving All Data from a Table.html. You can just open that up in a browser to see what I'm going to be showing you here today in this lesson and in any other lesson that you see. Let's talk about the select statement. The select statement is the only statement that is used to query data on a relational database. It's the only SQL statement you can use to get data out and display it. It has many, many options, and we're going to be learning about most all of them as we proceed through the class. The most basic option is the asterisk selector, sometimes just called star, and it brings us back all the data for all the columns. So if we look at an example of a select statement, we have select star from book. Now from specifies the table or tables we're going to look at. So we're just going to look at the book table now. And we want to see all the columns. That's the shortcut for saying that. So I don't have to write them all out. Let's take a quick look at our database here. We have a simple two-table database right at the moment. We'll expand on that as the class proceeds, but for right now, keeping it simple, we have a publisher table, which has one row for each publisher in our publishing house holding company, and each publisher can publish various books. You can see the book table here, and you can see there's a number of columns: ISBN, title, type, pub ID, price, advance, year-to-date sales, which is just the number of books sold so far this year, and the publication date called pub date. So let's go back and take a look at the statement. I'm going to copy it here, and I'll paste it over in this SQL statement area, and I'll click the button to run it. Let's go down and look at the results. So we have the results here. These are all the rows on the table. There's 17 in the book table. But you see it's also all the columns: ISBN, title, pub ID, all the way down to pub date. It's important we got everything. Now we're working with a very small set of data in this class database, and this is nice, so you can easily go take a look at the data and get a sense if your SQL statements are giving you what you expect by just looking at all the data in the table. So you can do this at any time. I want to point something out though. What we're seeing now is all the data that's currently in the book table. If we weren't just working with a class database that wasn't going to change unless you changed it, if we were working for a company or a large organization, data changes all the time. People decide to not publish a book, they drop it, or they add more books. So you could run the same select statement, select star from book, and get a different answer every time you ran it, theoretically, if you had a large enough organization with enough activity on the database. One thing about relational databases is people can change them from multiple places all over the world. 3M, Exxon, Apple. These companies have databases that can be accessed from anywhere in the world, and multiple people can be changing data at the same time. Remember to primarily base the rightness or the correctness of your statement based on the question it's asking. Here I'm asking, show me all the columns from the book table. It's not based on the data, primarily because the data can change at any time. Now you will, of course, be the only one updating the data here, but remember to code your statements in such a way as if the data could change at any time. Don't code to the data that you're seeing now. Let's look at another example. The other table we're dealing with is the publisher table. So let's go ahead. I'm going to copy it into here and run it. And we'll see we've just got 3 rows. Binder and Smith, Technobooks, Sunshine Publishers, etc. 3 publishing houses that we're dealing with. So it's just 3 rows. All the columns here, there's less columns because there were less columns in that table. Simple as that. At the end of each lesson, I'm going to give you an exercise, something for you to practice yourself based on the lesson. I want you to look at that and run it in the Oracle Apex area. Here's the problem. Code a select statement that lists all the data for the book table. All right, well, that's pretty easy. We just did that. Normally, I'm not going to show you the solution here. I'll leave you on this page, and then you can go do the exercise. But here, since it's so simple, I'll show you. Now at the end, I have the solution here, select star from book. You can go into your working files, get the lesson here, and you can just scroll to the bottom and you'll see the solution. But by not showing it to you within the lesson itself, it gives you a chance to try to work it out on your own and work out the thinking. Obviously here it's exceedingly simple, but it's going to get more complicated as we proceed. All right, do the exercise. Make sure it can work in your Oracle Apex area. This ends our lesson on selecting all data from a table in a relational database. This lesson is on retrieving some of the data from the table. Last time, we saw how to retrieve all the row with the select asterisk. This time, we're going to specify specific columns that we want to see. I have select, title, price, from book. Let's go back and look at the database diagram for a moment. And you can see that the book table has a primary key of the ISBN number, but it has a book title, and it has a price there. So we want to just see those 2 columns. Go back. I'll select this statement. I'll copy it and paste it over here, and then submit it. And it runs. We come down and we see the results. We have 17 rows. Now that makes sense. There were 17 rows when we looked at all the books, so we are looking at all of the books. But instead of seeing all of the columns, we just see the 2 columns that we asked for, the title, Silicon Valley Startups, and the price, $40. So let's go back up and look at another example. The other table we're dealing with here is the publisher table. So let's take a look at the name, city, and state on the publisher table. And we'll run it. And there it is. There's the name of the publisher, and the city that they're based in, and the state that they're based in. This gives you all the rows stored in the book table, or in this case, all the rows stored in the publisher's table, if we come down to the second example. But only for the columns that we wish to see. Let's take a look at the exercise. Code a select statement that lists each book's title and the number of books that have been sold year to date. Go ahead and look at the database diagram that you have in your working files. Look at the table, see what columns are available, and see which columns you'd use for title and the books that have been sold year to date, and display those in a select statement. Now you can scroll all the way down to see the solution. This lesson as well is in your working files area. This lesson is on restricting the retrieving of rows from a table. You can use something called the where clause to specify criteria that will restrict the number of rows that come back from the select statement. Let's take a look at the example here. I have select and I've given some column names, title and price. I specify the table that we're looking at. It's from the book table. And now here's the new clause, the where clause. And I say, where price is greater than 20. What SQL is going to do is it'll look at the rows in the table one at a time, essentially, and it'll ask a question of them. It'll say, is the price greater than $20? And if so, it'll return that row into the results. We'll see the title and price for that book whose price is greater than 20. However, if the price is not greater than 20, it rejects that row for consideration, and it doesn't show it in the results. Let me copy this. I will put it over here and paste it, and now we'll run it and see what it looks like. So if we look down at the results, we see that we have only 12 rows returned here. We know from past experience that there's 17 rows on this book table, but we're only seeing 12 of them because we only wanted to see where the price is greater than 20. And as you can see, they all are. If we were to look at the whole table again, we would see there's another 5 books or so whose price is less than 20. Let's go back and look at another example. I can use the star or asterisk in conjunction with a where clause. The asterisk essentially means show me all the columns. And so I can do that and still restrict the rows. So let's try that. Select star from book where price is greater than 20. Submit it. And now I get all of the columns, and I come down and I see that I have 12 rows. I look at the price again, and I can see that they're all above $20. So this is a good thing. One more example. I can look also at text data. I don't have to just look mathematically whether something's greater than or less than something. I can look where it's equal, and I can look at text. In this case, I want to look at the publisher table to see where the city is equal to Boston. So I'm going to copy all of this, and I'm going to paste it over here. Now, there's a mistake that I put intentionally because I want to show you this. An easy mistake to make is to use a semicolon in the wrong place. You only put a semicolon at the end of the entire statement. It is the terminator that says the SQL statement is over. If I put it there, it would have just run that part of it and then not known what to do with just a where clause hanging out in space by itself. Let's go ahead and run this and see what happens. And we go, oh no, I've got 0 rows. The temptation is to think that that's a mistake. Well, it might not be a mistake. If you're truly asking what publisher lives in Boston, there are no publishers who are based in Boston. Let's put Cupertino in there instead. And now I'll run the statement, and we correctly get back 1. So both answers were correct depending on which question I asked the database. How many in Boston? 0 are in Boston. How many in Cupertino? 1. So this is the right way to do it. One thing I want to point out too, in Oracle, the data is case sensitive. In some other databases like MySQL, it may be set up to be case insensitive. If you're using Oracle, you're going to need to run some special functions if you want to force a case insensitive search. And we'll get to that later in class. One other note for those of you who might be familiar with computer programming, like a programming language, very often when you compare in a decision statement, like an if statement, which is very similar to our where statement here, you use 2 equal signs to do the comparison. You say, where city equal Cupertino. Well, you don't do that in SQL. SQL is not a programming language per se. It's a declarative language where we ask questions of the database or we give instructions, and it figures out how to do it. So when we compare, we always use 1 equal sign. Now let's go and take a quick look at the exercise. It says code a select statement that lists each book's title and the type of book it is. It's a computer book. It's a cooking book. Remember that you can always go look at all of the data in the book table and just see what it looks like and get a feel for it. Doing that at a company that had millions of rows, it may be harder to do that. But here, while we're learning, we're working with a very small database. Here, I only want to see books. I'm saying only show books whose author has been advanced more than $10,000. So there's an advanced column in the book table that you need to inspect in a where clause and make sure it's more than 10,000. Now, you could pause this presentation here and do the exercise and go back, but you can also go to your working files area and get the lesson that's there and see this exercise. And I've put the solution about a page down on the lesson that you find in the working files area, so you can try it yourself without peeking and then scroll down and see what the answer was. These early exercises are fairly simple, so it's probably not going to be needed. But as we go on, things will get more complex, and you may need my solution to know exactly how the problem needed to be solved. This lesson is on using mathematical and text expressions in a select list. You're not restricted to just using columns. You can put things a bit more complicated. Let's take a look at an example here. I have select, and then title, comma, price, comma, and then I have price again, but this time I have price times 1.05. This is essentially going to show me what would the price look like if I bumped it up by 5%. Now, we don't change anything in the database when we do this. We just get to see what that might look like. And of course, this is all from the book tables. So I'm going to copy this and paste it in the SQL area, submit it, and you can see we see the current price over here, price is 40, and then what it would look like if I bumped it up by 5%. Likewise, all down the line. So we may be considering a price increase, and we want to get a feel for it and make sure it doesn't look like it's too expensive. We're still going to be able to sell our book. Let's move back up to the top here and go down to another example. I want to show you the standard mathematical operators, what they look like. Here's a plus sign for addition. You use a hyphen for subtraction. And as you've seen already, we use an asterisk for multiplication, and then a forward slash for division. Now, there's other mathematical operators that you can run in SQL, but these are the most common and what we'll use right now. Another thing to note is that you can use parentheses the way you would in any mathematical formula. So here, if I want 7 plus 5 to happen first before I multiply by 8, I just simply put it in parentheses, and that'll happen. These numbers, of course, can be column names. Taking a look at another example, here we go. I've got title. Now, the next thing is price times year-to-date sales. So I can have two column names operate on one another. We're going to get that. Now, price is obviously the book price. Year-to-date sales is an integer count of how many books we've sold so far. So this is going to give us a revenue figure. And so here's the formula. Revenue equals price times year-to-date sales. Let's go ahead and run that and see what that looks like. Put that over here. Submit it. And now we see we've got the book title and how much money it's made so far. 1 hour negotiations, $122,000. Okay, great. Now you notice, even though this is money to me, we don't put dollar signs in the formatting. Generally, formatting is done by a computer programming language, either one that's custom written or by using a commercially available product like Crystal Reports or ReportSmith. These are SQL report writing tools that you can use. The more sophisticated formatting with titles and headings and dollar signs will be done through those tools as opposed to what we're doing here, which is interactive SQL. So let's go up and take a look a little farther down. It would be nicer to see something more meaningful than just price times year-to-date sales. So if you did want to do a tiny bit of formatting, I want to get the word revenue to appear there instead of that formula. So the way to do that is on any expression, and that's what these things are called between the commas and the select list. They're actually called expressions. The most simple expression is just a column name. So we got the column name, price times year-to-date sales, that's an expression. And if I skip a space and I put something in double quotes, I put a word there, that'll become the new column heading. Instead of this, we'll see revenue. Let's go ahead and see that work. Copy here, paste into this window, submit it. Now we see the word revenue. So you can do some minor formatting like that if you wish. Let's look at one more example. I've been working so far with numbers, but what about text? See this? I can put in single quotes in the select list. Single quote, publisher, colon, space, single quote. So that's going to literally put the word publisher on every row that's returned in the result set. It's just hard-coded. Name is the column. Notice these are between commas. That's the column that holds the publisher name. Another comma, and then a tick and tick, or single quote, is based in, and then I give the city column and the state. And that's from the publisher table. I'm going to paste that in here, and I'm going to submit the SQL. So now you can see publisher, Bender and Smith, is based in New York City, New York. Likewise, All Techno Books is based in Cupertino. So you can put text in this way. There's ways to get the text to combine with the name in the same column as well, and we'll be learning about those kinds of functions later in class. Time to go down to the exercise, and here it is. I'd like you to code a select statement that lists each book's title and shows the advance, the revenue, and the difference between the advance and the revenue. So extra credit here is, what business question does this statement answer? So I give the answers to both this and this question down below, so you can go to your working files and get the lesson and scroll to the bottom to see the solution. Be sure to work these exercises. These will really help you retain the knowledge that we're going through in these lessons. It's very easy to just listen to something and think, oh yeah, that makes sense, no problem, that makes sense. And then you'll get down to the end assignment and you go, I forget how that works. In each lesson, I give an exercise, try to work it, try to get the understanding, and then later when you get the assignment, it's going to be a lot easier for you. This lesson is on sorting the results using column names. Now you can sort the result set in order by a column name using something called the order by clause. So a simple sort involves just using one column name. The order by goes at the end of the select statement, whether or not there's a where clause. Now if you do use a where clause in here, you do have to put it between the from and the order by. So the order by is always going to be the last clause in a select statement if you use it, and you'll find that you're going to use it a lot. Select title price from book, where price is greater than 20, order by title. So let's go ahead and run this example. There we are, analyzing the obsessive, dealing with behavior, gluten-free or die. So you can see A, D, G, H, it's in order alphabetically. I'm going to show you in a minute here. That's a little bit of a misnomer, but let's go ahead and just look at that by title. One thing I want you to look at too, you can't really see prices in any kind of order, and it really couldn't be. Once we have a title, there's just one title in the titles table. We don't repeat that. We don't have two books called Analyzing the Obsessive. This is not going to be in any order whatsoever. It's just in the order of the left column. It's a good formatting tip, by the way, to try to put in the left column what it is you're sorting by. Rearrange the results of your select statement. People tend to think in those terms. Let's look at another example. It is exactly the same as the first example, but I've put the magic word DESC on it. Right there. That means descending. Now I could have put ASC or ascending, but you don't need to. It is the default behavior of any sort. Ascending goes from the lowest, or if you will, lowest in the alphabet. A comes before D, comes before G. Descending reverses that. So let's go ahead and click on that. Now you can see we start with W, U, T, and there's two T's, so it goes to the next letter, W higher than R. So it's in reverse alphabetical order. Like I said, it isn't truly in alphabetical order. It's in what I like to call ASCII-betical order, because there is something called an ASCII character sequence, and it's a collating sequence. Now, one of the weird quirks about the ASCII sequence is that lowercase letters are higher in the sequence than are uppercase letters. And remember, this is case sensitive, so any lowercase letter will come after. Here, I want you to look at this conceptually. If I had a list of names, John, and then Deman, with a lowercase d, and then Bob, and if I sorted the list ascendingly without the ESC, I would have Bob, John, and then Deman afterwards, because a lowercase d is considered to come after an uppercase J. And this is how textual sorts are done. We look at the first column. If there's a tie, we look at the second column. If there's a tie there, we keep moving on down the line. So that's the way a normal sort would happen. You can put a sort within another sort. Okay, that seems a little odd. Let's take a look at how that works. I'm just going to show the book type and price, obviously from the book table. And I have no where clause here. Order by type and price. All right, what does that look like? I'm going to copy it and paste it over here. Submit the statements. And voila. I said I wanted it ordered by type. Go back to the example here. I wanted to order by type. But then I want to order by price. Well, if you look at price, 12, 21, 29, 29, 40, 42, 12, or back to 12. That's not in any order. Well, you can't separately sort price outside of the type. The books wouldn't go together. It wouldn't make any sense. You can't, just change the price on the book that you're showing over here. So what the second level of sort is doing is it's first sorting by type, business, computer books, grouping them all together, all the cooking books. And then within each common grouping, it does a sort. So within business, 12, 21, 29, 29. And within computer, within cooking group, 12, 21, 29, 40. So it's sorted within that group. And so that's the only relevance. The second column over here only has a relevance within the grouping of the first type in this case. This is very common when you look at last and first name directories. You'd see all the Smiths together. Then you'd see, Charlie Smith, and then John Smith, and then Harry Smith or Walter Smith at the end. The first name is in order, but only within similar last names. So you can do this as much as you want. You can have this order by go out as many columns as were necessary. Here's the exercise. I'd like you to code a select statement that lists each book's advance and price. Sort the information so that the price data is in descending order within each advance grouping. So you've got an ascending sort and then a descending sort within the first ascending sort in the similar groups. As always, you can open up the file for this in your working files, sorting results using column names, and you'll see both the exercise and the solution in that file. This presentation is on assignment 2. You're going to use your SQL interactive tool, Apex for Oracle, if you have Toad set up, or an implementation of Oracle SQL locally. You can use any tool you want to run the Oracle that's connected to an Oracle database. I've shown you how to set up the Apex, and that's the easiest to do. We're going to work out the answers to the following questions. Display all of the books, showing their title, price, and publication date. So you can always look at the database design diagram that's in your working files. Make sure you know what column names are on the various tables. Also, I want you to list the revenue that has been made by each book and give that a column heading of revenue. Only show books, however, that have been given an advance of more than 0. Put those results in book title order. Now, I'm going through this because as I say a sentence, in most cases, you can develop your SQL statements by just doing part of it first. Like just do this first sentence, display all of the books showing their title, price, and publication date, and get that to run. And then go ahead and add the next bit of criteria, which says also list the revenue and blah, blah, blah. So put the information on the select list for a column expression that gives you the revenue. And then move on and do the next thing, add the where clause, and then add the order by statement. So it's a good way to go through and develop your statements, especially as they get more complicated as we proceed through this course. Let's look at question 2. All of these questions, of course, are designed to give you a chance to practice the things we learned within the chapter. But SQL statements will build on one another, so as we proceed through the later chapters, you'll be expected to use things that may have been in chapters that were earlier. Question 2, list the publisher name and the city that the publisher is based in, so that the data in the results set appears in the following format. Publisher American Publishing is in Boston. So it's not going to look exactly like that because our results are coming back in a grid format, but approximately like that. So this deals with putting text expressions in your result set. We've gone through that. So the last question is, list the books that have been advanced less than $15,000. This presentation is on the assignment 2 solution. So here are the answers. Take a look at the first question. Display all of the books showing their title, price, and publication date. Let's just look at that. Title, price, publication date. So what I would have done, if I were working this statement out, I would have just done that much first. Click the Submit button. Okay, great. I've got that much working. Then I would take the next step. Also list the revenue that has been made on each book and give it a column heading of revenue. That's this part here. This is the new expression, so you put a comma between it. You see how things kind of wrap sort of funny in this window? SQL is free form. And so you can put things on new lines, just like this, an expression per line in this case. Like I said, most expressions are just the column name, but in this case we have a more complicated one. So this can make things easier to read when your select list, the columns and expressions that come after the select statement directly, when that gets long. So this can be helpful. SQL's free form this way, but you do have to have the clauses in the correct order. We have the select, we have the from, and then there's a where clause if one's needed, and then after that an order by clause. That's always the last one on there. So I'm going to run this much now. And you see that it all comes down. Now my little tool kind of flushed it to the left, but that's okay, but I wanted you to see that it would run. So you get the revenue. And what else did I ask for? Only show books who have been given an advance of more than 0. So that implies a where clause, because anytime you're going to restrict rows of information, you put criteria in the where clause to make a decision. Do I keep this row or do I get rid of it? In this case, if the amount found in the advance column on a particular row is greater than 0, then keep it. If it's not, then don't. We don't want to see it in our results. So before I run this statement, we can see we have 17 in there. I run this now, and we can see that we have only 15. I've done where advance is greater than 0, but I don't see advance listed there. And I kind of want that, what I call the warm fuzzy. And I'm going to go here and I'm going to list the advance column there as well. Run it again. Yes, advance is all above 0 everywhere. So I did this correctly. I've got a good sense that I've done the right thing. Now clearly in a million row table, you're not going to be able to list the column and get a comfort that you've done everything correctly. You'll have to work with a subset of data. Here in a learning environment, it's okay to do this. We're still not done. I said put the results in book title order. Are they now? No. Silicon Valley Startups, S-O-I-A, they're not in any order that I want them to be. Then we go back up to W. To get it in order, we have to put it in order. So I'm going to do order by. You don't have to capitalize these phrases, by the way. I do this for dramatic effect. These are the keywords in SQL, select, from, where. And these other things in lowercase are things that we're assigning. We're saying use this column or use this criteria. When I'm just typing naturally, I don't bother capitalizing these things. But here, when I think of it, to kind of make it a little clearer, I do. So I'm going to order by title. See if we can get this in book title order. Submit it. And now we can see we have A, D, F, so forth. And it's in title order. So it's much easier to read. Also, it's a good idea in general, if you're going to present this to anybody or even just present it to yourself, make the leftmost column be the first sort order. If there's multiple sorts, then the next column would be the next column sorted within this. For instance, if we sorted the price within title, if we had more than one title with the same name. In any case, I want you to get in the habit of ordering things now that you've learned how to do that. Even if I don't explicitly say so in a problem or question, I would get in the habit because you cannot count on the data being sorted on how it's stored in the database. But you can always enforce the kind of sort you want to see. So make a habit of using the order by clause. Let's look at question 2 here. It says list the publisher name and city where they are based so that the data appears in this following format. It would be publisher, and you'd have the publisher name, and then the words is in, and then the city name. It looks something like this. I select publisher, and I put that in single ticks because it's just text I want to appear on every line. And since it's an expression, I put a comma there, and then name is the column name. It's just whatever publisher name we get. And then the words is in, and then a comma, and then city. So let's go ahead and run that. Use single ticks in the select list. When you use double ticks after a column name, that becomes a heading. But this is going to appear within the select list itself. So let me wipe that out. I copied and pasted it. Run it now. And here we have publisher. Binder and Smith is in New York. All Techno Books is in Cupertino. There are better ways to get this working out, but I want to illustrate that you can do this. You can have text like this. There's ways to get this all to appear in one column, and we'll be learning about those later. So here with question 3, we've listed the books that have been advanced less than $15,000. We have the title and the advance. I want to see the advance from book. Now I said the advance has to be less than $15,000. As I mentioned before, we never put a dollar sign in here. We don't put commas in the numbers. They're just numbers to SQL. If we get into more fancy formatting for a user or for a report or something where it needs to look more proper, we're going to use a computer application or a SQL reporting tool like Crystal Reports or ReportSmith, something like that. But for here, we're not going to worry about the formatting. And now I'm ordering by title, and then I put in after that the keyword DESC, and that means descending. Are we descended here? We have title. We start with the W, U, T, T, W, T, R, S, so forth. Yeah, so everything is sorted from later in the alphabet to earlier in the alphabet. And we saw the advance as well. And we can see that our advances are less than $15,000 by simply taking a glance at them here, and every one is. This lesson is on what is a primary key. The definition is a primary key is any column or combination of columns that can be used to ensure the uniqueness of a row on a table. That means the values in these columns will ensure that this row is unique. For example, if I have a primary key as a ISBN number, as I do in the book table, well, an ISBN number is supposed to be unique, and I could use that to ensure that I'm talking about one particular book that won't be confused with any other book on the table. All of the columns in a primary key must have a value. They can't be empty. That's called null in database speak, and we'll talk about that later. For now, realize that it is simply a rule that there must be a value in a primary key, either a single column or multiple columns. Sometimes a primary key may come from a natural source or natural data, such as the ISBN number in the book table that I mentioned. Another way to get a primary key is to do something artificial. Sometimes just a numeric counter is added into the table in such a way that every time a new row is inserted into the table, it just gets bumped up by 1. Sometimes there's other artificial primary keys that are made up by a company. Like in this case, we're going to use something called an author ID to identify an author. And I'm going to show you this new table that I've added to the database here in just a moment. Sometimes we use a numeric artificial key, even when there might be a natural primary key that exists as well. This can help when making updates. Let me show you the database now as it stands. Click on the database diagram. So we had before the publisher and the book table, and I should have showed you there's a relationship there. The pub ID is in the publisher table and in the book table. And I'm going to talk more in the next chapter about the primary key and foreign key relationship. But right now, I'm going to just concentrate on primary keys. A book, PK means primary key, has an ISBN number, and we can feel pretty confident that if we know the ISBN, we know the book. And you may think, well, why can't I just use the book title? There are books with exactly the same name. I read one once called Your Money or Your Life. Well, there were 2 of them out there, and only one would have the ISBN number. That was the one that I was interested in reading. A pub ID, as we'll find out, is just an integer. It's just a number we made up to keep track of publishers. We could do it by publisher name. It's not likely to change. We're not likely to have more than one publisher with the same name. But having numeric primary keys will help us in large tables with performance issues. By performance, we mean speed, when you join information together in tables. Over here, I've added the author table. Now, the author table, I don't have it relating to anything yet, but we will get there in the next chapter. Right now, it's just going to be a standalone table, but clearly, we're going to have to get authors to relate the book somehow, and we'll be doing that later. Right now, let's just look at the data. The author ID is the primary key. It is a numeric value that is unique on the table. And what we're saying is no other author can have the same author ID. You can't have me and some other person have the same author ID, then we couldn't use it to guarantee uniqueness. Social Security number, SSN, short for Social Security number, used in the United States for taxation purposes. We could have used that. Theoretically, these should be unique per person. But there's a security issue with that. This number can be used in many different places, and we don't want that out and about as a primary key being used as something we input into our system to guarantee uniqueness of a row. This becomes more obvious perhaps as we get into database design and as we do more statements throughout the class. But for now, this could have been what they call a candidate key for primary key. We could have chosen it, but we chose to do a numeric, it's just an integer, primary key for the author that will be unique. And when you make something a primary key through SQL, it'll enforce that. The database won't let in a duplicate value, so it's kind of nice. Here we have other information, last name, first name, phone, address, city, state, and zip. So it gives us something else to select against as we go along with the class. Move down just a little bit. You only need a primary key along with a column name to retrieve a specific cell of data from a specific row. Let's go ahead and select from the author table. And I'll submit this. And we'll see that we have these author IDs over here. And I didn't sort it in any particular order. You can see that they're unique. And if I needed to get the last name for a particular author, and I had the primary key of 930, I could say where author ID is 930 in a where clause. Get me the last name and first name. Let's go ahead and do that. I'll say where author ID equals 930. Submit. And there we go. I've got Sylvia Perry. I could have listed just the last name and first name instead of everything, but it brought me to that one particular row. Here's the exercise. Just think about this for a little bit. Say you had a table of employees, the kinds of things you would have for employees that dealt with people and people in a company. And you perhaps had a table for the various departments in the company or an organization. Try to think about what would be a good primary key choice for the employees table and for the departments table as well. You can look at this file in your working files and on the lesson here on what is a primary key. And at the very bottom, I'll give you what I think is a good solution. This lesson is on comparison operators that we use in a where clause. Comparisons between columns and values, or even columns and columns in some cases, are used to make judgments in the where clause. Recall that the where clause is where we specify criteria that will eliminate or accept rows to be shown in the results list. If a comparison is evaluated to be true, for example, is price greater than $20? If it is on that row, we return that row to the results. Otherwise, it gets ignored. Now, there are multiple operators that can be used for comparison. These are very common, like you'd see in mathematics. Equals for equality, greater than, less than. But here's how you specify greater than or equal to, or less than or equal to. We can do that as well. And there's two ways we can specify not equal. We can have a less than and greater than sign right next to each other. I prefer the second choice where we have an exclamation point equals to mean not equal. Exclamation point often indicates not in many programming languages, so I find that a little bit more common. But both will work. And we will learn some more operators. There's some very sophisticated ones that we'll learn as this class proceeds. But this will get us started, so let's start with this. Now here's some examples. I'm going to go against the author table. And I want the last name, first name, and the state that they live in. But I only want it where the state is not equal to California. And again, you put single ticks here. If it's a number, you don't put any ticks. Look down here quickly, where price equals 17. Since I'm doing a numeric comparison, you don't put single ticks in. As you'll see here in the second statement, when I'm looking at a date, I treat it like it was a string. I put it in the single quotes for comparison. We'll do that in a moment. Let's get back to the first statement. Let me copy this and paste it in the SQL window, and let's run it. Here we are. We have Tennessee, Mississippi, Oregon, Illinois, Maryland. We have everybody but California. And if we had any nervousness about did we have any California, we can just take the where clause out, submit it again, and we'll see everybody, including the people from California. So that worked pretty well. Let's start with this next example. I want the publication date for each book title from the book table. Now I'm going to say where pub date equals this, and this is the native format that we're going to use here. We're going to use 2120615 as a native format way to deal with dates. This is how it works in Oracle Apex. Order by title. Let's try that. Copy that out, and I will put that over here, and I will run it. So there we are, pub date 2120615. So we see that they're equal. We can do greater than and less than as well, and it will use the date. It'll know to do a true date comparison. So you can see that these dates all come past 615. I didn't say greater than or equal. If I said greater than or equal with a date, it would understand it as a date, and it gives me the dates as well that we had before. So it's very powerful stuff. We'll see as we learn more about data types in the database that dates are handled in a special way, and they do a lot of the work for you. It figures out where it lands on the calendar and will sort and compare things correctly. In this case, we sorted it by title, and we have the A, the F, and so forth, and it's in the proper order we were expecting. Move down to the last example here. Copy that and paste it. Select the title of price from book where the price is greater than or equal to 17. So we can see, even though we have decimals here, it's doing a true numeric comparison. And so we got the book that costs $17, or the price is $17 exactly, because we put the equal sign there. If we took that out, that book will disappear from our list, and we would only get those that are greater than that. And again, I put it in title order. Like I said, it's always a good habit to get into. Let's take a look at the exercise now. Code a select statement that shows book titles and the advance paid, but only show books that have been given an advance of $7,000 or less. In the working file for this lesson, you will be able to scroll to the bottom of the page to see the solution. This lesson is on logical operators. Logical operators are used to deal with having criteria being specified on multiple columns. So far, we've only used things like where price is greater than 20 and that sort of thing. But if we wanted to ask two questions, price is greater than 20 and the advance is greater than 5,000, we need these logical operators to be able to put that together. A very common thing is to look for someone's name. If I'm looking for Cindy Hunter, I have to look for an author whose last name is Hunter and first name is Cindy. Both need to be true to pull that author back. So we need the AND logical operator. What that implies is all conditions must be true in order for a row to be returned to the result set. We have to have someone who has a first name of Cindy, and they must also have the last name of Hunter. If either one of those conditions is not true, then we reject the row. It's not something we're looking for. Let's look at this example. And here it is written out. Last name, first name, city, state, last name Hunter, and first name Cindy. Let me copy this statement out here and paste it into the SQL area. And I'll go ahead and submit this. We see, there it is. Cindy Hunter, Palo Alto, California. One result. Pretty much what we expected. Clear that out. And we'll go down. Another often used logical operator is called the OR condition. What that implies is that at least one of the conditions on either side of the OR must be true. They both can be true, one side or the other can be true, and if that's the case, then the whole thing is considered to be true. If they're both false, of course, then the row is rejected. It's not true. So let's look at this example. I might want to see all of the authors who live in California and the authors who live in Utah. So I say either in California or Utah. So here I have this select statement, and I'll paste it over here. And we see last name, first name, city, from author, state equals California, or state equals Utah. Now remember, the where clause is used to restrict rows. The SQL statement is looking at every row individually and making a decision on whether that comes back to the result set or not. So it looks at row number 1 and it looks at the state column and says, is it California? Oh, true, good, return it. And if it says, oh, is the state equal to Utah? Oh, good, true, return it. Now, if it's not California or Utah, if it's not either one of those, it won't get returned to the result set. Let me go ahead and run this. And we can see that we have Utah and California, and we have no other state. So we've got 17 rows returned from the author table, Utah and California-based authors. One thing you need to be careful about is sometimes there's confusion between translating English into SQL. Someone who might have wanted this information, they might have asked the question like this. Show me all the authors in California and Utah. Well, they used an and when they described it. But just because something is an and in a sentence doesn't mean that you use an and in the statement. Clearly, an author is not going to live in California and live in Utah. When someone says wants to see the California and Utah, generally what they mean is I want to see California authors and I want to see the Utah authors as well. And to get that to be true, since we're evaluating the rows line by line or row by row, we have to use an or because either one is true and then we get a return. Okay, so that's something to be careful of. Don't automatically assume that an and in English means an and in SQL. Clear that out and we'll go down. The last logical operator to concentrate on is something called the not operator. And essentially, it negates everything that it found before. So if you look for a certain set of conditions and then you stick a not in front of it, it essentially says, give me everything but that. You found something? Now I don't want any of that. I want the other rows. For example, with the condition we just had, we were looking for authors where the state was California or Utah. Now if you put it in parentheses, what happens is the SQL statement works just as before. It first finds the California authors and the Utah authors. But because we have the keyword not in front of it, it then throws those away and gives us everything else. It's the opposite, essentially, of what we asked for. And we'll go ahead and run it. We got Illinois, Maryland, Tennessee, Minnesota, everybody but California or Utah. The parentheses are very important here because the not applies to this whole condition being evaluated. If I didn't have the parentheses, the not would only apply to state equals California. And that's kind of confusing. In fact, I want to show you something about nots and ors that's very important. This is a big warning. Don't mix nots and ors in the following manner. Don't say where not state California or not state equals Utah. An equivalent way to say that would be, we don't have to use the not operator, but we can do it this way. Where state not equals California or state not equal Utah. Those are equivalent statements. Now here's the deal. Say someone lives in California. So we come here and we look at the row and it says, is state not equal to California? False. The state is equal to California. Is state not equal to Utah? True. They don't live in Utah, they live in California. So this whole condition is evaluated to true because with an or, if one side of it's true, the whole thing is true. So if they live in Utah, they don't live in California, so it's true. If they live in any other state, then it's true that they don't live in Utah, and it's true they don't live in California, so it's true. So when you code something like this, it's always going to be true. It's essentially a meaningless criteria. If you really want to do it the proper way, you do it like this. Find it positively and put it in parentheses and then negate the whole condition. So let's go down to the exercise. For all these statements, get in the habit of sorting the results in an appropriate order. I'm not even going to give you the order. You just think about it and get used to having your results come back in a sorted way. Code a select statement that shows book titles, their price, but only show books that have a price between $20 and $30. So we're going to need to use a logical operator to pull that together. Now once you got that working, the number 2 says, show me all the rows that don't meet the criteria in option 1. Find a way to negate that whole thing. And then the last one is 3 here. Code a select statement that shows all books that have an advance of $5,000 and shows all books that have an advance of $7,000. You can look at this in the working files area, going back to the top here. It's the logical operators.html file in your working files, and the solution is near the end of that page. This lesson is on dealing with null values. What is a null? It's kind of a unique concept, doesn't have any conversational use. In terms of data in a table, a column value is considered to be null if it has no value whatsoever. Nobody filled anything in yet. You might have an employee table, and you need to add information for a new employee. Now, this employee just moved to the area and is temporarily living in a hotel. Right now, the employee has no permanent mailing address. So you still want to add the employee to your database. You add all the information that's necessary, but you don't put anything in the address. Therefore, the address columns would be null. Nulls are not the same things as blanks or spaces. They have no value at all. They're not zero. It's its own little special thing called a null. Now, the database assigns the null value to every data column that has not had any information entered into it yet. And it handles it in its own special way. It's not something we need to worry about. We're going to learn some SQL that'll allow us to interrogate whether something's null or not, but how the database management system handles it, we don't have to think about it. Why would you even want to search for a column that had a null value? Why would that ever be useful? In the above example about the employee table, with the employee who has no address in the employee table, we might need to mail the employee a W-2 form for tax withholding purposes. You could query the table to see, is there anybody left in our database that doesn't have an address yet? So we have to ask, are these columns null? We may need to do something for our business now, and we need to know where there's missing information so we can try to get it filled in pronto. But here's a conceptual example. It's conceptual because I don't have an employee table built on our database. We have last name, first name, phone number, from employee, where, address, and here's the key word, is null. And it's usually capitalized like that. You don't have to, but for dramatic effect and to point it out, I have here. So you say where it is null, and we can still do an order by last name, first name, or whatever you need. Null essentially means, conceptually, it's missing, it's unknown, it's not applicable. It doesn't mean blank or zero. Let's look at the data in the book table. I'm going to do a select table, and we should all remember how to get all the rows in a book table. All right, so here we have the results. So let's move down. And we're scanning along. We're looking at price advance and coming down and going, whoa, look at that. See the keyword null? It's in parentheses here. It's a little tiny null. There actually isn't stored in the database a little tiny word null with parentheses around it. This is just a display to indicate to you that there's a null value there. It's something that this presentation tool that I'm using puts there to indicate that it's not just a blank or something that's not filled in. It is literally a database null. So we can see there is one row of data, the psychology of social networking, where these columns, type, price, advance, year-to-date sales, and publisher date, are null. Let's go back. There is another book in the table, though, I want you to notice, called Treats and More Treats, right here. And we go over to its advance, and we see that it is 0. Well, 0 is not the same thing as null. This publishing house has made a definitive decision that they're going to give the author of Treats and More Treats a 0 advance. It's a legitimate, valid value. If we haven't yet decided what advance to give a particular book, as we saw down below, we'll go back down there again for a second, this psychology of social networking, we may want to enter the book into our system, but not fill these values in until the negotiations are complete. Different thing altogether. To find books that have a null value in the advance column, you use a statement like I'm showing here, and I'll go ahead and run it. Select title from book where advance is null. In the select list, I'm just selecting title. I don't have to show the advance. I can see that it's null, so I go submit it. And there it is, the psychology of social networking. Now we know, because we looked at the table earlier, that there is a null value in the advance field. Let's look at this another way. We can find books where the advanced does not have a null in it. The other criteria is not null. We have is null to show me the nulls. Here I want to see where the advanced does not have a null in it. So I say, in caps, is not null. Let's go ahead and run this statement. Paste it and run. And now we see we have a whole lot more books. We have 16. There were 17 total in the table. We saw the one before that had a null value. And here we see all the book titles that do not have a null value in the advanced column. Now here's another thing to keep in mind. If you specify any criteria whatsoever about a column that may or may not have a null in it, the rows with the null are automatically not returned to the result set when you do that. For example, the book table has 17 rows of data, and one of those rows has a null in the advanced column. So if you run this statement, select title advance from book where advance is greater than 0. Let's take that. I'm going to copy it, put it in here, and we'll go ahead and run it. And we see that we have 16 books returned. We didn't get the advance null at all, even though we didn't say is not null. We didn't because it's doing this comparison. Remember, a where clause, its purpose in life is to restrict the number of rows that come back to a result set. So we're asking a question about advance. We're saying show us all rows where it is greater than or equal to 0. Well, null isn't greater than or equal to anything. Nulls are not equal to anything, so it is automatically eliminated by that statement. Since a null has no value, it is never equal to anything, not even another null. A null can only be directly found by using that isNull operation I showed you. Now here's another warning. Never do something like this. Select title advance from book where advance equal null. That does not work. That will bring you nothing. Same thing here. If you do advance equals null and you put it in single ticks, it's looking for the word null sitting in the advanced column. Not likely, since the advanced column is an amount. You're not going to have text in that column, so you'll get nothing back. So you cannot use the equal sign. You have to use the is null or is not null operator instead. Let's look at the exercise. Got a few statements for you to do. The first one, code a select statement that shows the book title, their price, their advance, and their publication date, but only show books that have a price that is null. The second one, code a select statement that shows the book title, their price, their advance, and publication date, but only show books that have a price that is not null. And then the third one, same kind of deal, book title, price, and advance, publication date, but only show books that have a price that is greater than 0. And as we showed in the example before, I make a note that the answers, or the result set for number 2 and number 3, will show the same thing. This lesson is on sorting results using the column position in the select list. You already know that you can order by a column name and get the result set in the order by that column name. You can also use the position that that column or expression happens to fall within the select list itself and just provide a number. It's a shortcut for working interactively. Let's look at the statement. Select title, price, from book, where price is greater than 20, and then it says order by 1. Well, 1 represents the first expression in the select list. If we ordered by price, it would be 2. Let's go ahead and run this. I'll paste it over here, submit it, and you can see we have the title in sorted order, A, D, G, S, W. It's all looking good. If we took off the order by 1 and submitted it again, we would see that we lose that sort completely. Don't want to do that. Ordering by 1 is a shortcut way to do it. Saves you a little bit of typing. We can still use the DESC keyword with the number position, just as we did with the column name. So here, same statement, title, price, book, price greater than 20, order by 1, and then descending. Let's go ahead and run that. I'll copy it here, paste it in here, submit it, Now we see that we have a W, U, T. It's in reverse alphabetical order. The D, E, S, C worked just fine. You can also still have one sort within another sort, just like we did with the column names. So I can have price appear sorted within each unique book type. So it's from book order by 1, 2. Let's go ahead and submit that. I'm copying it and pasting it and running it. So we have the nulls floated to the top. I did nothing to restrict them. That's fine. But we have business, 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 and then 12, 21, 29. Computer, computer, 40, 42. So you can see that each price is in order within each grouping of book type for cooking and computers and so forth. So that worked just fine. I'm going to give you a warning now. Most SQL statements are eventually incorporated into a programming language. PHP, Visual Basic, or Oracle's PL SQL. It's generally considered not a good practice to use the position numbers for SQL that you're going to then move into a programming language. It increases the chance of making an error, makes it harder to maintain. Tables sometimes change, column orders change, and so it just introduces less rigor into the program and you might make a mistake. So it's recommended that you don't do that. But here we're working interactively. We're just typing in statements into Oracle Apex or some other SQL tool and running the statements. So the order by 1, 2 instead of the column name is a time saver, and it's fine for you to use it here. Just keep in mind that if you're a programmer who's going to be using SQL, you want to get in the habit of spelling out the column names. Move on to the exercise. Code a select statement that lists each book's advance and price. Sort the information so that the price data is in descending order within each advance grouping. Use the column position method in the select list in the order by. Use that method that we just learned. And the answer, of course, is at the end of this lesson, which you can find in your working files under sorting results using column position. This presentation is on assignment 3. Now use the SQL interactive tool of your choice. I've shown you how to load Oracle Apex, so that's the most likely one you'll use. But if you have another setup with Toad or some other installation of Oracle, you can use that. For this assignment, all of the questions must be answered with a single SQL statement. So don't break this up. There's more and more criteria that we're adding to our questions here, but we're going to have to add them to the statements as well. So the temptation is to think, oh, I've got to do 2 select statements to get all this information. And that's not what I'm trying to teach you. I'm trying to get you to do everything in one statement unless I specifically say otherwise. Let's take a look at the first question. Code a select statement that shows the book titles, the price, the advance paid, but only show books that have been given an advance of $10,000 or more, or whose price is greater than $30. Now, if the advance or price is null, I want to see that as well. You can do all of this in a single select statement. Same thing here with question 2. Code a select statement that shows all authors who live in Oakland, California. Also show any author that happens to have the last name of Singer. Doesn't matter where they live. I want to see that too. Question 3 is code a select statement that shows all books that have yet to set a publication date. This lesson is on the Assignment 3 solution. I mentioned that all questions needed to be answered with a single SQL statement, so let's look on how we do that. Question 1. Code a select statement that shows book titles and price, and the advance paid. I would go ahead and I would take that much. If I were coding this to do the assignment, I would have started with that. See what that looks like. Okay, we got that far. Let's look at the rest of it. But only show books that have been given an advance of $10,000. We know to restrict rows, we use the where clause, where advance is greater than 10,000. So I'd run that, and there we go. I've got 2 rows. But I also said or whose price is greater than 30. So let's try that. Or price is greater than 30. You think, well, these two are just $12.99. They're not greater than 30. But because I'm using an or, an OR is actually going to add to our result set because we have two conditions that can return a row. Remember that with an OR, either this needs to be true or this needs to be true. If either one's true or both are true, a row will be returned to the result set. Let's run it. So you can see now we have more. We have this advance isn't greater than 10,000, but the price of its book is greater than 30, so it's returned to the result set. So we have more rows, 6. In the solution there, of course, I said, if the advance or price is null, show that as well. I didn't show that, so we have another OR. Put the order by in as well this time. So we have another OR. Can you do that? You sure can. Submit it. So now I have 7 rows. This time I got the one with nulls. I've got this, or this, or this. Price is null. If any one of those conditions is true, I get a row. So I added one more row, the one with nulls in the price, by adding this other OR condition. Code a select statement that shows all authors who live in Oakland, California. All right, well, let's try that much. So I would do this part first if I were coding this for the first time. Whenever you see something that says show all authors, that means you have to give enough information so we know who it is. At a minimum, you're going to need the last name and first name to know who an author is. Now, since I said I want to see the ones that live in Oakland, California, then I'm going to also list the city and state. So I might not be explicit in all of these assignments, but put in something that makes sense. Put in a reasonable amount of information so you can see what's going on. So I get that from the author table, but here I say, where city equals Oakland, let's take these parentheses off temporarily, and the state equals California. Both of them have to be true. There might be an Oakland, Illinois, or Oakland, New Jersey. I don't know off the top of my head, but if I want to be sure I'm getting the ones that live in Oakland, California, I have to have both conditions be true. And I do that, of course, with the AND. Go ahead and submit that. So now I've got 5 rows in the results, all live in Oakland, California. So that much is good. So why did I put that thing in parentheses before? Because I had more criteria. I said also show any author who has the last name of Singer. Doesn't matter where they live. That implies an OR condition. So OR last name equal Singer. This may work out and may not. It depends on the order of precedence. Is it going to go left to right, or are ORs processed before ANDs? You know, I can never remember the rules for that off the top of my head. So I always use parentheses. I don't care if it would have worked without the parentheses. I put them in here because I first want to consider Oakland and State California. I want that to be true collectively. Then, or I want the last name to be Singer. I don't care if they live in Oakland and California. The nice thing about parentheses, even if the processing is not affected by you using them, it would have worked in the same order of precedence if you just typed it in without the parentheses. The nice thing is, you can see this in a glance, what's going on. Without the parentheses, you may think this has to be State California or last name Singer, and that's different. Is it Oakland and State California or Singer? That's not really what I want. I want Oakland and State California or Singer. Let's run it again. And this time, of course, we get a bunch more rows because I've gotten or last name equals Singer. I've gotten way too many rows. Why do I have all these things here? California. I don't want California just without being in Oakland, Santa Clara. I made a classic SQL mistake, so this is worth showing you. I put the parentheses in front of the word Oakland, and the city equaling just sitting out in space there. It's not really attached to anything. So I'm going to remove that left paren, and I'm going to put it over here. So it's city equals Oakland and state equals California, or last name equals Singer. Let's run this again. So we've got the 5 Oakland, California rows we had before, plus we have 2 Singers, Albert and Ann Singer from St. George, Utah. Let's go on, and we'll look at this last question here. Code a select statement that shows all books that have yet set a publication date. And here it is. I've chosen to put the ISBN number in my select list this time. That is the primary key, and you don't always want to see that, but in this case I thought it would be good to put the ISBN, the title, and then the publication date would be null. So I want to see that null, so I'm going to say where pub date is null. So let's go ahead and take this and run it. So here we are, one book, The Psychology of Social Networking, and null. This lesson is on what is a foreign key. You know already that a primary key is a column or a combination of columns that's used to ensure the uniqueness of a particular row in a table. Well, a foreign key is a column or combination of columns in one table that refers back to the primary key of another table. This is a relationship between primary key and foreign key, and this is what's used to connect data together from two tables. How do you know which books in the book table were published by a particular publishing company that would be found in the publisher table? Let's look at the database diagram. You can see the publisher table has a primary key, the PK, as pub ID. The book table has a primary key of ISBN number. If we go down here, there is a pub ID column in the book table, and it says FK to represent foreign key. So the value in this column relates back to the value in the publisher table that has this as a primary key. So this is how we connect the two together, and we're going to learn how to do that. Let's go back to the presentation and give you an example. There is a publisher in the publishers table that has the name of All Techo Books. And the pub ID, their primary key, is a value of 1. Let's select all the data in the book table. Select from book. I'm going to submit that. And we can see that along the columns that we have here, there is a pub ID column that has data in it. And it's got 33112223, all these different numbers. Well, the ones with 1 in them were published by All Techo Books. I am special, analyzing the obsessive. Down here, stress for success, sleep deprivation, all this good stuff. Published by that publisher, and it goes down to the last row is here as well. So if we want to get this information together, we're going to end up joining on the pub ID column. Truly, we'll be joining on the data contained in the pub ID column. Let's go back up to the top. The foreign key values in the book table get joined with the matching primary key values in the publisher table. A relational database is designed in such a way to reduce the redundancy of data stored in the database. And when someone designs a relational database, this necessitates breaking up data into separate tables. Sometimes it's not always obvious why that's done. But because a good designer will do that according to certain rules, you have to know how to get the data back together when you select from the database. So this process, as I mentioned, is known as joining. We join tables together. So knowing how to join the data between two tables is absolutely necessary in order to be able to effectively use the data in most databases. So I'm introducing joining relatively early, and I'm showing you just a little bit. And then we're going to use joining and add to the complexity of joining as this class proceeds. You simply must get that concept down. It's difficult for some people at first, but you have to get it down because you have to get this data back together, presented in most SQL queries that you would use in the real world. Moving down, here is the exercise. This is conceptual right now. If you had an employee table and a department table, what do you think would be a likely column to use as a foreign key? Which table would contain the foreign key? So consider these abbreviated versions of what these tables might look like. Here's an employee table with an employee ID as a primary key, last name, first name, phone, office number, and there'd be other stuff, but this is just to keep it simple. A department table would most likely have a department number as the primary key, the name of the department, and perhaps a location and some other information. But we'll just use these 3 columns to get started. Go ahead and work on that. When you're done, you can go back to the lesson in your working files and look at the solution at the end. This lesson is on using inner joins with the using clause. An inner join is a term that is formal, and it means the same thing as just saying join. So usually when you say, I'm going to join these tables, you, in a technical sense, are doing something called an inner join. So from here on out, I'm just going to use the word join. Some people get confused and think that a join and an inner join are two different things. They're not. So joining tables usually happens when we tell a select statement to connect a primary key column from one table to a column in another table that has matching values. As you know, that's a foreign key. Now these tables can be joined on other columns, however, if there are column values that make sense to match. So you're not restricted to a primary key, foreign key relationship. That's just the most likely relationship. Here's an example. I'm selecting the name, which is in the publisher table, and the title, which is in the book table. Now our from clause is always used to deal with the tables. We're going to list all the tables we're going to deal with in a from clause. Now when we use this join keyword, and that's the method I'm teaching you here, it's a join keyword, we put the two tables on either side of the join. I'm going to take publisher and I'm going to join to the publisher table the book table. But I've got to give it a little bit more information. There needs to be a connecting column or set of columns used to get these two together. It doesn't automatically know the way I've done it here, so we have to minimum give it the column name that they have in common. As you've seen in the database diagram, pub ID is in common between the publisher and book. I'll bring that up real quick. There it is, book table again, pub ID in the book table. Pub ID is the primary key in the publisher table. The keyword using essentially says, give me the pub ID values, match the two tables where they are equal. Just like we match the one for all techno books to the particular books that all techno books published, we can enforce this with SQL by doing it this way, a join and a using, and specify the connecting column. You still can use the order by 1, 2, that's fine. The most simple case is equality. That's what you're most likely going to use. There are other ways to join a table that we'll learn about later, but right now we're looking for things that are equal to one another. To specify the criteria, you only need to list the name of the matching column in using clause, like we just saw using pub ID. The using is a shortcut that means connect the pub ID column in the publisher table to the pub ID column in the book table, where their values are equal. Conceptually, it might be written like this. Publisher.pubid means the pub ID on the publisher table equals book.pubid. Let's look at the statement. Now, notice in the statement that I did not have to tell SQL where to find the name column. I didn't have to qualify that and say, oh, by the way, that's in the publisher table. It's smart enough to know that. Same thing with the title column. It knows it's in the book table. If there were a name in common between these two tables, other than the pub ID I'm using here and the using clause, if there were some other name in column that I wanted to list the select list, I would have to give more information to make sure it was listing the right column that I wanted to see from the right table. If there's any ambiguity with a column name, you can qualify the column names with a table prefix. For example, if the title column in the book table that we have, say it wasn't name title, say we named that column name, like book name, so then you could rewrite the last select statement like this. Select publisher.name, book.name from the publisher join book using pub ID. Everything else is still the same. So this qualification, you only use it when it's needed. In general, you could always use it, but it makes the statement unwieldy. You qualify with a period. For now, I'm showing you how to join those two tables with a single select statement. Later on in the class, you're going to learn how to join more than two tables. We're going to keep it simple for right now and get used to this idea of joining. Now, you don't have to use a primary foreign key relationship. You don't have to match those columns. You could match on any column that was in common using this using method. Select the name from the publisher table, last name, first name from the author table, and I'm going to list the city. I'm looking at the publisher table, joining to the author table, using city. Let's go ahead and look at the diagram again. The address for the author has a city column. The address for where the publisher is based has a city column. And they've got similar kinds of information, so I can join on them if it makes sense for me to do so. Remember how I said, well, if you've got a same name in two tables, you have to qualify it to remove the ambiguity? However, there's this one little funny syntax rule that says you're not allowed to qualify a column name that's used inside the using clause. So up here in the select list, I have city. Normally, you'd think I'd have to specify, well, city from which table? Is it from publisher or author? But because I'm using the city table, implies equality, it figures it out, and you'll actually get an error if you try to qualify that column. If we're not using the using clause, then you may need to qualify city. Just keep that in mind. Now, you still can use a where clause to restrict rows from the results set. In fact, you often will. You don't always want the two tables joined and want to see everything all the time. No. So here we have it again. Select name and title from the publisher, joining the book table using pub ID. We want to find out where price is greater than $20. Now the price column is only on the book table, so we don't have to give it any information. We don't have to qualify price. It figures it out. And then I have a sort of 1, 2. Let's look at the exercise now. Code a select statement that shows all the book titles published by Binder and Smith. When you're done, go ahead and open up the working files on inner joins with the using clause, and you will see the solution at the end. This lesson is on using joins with the on clause. Now, the using clause, as you've seen before, allowed you to look at equal values where column names were named the same. Looking at this statement here, select name, title, publisher, join book using pub ID. So it found where the pub ID values were equal between the publisher and the joined book, and then return that as one row of information for each match. I could have done that another way. Instead of using that shortcut way of using, there is a clause called the on clause. I could have asked the very same question, doing it the long way, so it's still the same. It's name, title, publisher, joined book, and then I had to wrap around to the next line to make this easy to read. But the keyword is on instead of using. And now I say publisher dot pub ID, which means the pub ID on the publisher's table, equals the pub ID on the book table. Order by 1, 2. Still makes sense to use the using clause instead. It's a lot simpler, and as long as the names are the same and you're looking for equal values, then that's the best way to go, I feel. What do you do when the data that you wish to match is in different column names? Then you're forced to use the on clause. You don't really have a choice because the using is a shortcut that won't help you there. So, for example, let's pretend that the pub ID, that's the primary key on the publisher table. We'll go back to the view here. Publisher is called pub ID. Let's pretend that we name that something longer like publisher underscore ID, just for purposes of this demonstration. If we named it publisher ID, we could join between the publisher and the book table using the on clause like this. Select the name, title, publisher, join book, and we'd say on publisher ID, the long name that's on the publisher table, equals pub ID on the book table. Now I don't have to qualify these column names if I'd done what I said, changed it to publisher ID on the publisher table, because there's no conflict anymore. The names are different. SQL can figure out what table they came from. Let's look at this statement again. Select name, publisher, join book on publisher ID equals book ID. Let me go ahead and run that. I want to prove that out for you. So we'll go ahead and run that. And here are the results. See how the titles are all grouped? We've sorted them that way from the various titles of books that each publisher publishes. So let's go back up, and I want to talk about a shortcut. It is kind of a big hassle to put publisher.pubid equals book.pubid, always using the table names as a prefix. And as I mentioned at another point during the class, we're going to be learning how we can join more than two tables at a time in a single select statement. So this can get very unwieldy. Fortunately, SQL provides a nice shortcut, and they are called table aliases. In the from clause is where we specify all the table names, and it's also where we specify these aliases. They can be just about anything. I say here, from publisher, I skip a space, and I just put P for publisher. Join book B. Okay, so now once I've done this in the from clause, anywhere in the statement, I can use P where I would have used publisher and B where I would have used book, even beforehand. So see, select P.name, B.title, and then down here in the on area, P.pubid equals B.pubid. Let's go ahead and run that just to see that work. You can see we still got pretty much the same statement, all 17 rows in the titles table and their various publisher names over to the left. So it works. It's a very nice little shortcut. I didn't actually have to put the P dot in front of name or the B dot in front of title, but it's always an option to do that, unless it's in a using clause, and then you don't. Let's go to an exercise. SQL does not care whether or not your joins make any sense at all. The only thing it's looking for is that the two columns you're trying to join, the data type has to be the same. And there's three basic data types. There's numbers, there's text, and there's dates. You can even have a text data type match a numeric data type as long as what's in the text data type is all numbers. And then it'll work. It'll convert them to numbers for purposes of the joining. There is a column like that. It's the zip code column. And just a little side note, the reason the zip code column is a text field in the USA, where it's all numbers, and not a number field, is if you make it a number field, the leading zeros wouldn't display for zip codes like in New Jersey that begin with 08. So to get it to display, we make it a text field, even though it's all numbers. Code a select statement that joins the zip code in the author table to the year-to-date sales number in the book table. So we're trying to find out, do we have any authors with a zip code that just happens to equal some book that has the same number of sales? Could be. Show the author's name and the book title if you get a match. This lesson is on joins and the order of processing. SQL is a declarative language. It's not like a programming language where you are required to specify the order of the logical steps that have to be taken to achieve whatever result you're trying to do with your computer program. When you need something from SQL, SQL takes care of all the logic. You have to learn how to specify the question in the right way, follow the right syntax rules, and then SQL and the database management system is going to handle everything for you. It's very nice that way. As your select statements get more and more complicated, it's a good idea to have some understanding of at least the concept of how your SQL is being processed. Again, it can help you as these statements get more complicated, knowing how you should structure a statement so things are processed in the way that you need to get the results that you need. I want to analyze the following statement. Here we've got select name, title, price, and advance. From the publisher, the name column, of course, is from the publisher table. We're joining with the book table, which has the title, price, and advance, using the pub ID. That's the foreign key to primary key relationship. Now we want to look where the price is greater than 10 and the advance is greater than 10,000. And order by 1, 2. Let's go ahead and run this and just see what we get. We just have two rows. The price is greater than $10 and the advance is greater than 10,000. So it meets the criteria the way we specified. Let's just think about how this was processed. The first thing SQL does, at least conceptually, is it looks at the from clause. And it says, what tables am I looking at here? Looks at the publisher, the book table, and it's joining using the publisher ID. Imagine, if you will, that the publisher table has 100 rows on it, and the book table has 400,000 rows on it. So we want to get our subset of data that we want to deal with down to the smallest possible thing to begin with. Now in this case, the from clause is going to just pull everything together on the pub ID. So we now have it as if it were a hidden table of its own. It's a temporary hidden result set that behind the scenes is going to behave like a table that's one table unto itself for purposes of processing the rest of the statement. The next thing it looks at is the where clause, and it applies the criteria. Essentially has to go through each row and check the price and say, is it greater than 10? Oh, this is part of an AND clause, so it also has to check the advance and make sure that it's also greater than 10,000. So if it passes that criteria, then it sends the row back to a new hidden result set that again is going to behave like a hidden table behind the scenes. But it's a new result set that accepts the row. Everything that doesn't pass this test doesn't go into that next set of hidden data, if you will. It's a buffer or a temporary table. You don't see any of this. This is all behind the scenes. Once we have this criteria applied, we've got the result set down a bit. Not everything's going to pass that criteria, especially with a large database. So now the next thing we do is we sort the data. We apply the 1-2, which is the name and the title. And then we're going to go ahead and do the select list. This is actually the last thing done. And as you'll learn later in class, there's more we're going to be doing in this select list than just listing columns the way we've done so far. But then it's going to exclude all the other columns and just show us the name, title, price, and advance. Once we have that, it's going to present the data to us as it's done here, name, title, price, and advance. You may recall that on the book table itself, there's 17 rows, and there's 3 on the publisher. So we've got it down to 2, and this gives us the last thing. Now the exercise is a bit of a joke. Lay down on a sofa, close your eyes, and visualize how SQL would process your select statements. When you wake up, you'll have become a better SQL developer. Think about this stuff. Try other statements, think about the processing, and try to get comfortable with the idea how things are being applied. Right now, it's not that important with the statements we've done so far, but it's going to become so in the near future. So if you begin to think about it now, as I add complexity to this process, it'll be easier to take the next step. This presentation is on assignment 4. Use a SQL interactive tool of your choice. I've shown you how to use Oracle Apex. You can use anything else hooked up to Oracle if you'd like. But note that all the questions must be answered with a single SQL statement. You won't need more than one to solve each of these problems. So the first question, we're in the joins area now, so everything includes a join. I want you to code a select statement that shows all the book titles published by Sunshine Publishers and all Techo books. Only show me the books if they've sold more than 5,000 books this year. The second question is to code a select statement that shows all the authors who live in Oakland, California, and they're based in the same state as at least one of the publishers in our publisher table. The select list should display the following information: the publisher's name and the publisher's city, the author's name and the author's city and state as well. This presentation is on the solution to assignment 4. So let's go ahead and look at the first question we had to work on. So code a select statement that shows all the book titles published by Sunshine Publishers and all Techo books. Okay, so we have the name of the publisher, we have the title, and we have year-to-date sales, because we only want to see the books that have sold more than 5,000 books. So we need to join. Once we're dealing with 2 tables, we have to pull them together. So the publisher table joins on the book table using the pub ID. That is the primary key on the publisher's table and a foreign key on the book table. Now we need criteria. We want the publisher to be either Sunshine Publishers or all Techo books. So we want both of those, so we need or to be used. If we used and, we would get nothing because someone's not going to have 2 publishers for 1 book. We have a rule here that a publisher can publish a book and that book can't be also published by another publisher. So we need an or. And so we do that and we put it in parentheses because we also have an and condition to deal with. We need to be required that the year-to-date sales is greater than 5,000. So we have this here. So let's go ahead and run this and see what this looks like. I'll put it in here and I'll submit it. So now we have, there it is, all Techo books, Sunshine Publishers, and we have a title, usability testing. The year-to-date sales is greater than 5,000. Are you stressed for success? 18,000 plus. So presumably, we don't have any other books with year-to-date sales more than 5,000 books for those 2 publishers. We'll clear that out. Code a select statement that shows all authors who live in Oakland, California, and also that they are based in the same state as one of the publishers. Let's go ahead and look at the publisher table. We'll see what data we have. We've only got a few rows. So clearly we have two publishers that are in California, Alteco Books and Sunshine Publishers. So those should be the only two publishers we see. The select list in the display should show publisher's name and city. Here we have the select statement with the name, that's the publisher's name, and then we have p.city, that's the publisher city, because if you jump down to the from clause, you'll see that after the publisher table name, I skipped a space and put a p there. That makes it a table alias, or a shortcut for that table name that I can use in other parts of the SQL statement. I also decided to use double quotes and give a different heading to make sure that it looked like something I could read, that I knew that I was looking at the publisher city as opposed to the author city. So now we get into the last name and first name of the author, and then the city for the author. And again, A is a table alias because over in the from clause, I have author A. So A works as an abbreviation. And then the state. Now the reason I don't prefix the state is that the state is in a using clause. And there's a rule that says if you use a column in a using clause, since we're looking for equality, there's no reason to qualify the state column with anything because it's going to be the same no matter what. So let's look at this. We got that data, author, join, publisher, using state. We want to get where the authors are in a state that's in one of our publishers. And we can see that we're looking for Oakland, California, and Cupertino and Berkeley are also in California, so we should get a hit on that. So we're also looking where the author city is Oakland and the state is California. This has to be author city. We're not looking for where the publisher city is Oakland. We haven't got any of those. We want to find the author lives there. And like what I did with the order by. I just ordered them all the way through. Name, city, last name, first name. So why not? We'll select all this. I'll copy it. And I'll paste it into here. And now I'll run the statement. So here we are. We have quite a bit. I have 5 books from the Alteco books that Oakland, California is the author city. They're all Oakland, California. That was one of our criteria. But they also live in a state where there's a publisher. Remember, the state, we looked for equality, so we know Cupertino is in California. And Cupertino is in California. And Berkeley as well. Berkeley is in California. So this makes sense to get these publishers back. This lesson is on aggregate functions. Now so far, you've used select statements that have shown detailed results. You see a row-by-row result set. It always includes any row that passes the criteria that we may have specified. But what if you wanted to see summary information on the table from all the rows? For instance, you might want to know the average price of a book that the Sunshine Publishing Company sells. You might want to know the total number of books that have been sold already for Sunshine Publishing. Fortunately, SQL provides some standard aggregate functions to allow you to see summary information. And so there are 6 standard summary or aggregate functions. So the first one you see highlighted there is the sum. This is summation, the way you sum something together in mathematics. We're going to add the values of all the columns that are specified in the column name area. So we said sum year-to-date sales, that's going to give us the total number of books sold across the whole table. So it totals the values in the specified column for all rows in a result set. The average finds the average of those columns, figures it out, adds them together, divides by the number of rows, and gives you an average. We have 2 other functions here, the minimum and maximum, that show you either the earliest or latest or lowest and highest value depending on whether we're dealing with a number or text or a date. I'll show you more on that later. Now there's 2 other ones here, and these are count functions. One counts a column name. So when you count a column name, what you're really counting are all the non-null values. Really, the rows with non-null values. As you've seen in the book table, we have 1 row that has a null price. So if we counted the price, we would get back 16 rows instead of the full 17 rows on the table. Now we don't see the rows, we just see the number, 16, because it's a summary information about the table. Now, if you don't want to look at any specific column name, and you just want a count of the number of rows that were returned, you use the count star or count asterisk, and it returns a count of all the rows in the result set. That may be obvious when we work here with a very small database. You can say, oh, that's 6. Yeah, I can count that. But if you're working with a table that has hundreds of thousands of rows and complicated selection criteria, you might not know that you're going to get 47 rows of a certain condition back. Using the count can be very helpful to get that summary information. In all aggregate functions where a column name is specified, the null values are ignored. It just pretends that the row isn't even there. It doesn't count it, doesn't minimize it, so to speak. It doesn't look for the lowest end or the highest end. It just pretends that it doesn't exist. An average function, for example, will correctly calculate the average price, if you were looking for a price, for all rows in the result set by excluding any row from the result set that has a null value in the column. I'm using the term result set a little different than I have in the past. In the past, I meant the result set is what you see. It's the result of the SQL statement. Well, here, we're still going to get the result set, but that's going to be hidden from us. And then these summary functions are going to use that to come up with the summary numbers. So all we're going to see as results, truly, are the summary information. We'll see the average, the sum, the min, the max, these sorts of things, or the count. The aggregate functions that I showed you so far, those 6 that I showed you, they are part of the standard SQL specification. However, Oracle offers many, many more aggregate functions. These are called extensions to the SQL standard. Here's a few examples. You see there's medians and variance and various other things with percentile in them. There's about 50 or so in Oracle. So if you want to research them further, you can get the current list by going to docs.oracle.com. And you search for the key phrase aggregate functions, and you'll come up with a link that's a list of these functions. This is an important warning. You cannot mix columns on a select list that would bring back detailed information with something that would bring back summary information. What gets returned from a select statement has to be a grid. Mathematically, this is called a relation. It has to be a regular grid of information. We have 3 rows and 6 columns. It can even be 1 row and 1 column. It doesn't matter, but it has to be regular. We can't get 17 titles on 1 column and then on another column just have 1 bit of information that's the average price. It violates what we're supposed to be getting back out of SQL when we select against the table. So you can't mix them up in the same statement. Go ahead and try this in Oracle Apex, and you'll get this wonderful but confusing error. Not a single group function. That's not really very helpful, but when you see this, you want to realize, oh, I've mixed detailed information with summary information, and that's a big no-no. That's what this error message in red that you'll see in Oracle Apex will bring back. What this means is, if you want to see all the titles, and you want to see the average, you're going to have to run 2 separate select statements. Now, as you know, SQL often gets put into a computer programming language. So things can be formatted there where you could see summary on the same page you saw list information. Also, there are reporting tools like Crystal Reports and ReportSmith that work with SQL. Here's something I want you to remember. When you do use an aggregate function in the select list, you will always get exactly 1 row return because it's summary information. How many rows are in the book table? 17. You don't need more than 1 row to show that. In fact, if you just ask about 1 bit of summary information, you just get 1 row and 1 column. This is always going to be true when you're summarizing information on the whole table. We're going to learn later how to summarize information on subsets of rows. Let's look at the exercise. Take the statement that I've been showing you, select title average price, and break it up into 2 select statements that will run. Then try adding a where clause to the select statement. Then after you get a select statement running with the average price, add a where clause to it and see how the average price changes based on the criteria that you've dealt with, that you've added to that statement. This lesson is on the count functions. Now there's 2 functions that count rows. The first one is the keyword count, and then we look at a specific column name. So what it does is it goes through each row in the table and it adds up columns based on the column name. However, if any of those columns are null, it skips them. It only counts non-null values in the column name. Now the next one is count star or count asterisk. and it returns a count of all the rows in the results set. And what I mean by results set, of course, is the internal tracking of all the rows in the table. Count star brings you all the rows in the table, or a count of all the rows. Again, when you use count column name, any row that has a null value in the column is not counted at all. It's like it isn't there. For example, there is one row in the 17-row book table that has a null value in the advanced column. So if we do this, select count advance from the book table, we expect to see 16 rows return. So let's go ahead and try that. I'll paste it in and I'll submit it. This is what we see. Count advance 16. The one with the null value was completely skipped. If we change that to use a count star, the nulls are not an issue at all because the count star isn't looking at any of the values in any columns. So it simply tells you how many rows were returned by the statement. And in a simple statement like this, select count star from book, it's returning all the rows. We of course could add a where clause and change that. So I'm going to go over here and I'm going to take advance. And I'm going to get rid of that and just put the asterisk in there. And we'll go ahead and run this. So here we see there are 17 rows returned, which is what we expected. Here's an example where we add a where clause to this. Now, this time I'm counting all the rows in the author table, but I'm only going to count them if the last name is equal to Singer. So let's copy that in. So I'm not going to count all the rows in the table. I'm going to count all the rows in the table that pass the criteria that I set out in the where clause. Let's put that in there, and then I'll submit it. And you can see we have 2, because there are 2 authors that have the name Singer. That's how it worked out. Works good, shows us the count. When you look at all the rows of a table using an aggregate function, you always get exactly 1 row returned. In fact, when you look at the rows of a table that are restricted by the where criteria, like we just did, you can see we get 1 row of data back. In this case, we get 1 row and 1 column. But we can do more than that. We're not restricted to 1 summary function on a row. Remember that we can't mix detailed information and summary information, but we can put more than 1 summary kind of information on a row. Let's look at this example. I have select count star and comma and then count advance. So I should get something a little different for both of those. I'm going to copy it. I'm going to paste it into the select area and then go ahead and click on it. And you can see we have 2 columns, 1 row still. It's always 1 row. Count star is 17 rows in the book table, but count advance is 16 because one of those is null. Now remember, you still can join tables with all this. In fact, most of the time with SQL, you will be joining tables. You need to get the data back together to get a meaningful query. Let's look at this with a join. Here's just a standard join. Select the name, that's the publisher name, last name and first name of the author, and the city. From the publisher table, joining on author using city. So I'm going to run that first. That's not an aggregate, but let's just go ahead and look at that first. Here we can see we have Sunshine Publishers and the 2 authors, Adams and Carson, and they're from Berkeley. So if we didn't need to see all that detailed and we just needed to have a count, we get rid of this entire select list and we just put count star there instead. Let me copy that and paste it, and I'll go ahead and run it. You can see we got a count of 2, which was obvious from the last statement where we saw the actual detailed lines themselves. Number of rows in results, 1. It's always 1 row. Let's move on to the exercise. 2 statements to code here. One is a select statement that shows how many books have been published by Binder and Smith. And then code a SQL statement that shows how many authors live in a city where a publisher is based. These 2 imply joins again. Going back to the top, you can find the count functions in your working files and see the solution at the bottom of the file. This lesson is on the min and the max functions. These functions bring back the least of something or the greatest of something. Let's look at the min function first. Here's the min, M-I-N, and then we give a column name between the parentheses. So it's going to return the minimum value found in that column for all rows in the result set. The max, of course, is just the opposite. It's going to return the maximum value, or the greatest value, found for that column for all rows in the result set. And what I mean by result set here is either all the rows in the table, or the rows that have been restricted by the where clause that are held internally, and then the max would go for those rows that have been restricted, and same with the min. The min and max functions work with all data types, such as numbers, text, and dates. For a number, the minimum value is going to return the lowest numerical value found in the specified column. For the set of rows that are being returned by the select statement, either the whole table or the set of restricted rows by the where clause, the max, of course, returns the highest numerical value. Text information, we're going to get the minimum value is going to return the lowest ASCII collating sequence order value. Remember, there is an ASCII collating sequence that determines where something falls on the priority list. B is greater than A, C is greater than B, etc. For most practical sets of summary here, or getting the minimum or max, this is going to be done alphabetically. So apple appears before orange, and orange appears before tomato. So it'll be in alphabetical order. So minimum will be the earliest in the alphabet. The max returns the highest ASCII value, so that'll be later in the alphabetical order. You'll see zebra, for example. Now for a date data type, now this is pretty cool. This is one of the really good things about SQL, is it handles date. It gets it. We don't have to do any special math to figure out where a date falls on the calendar. SQL will handle this for us. So the minimum, or the min function, returns the earliest calendar date value found in the specified column. And it does it, of course, against the set of rows returned by the select statement. The max returns the latest calendar value. Here are some examples. Let's copy and paste this. We're going to first look at a numerical example. And I'll put it in here, and I'll click the button. And we can see we have the minimum advance is 0. That's probably for a book I've written. And the max advance is $15,000. And so we don't have anybody like Bill Gates or Warren Buffett writing for our companies. Let's go ahead and take another select statement. This one is looking at textual information. So I'll paste it in here, and now I'm going to run it. And we see we have 2. We have the minimum last name is Adams, and the maximum is Suko. There's no zebras in this table, so Suko is the highest one on the alphabetic list. So now let's take a look at this last select statement, where we're going to look at a date field. I'm going to copy that and paste it in here, and now I'm going to run it. And you can see we have a minimum date of June 9th, 2012, and a maximum date of October 21st, 2012. So that's across the whole book table, looking at the published dates that I have there. Of course, the null date in there was completely ignored. And here's the exercise. Code a SQL statement that shows you which book is listed first, alphabetically, of course. That's published by Binder and Smith. This involves a join. You've got to pull back Binder and Smith, look at the books that they publish, and bring back the first one on the list alphabetically. The second exercise here is to code a SQL statement that shows how many authors live in a city where the publisher is based. So you've done that kind of join before. Do it again, and this time show us the number of authors that live in there, not the authors themselves. So as always, you can see the minimum and max functions working file and see the solution down at the end of that. This lesson is on the average and summation functions. We're going to deal with the sum function, which is going to total all the values in the column name we specified. And it'll do that for all the rows in the result set. That'll either be across the entire table or on the rows that are left after we've restricted the rows that come back in the where clause. This will, of course, ignore nulls. Nulls aren't counted as anything, so it completely skipped. Same is true with the average. The average does the same thing as the sum, but then it divides it by the number of rows that it used in the sum operation. So that gives us the average for that column name value. All non-null values for the column are specified, adds them up. Function only works with numbers. We do not add up letters or dates, only numbers. It adds the column values for the rows that passed any criteria that we might specify in the where clause. So here's an example. Go ahead and copy that, paste it, and we'll go ahead and run it. And we can see we have the summary information here. It's 95,400.00. All the advances added up together for the entire table, that's what they add up to. Let's take a look at the average function. It also considers all non-null values for the column, and then adds them up, and then divides that total by the number of rows that were added up. Again, this function only works with numbers. It only adds the column values for rows that may pass any criteria that is specified in a where clause if one's present. Otherwise, it adds up and averages for the entire table. So let's go ahead and copy this, paste it in here, and now I'm going to run it, and you will see we have an average now. That's the average advance, $5,962.50. Move on and look at the exercise. Code a SQL statement that shows the average price charged for books published by the All Techo books. Notice in the exercises, I'm always giving you conditions where you need to use a join. Number 2 is code a SQL statement to show the total number of books sold by this other publisher, Sunshine Publishers. And then when you're done, of course, scroll down to the bottom, and you will find that in your working files area, the average and sum functions. This lesson is on concatenating data. Now, to concatenate something means to link things together in a series. With Oracle SQL, there is a way to place more than one piece of information together in a single result set column. We're going to use this with concatenation. First, I want to remind you of an example we had all the way back in Chapter 2. Here we saw textual information, like select publisher, and then there was a comma, and then the name. So this is an expression. It's in a text expression all by itself, comma, the column, whatever's in name, and then another text expression is based in, comma, city, state from publisher. I want to run that. I'm going to copy and paste it, run it, and I want you to see this again. So you can see how this part of the text was in its own sort of separate result column, and then the name, Bender and Smith, Techno Books, is based in New York, Cupertino, California. What if I wanted to get all that information kind of cleanly in a sentence in one result column? Well, I can do that with the Oracle concatenation symbol. Now that symbol, the operator that we're going to use, it's what's called a double pipe. Now you see how the vertical lines are up and down? They're right next to each other. There's no space. I hit pipe, pipe. Not everybody knows where a pipe is on their keyboard. It is the capitalization of your backslash key. So you find the backslash key, there should be a vertical up and down symbol at the top. Hit the shift, hit that, and do it twice, and you'll have a pipe pipe. Now on some keyboards, it doesn't show as an unbroken vertical line. It shows as a broken vertical line. It'll have a little space in the middle of it, even though it still will be vertical. Go ahead and type that. It'll print as an unbroken vertical line or pipe. I don't know why those keyboards do that sometimes, and it's kind of confusing, but go ahead and type that, and you'll get what you need. The select statement that we just looked at can be rewritten to work like this. And this works better in Oracle Apex than in my demonstration area, so I'm going to take this over. I'm going to copy that, and I'm going to go to Oracle Apex. Here we are in Oracle Apex. I'm going to paste it in here. Oracle Apex is a little touchy about spaces and things like that, so if it sees a tab key in there, it'll give you like an invalid character. So if you get anything like that, just make sure you take anything extra out, like I'm doing right here. Select Publisher, pipe, pipe. Make this just a little bigger for you. So we got select Publisher, colon, tick. So it's still text, but now it's pipe, pipe, the name, which is the name column, pipe, pipe. Then this text expression is based in the city and the state. Now I added this little information between the city and state because they're no longer going to appear in a separate column. So let's go ahead and run this. And you can see now it all comes in one big column. It's got kind of a crummy heading. We can change the heading. My heading. I can put that double quote thing on it. Let's run it again. So publisher, Bender and Smith is based in New York, New York. Publisher All Techno Books is based in Cupertino, California. So this looks more like a sentence than to have to put everything across all those columns. I'm not saying you're going to do this very often, but the concatenation symbol can be handy for certain things. Move on down. This works well with aggregate functions as well. So I can do select average price is pipe average price from book. So I'm going to copy that, and I'm going to go back to the Oracle Apex tool. And you can see I've pasted in the statement, average price. Let's run this. And there it is, average price is, again, we got a funky heading, but that's all right. Average price is 27 plus. So you can see that work. Let's go ahead and take a look at the exercise. Code a SQL statement to show information for each author in a single result column. Follow this format here. John Smith is an author who lives in Oakland, California. Here, you want to see detailed information for the entire author table. There's no summary information here. This lesson is on an aggregates order of processing. I want to help you visualize and understanding how these statements are processed, so I'm going to talk you through an example. We have select average price, comma, and the sum of the year-to-date sales. Remember, the year-to-date sales is just a count of the books that were sold for that particular book year-to-date. Now we're going from the book table, we're joining the publisher using the pub ID. We are going to limit this discussion to where the publisher is All Techo Books. So let's think about how this is processed. So I'm going to copy and paste this. Now I'm going to get rid of first this part, the where clause, and I'm going to just put a star here. So we'll see what we get when we do this. Behind the scenes, we've got all this information. We've got information from two tables here. Pub ID, ISBN, this is all from the book stuff here. But then we've got the publisher name, address, city, and state. It's all kind of just run together. This isn't necessarily a good way to do it, but it's there. So the computer, if you will, sees this kind of temporary table, this grid of information behind the scenes. Now the next thing it does is it restricts that. It goes through and it applies the where clause. Put that in here. I'm going to run it again. And so you can see we've gotten less rows. We've gotten it now down to 5 rows of information by restricting to All Techo Books. So now what it would want to do is it would want to look at the column names. But we're not just looking at column names, we're looking at the average price and year-to-date. Behind the scenes, it is most likely looking at the year-to-date sales. Let's go ahead and run this. And it's reduced the result set to this. Here, if there were any nulls in here whatsoever on price or year-to-date sales, it got rid of them. It tossed them out. I don't think there was in this example, but if there was, they would be gone. So now, once we're down to this level, now we're going to do the summing. We're going to get the average price. That means we'll add all these together and divide by 5. And here we'll just add all these together and get a sum. So we'll go ahead and add that back. Average. And then the sum. And close it off. And now I'll run the statement as is. And you can see we have the average price now and the sum year-to-date sales. So I'm going through these processing lessons, and I'll have some more as we get more and more complex with the selection criteria in later lessons. But it's important sometimes to really know how to ask the question and where to put things to understand how it's being processed so you get what you're really looking for. Remember, we're dealing with a very small database here, so we can just look and kind of get a feel for it. But in the real world, that's not necessarily going to be the case. You may have hundreds of thousands of rows of data, so you need to become very comfortable that you're asking the right question in a way SQL needs it to give you the information that you need. So let's move on. Take a look at the exercise here, and there is no specific exercise. I just want you to keep in mind these principles of how these statements are processed. These summary or aggregate functions will get a bit more involved as we learn how we can divide the table into subsets of data and process summary information on subsets, not just on the whole table. This lesson is on Assignment 5. Now use your interactive SQL tool like Oracle Apex or some other tool you have set up to answer the following questions. All of these questions can be and must be answered with a single select statement. Here's the first question. It is the only question. Code a select statement that shows the average advance, the total number of books sold, and the number of books being published by the Sunshine publishers and also Techo books. Use a join, get all this information together, and give all that summary information. I'm giving you good practice with the summary information because we're going to continue to use it throughout later lessons as well. Go ahead and give that a whirl, and then you can look at the solution. This lesson is on the Assignment 5 solution. You used your Oracle Apex or some other tool to run SQL and answered this with a single select statement. You were to code a select statement that shows the average advance, the total number of books sold, and the number of books being published by the Sunshine publishers and all Techo books. Let's take a look at this. We've got the average advance, the sum year-to-date sales, that's the total number of books, and the count star is the number of books being published by Sunshine and Techo books. We've got 3 bits of summary information. We, of course, have the standard join we've been doing. We're going to get more complicated in the near future, but right now the book joins to the publisher table using the pub ID, and then we apply where clause, where the name equals Sunshine Publishers or the name equals all Techo books. Because even though we said we want and all Techo books, we need an or to get both things to come in our result set. So let's prove it. Copy this, and I'm going to run it over here, submit this statement. And there it is, 5581, change, 53602, and there are 11 rows in the result set. There's more than 11 rows between the book and the publisher, but when we eliminate it with Techo Books and Sunshine, we get 11.
Subscribe now and press the bell icon. Never miss an update.
This lesson is on many-to-many relationships. Now, the relationship between a primary key and a foreign key is what's generally used to connect the data from 2 tables. The relationship it enforces is called a one-to-many relationship. So as you've seen, there's been 3 publishers listed in our publisher table, and for each one of those publishers, there's a number of books that they're publishing that are in the book table, and they're connected together by using the pub ID column. That's how we get those 2 together. Conceptually, again, this is a one-to-many relationship because one publisher can publish more than one or many books. That's kind of database speak. When we say many, we basically mean 0, 1, or more than 1. Now, it's not true in our database that one book can be published by more than one publisher or many publishers. We've got it set up where a book can only have one publisher. It's not a many-to-many relationship, it's a one-to-many. But there is a concept of many-to-many, so what would be classified in that way? Let's look at the relationship between author and book, just conceptually. Can an author write more than one book? Sure, if I write a book, no one says I can't write another one. If we want to put it in the database, we've got it. I've written more than one book. Can a book be written by more than one author? Sure, it's done all the time. Sometimes you have 2, 3, 4, or more people working on a book together, and they both get credited as the authors of the book. Since the answer to both questions is yes, this ends up being a many-to-many relationship. One author can write many or more than one book, and one book can have many or more than one author. So the question is, how do we enforce this relationship in the database? It's not as obvious as you might think. You might think, okay, cool, well, I know about these foreign keys, right? So I can just stick an author ID column in the book table, and I can put an ISBN number in the author table, and those just sort of like point to each other. But we have to remember that we're using a relational database. And the most important thing in a relational database, the reason data is broken up the way it is to begin with into all these tables, is we're trying to reduce data redundancy. We don't want to repeat things. If we have an author's first and last name in an author table, we don't want that first and last name to be anywhere else in our database. If we need the first and last name of an author, we can just join that table to whatever query we're making, so we can get at it. The idea is if we carry that information in more than one table in our database, if we ever have to make an update, John Smith changes his name to a hyphenated name when he gets married and wants it changed in the database, we have to find where he's John Smith in the author table and then any other reference as well. It just introduces more possibilities for data inconsistency. So that's one of the big things about a relational database. We try to restrict redundancy to this primary key, foreign key relationship. So it's the foreign keys that repeat, but we don't repeat everything else about them. Here's an abbreviated data example of an author who's written 3 books. So I've got an author ID, and he's 173, same guy. An ISBN number, they're all different. These aren't real ISBN numbers, I just put them in here to make it easy to type in, loosely following the format. And then a social security number, same on each row, right? Last name, his last name doesn't change because he writes a different book. Well, already you can see we're repeating a lot of data. For every book that John Smith has written, we repeat his first name, his last name, his social, and the author ID. You'd expect that, but certainly not the last name. So all this data is being repeated within one table, so we have to change it everywhere on all these different rows. So that violates the principle of reducing data redundancy. Let's see how we get out of this. This is pretty much what I just said. In that new author table, I have to repeat everything, and it's just not good. Let's go down, and I'm going to break up that author table into 2 separate tables now. So you can see here, I have an author table, and I have a book author table. And this is abbreviated. I'm not carrying all the information that you've seen in the tables, but this is enough to give you the idea. My author table is just like before. I have an author ID, I have a social security number, last name and first name. Now the book author table contains an author ID and an ISBN number. So I have 3 rows here for each book that author 173 has written. I have the ISBN for that book, but I only have the author information listed once, John Smith and the social. So I can join these tables together to get the information about books. In fact, I'm going to have to join the ISBN number over to the book table that we have to get information about the titles of the books. So this lets me put all the information together, but it solves the problem of not having to repeat John Smith and the social every time he writes a new book, and this preserves the relationship. So this allows me to put the author information, the social and last name, etc., in just one table. If I need to see how many books the author has written, I can just join the 2 tables together on the author ID column and count the rows. You get 1 row for every book that this author has written. Let's look at something else. I've now got 3 tables going here. I've clipped off the top here, but that's the author table. And here's the book author, and here's the book. I did this a little differently now. I still have author 173, John Smith, but I've added author 190, who is Mary Jones. Here's the book author table. So I've got 173, 173. So John Smith has written 2 books in this database, and 190, which is Mary Smith, has written 1. Look down at the book table now. See how this relates back? 1032, 1032, 1035 here, 1035, and 206 to here. So this gets all the information back together. You may have noticed that with the column names up here, I have the little PKFK symbol. That is indicative of a primary key and a foreign key. So you're thinking, okay, well, how can we be both a primary key and a foreign key? The truth is, the primary key of the book author table is the combination of these 2 columns. It's the author ID and ISBN number together that make up the primary key. Obviously, it can't just be the author ID because I need to repeat that for every book. It also can't be the book ID because potentially I can repeat that for a book that has more than 1 author. So we need the combination to be the key. It's always true that when you have this table in the middle, this is called an intersection table, the primary key of that table will be the combination of the primary key of the 2 associated tables. This begins part 2 of our discussion on many-to-many relationships. So we left with the 3 tables showing the author table, the book author, and the book. And you can see how the primary key of the book author table is the author ID and ISBN number. The foreign key aspect is just the 1 column of author ID is a foreign key back to the author ID on the author table. And the ISBN is a foreign key back to the book table. So we preserve one-to-many relationships, but to get a many-to-many relationship to work, we have to invent a brand new table in the middle of them, called an intersection table. I've heard this table called multiple things over my career, sometimes a bridge table, association table, a resolution table, but we're going to use the term intersection table here. Conceptually, we have a many-to-many relationship. So if we were to draw out a logical database diagram, we'd have crow's foot on both sides and no one-to-many shown. But to implement this into the database, we have to do this business of putting the primary keys of the associated tables into the intersection table. Now that we've got this new table that represents the relationship between book and author, there are new attributes that can be discovered that only make sense to be on the book-author table. There are certain things about the relationship that are characteristics of it, not characteristic of author or not a characteristic of the book. For example, if I wrote a book with Bill Gates, whose name do you think would be listed first on the book? Bill Gates would be in position number 1, and I would be in position number 2. No surprise there. Would I always be in position number 2? Not if I write a book by myself. Then clearly there's only one position, so I get number 1. It's not a characteristic of an author to be number 2. It's a characteristic of an author on a particular book to be number 2. Say we're breaking up the money. I write a book with Bill Gates. Do you think we're going to split it 50-50? Probably not. Bill's probably going to get a little bit more. I gave him 95% and I get 5%. That's a royalty share. They may be different for each author. Again, if I write a book by myself, hopefully I'm getting all the royalties, but not true if I'm writing it with Bill Gates. Look at the database diagram. I've included it in the lesson file that you have in your working files, but I also have it here, so I'm going to bring it up here, a little easier to see. So this shows that I've added the book author table. I've added one table between the author and the book table. Now, if you put your hand over the book author table and pretend it's not there, but you still see the author and book, you'll see that there's a crow's foot over here for author, representing many, and a crow's foot on book, representing to many. So that's a many-to-many logical relationship. A physical relationship, when we implement the data physically on the database, to get it to work, we have to invent this other table. So there it is, the same thing with a primary key and foreign key. But here are the two new characteristics or attributes of the relationship, the author order and the royalty share that I just talked about. Now we have a one-to-many from book author to author and from book author to book. So we can implement that. We have foreign keys. The ISBN number here is a foreign key back to the primary key of the book, and the author ID is a foreign key to the author ID on the author table. You need to get used to this because this is used a lot in implementing a database. There are many-to-many relationships out there that need to be modeled this way. Now our publisher table, we didn't lose that. I just moved him down to the bottom, and we have the same one-to-many relationship that we had before. That's still there. So here's a 4-table database we've got going right at the moment. I've got the diagram here as well. And now here's an exercise. Just want you to think about this a little bit. Just think about the tables without looking at my little markings and think to yourself, what is a foreign key? We have 4 tables: author, book, and publisher. Try to do this without looking at the diagram. Think, what are the foreign keys in the author table, the book author table, the book table, and the publisher table? This lesson is on joining multiple tables with the using clause. We've seen how to do this already with 2 tables. Now we'll see how to do it with more than 2. We have information between the author and the book table that we need to get together, but we're going to have to connect through the book author table to do it. Taking a quick look again. There's the book, there's the author, there's the one-to-many relationships between book author and book author and author. So we're going to connect these together on the foreign key, primary key relationships. We have to join 3 tables together, and I will show you how that's done. We need to keep the tables in order of the relationship. So book relates to book author using the ISBN number. That's where they're equal. And then book author relates to author using the author ID number. So it's important to keep this in the proper order. You could reverse it. You could say author, and then book down here and change the using clause. but it has to be in the order. You can't put like book author first and then book and author afterwards, or it won't work. Think about the relationship. The first join, book, joins to book author using the ISBN number, and then author joins to book author using the author ID. Let's go ahead and run this, copy it, and paste it, and now I'll submit. And you can see we have a bunch of results. Analyzing the obsessive, stress for success. Whoa, what's this? We have dealing with behavior problems. We have that twice, and fresh and easy's twice, and gluten-free or die we got 3 times. Well, we don't have 3 books of that, so why did it repeat? It repeats because for every result row that has an author on it, I have to repeat the information in the results. Gluten-free or die has 3 authors, Kurt Dunhill, Michael Farley, and Ahisuko. We repeat the title information. I haven't done anything to the data back in the database. This is just selection. But this is how it works. Since the results of a select statement have to be a regular grid, called a relation, 3 columns by however many rows. If you look, I've got 24 rows, clearly more than the number of books that I have in the database. I've got about 17. We don't get gluten-free or die and then 3 authors listed in one place. No, it gets a separate result row of its own. So it's very important to keep that in mind. It's not a mistake. That's the way it has to be done to show you the information. That's the way SQL does it. Let's go back up to the top, and we'll clear that out. Another thing that I mentioned is with the author order and royalty share, those are attributes of the book author table. They are attributes about the relationship. Well, we can look at them. So I've added author order and royalty share to this statement. Let's go ahead and run this and see how that behaves. So I'll paste it in here, and now I'll run it. And you can see we have the same thing we had before, but now we see over to the right the author order and the royalty share. So one author on analyzing the obsessive gets all the money. 1.00 essentially represents 100% here. But on Fresh and Easy, Mike Lance gets 75% and Singer gets 25%. And you can see Mike is listed first and Anne is listed second in this example. Clear that. And we'll go down and look at another example. If I wanted to get it in a different order, I could put the author order after the title, and I could have it an author order number, and then the last name, first name, and royalty share. Let's try that. So 1, 2, and Fresh and Easy, 1, 2, gluten-free, 1, 2, 3. So we've got them in the way they're going to be listed on the book. So that author order sort worked just fine. I may want to see the authors first and the books they've written after that. I want to use a different perspective, so it's not a problem. Last name, first name, title, author order, royalty share. Now notice here, I can still do from book, book author, and author, or I could reverse it, but the connections have to be made the same. It doesn't really matter from the standpoint of what information or how we put it in the select list. Because I'm showing last name and first name first in the select list, I'm not required to do from author first. It does not matter, just as long as the connections are good. Copy that, paste it first, and then run it. We now have an author order number. I use the order by 1, 2, 3. I've got the author. I've got Abraham, Black, John, Blue, Maggie. And I'm not seeing the books repeat necessarily in order. Here I do. It just happens to be a fluke that Dunhill and Farley come after each other in the alphabet, the fact that I saw them there together. There's another author who wrote Gluten-Free or Die, all the way down here, Ahisuko. It's not in title order anymore, it's an author order now, and so if I was interested in, hey, what books has so-and-so written, I'd do it like this. Let's go back to the top here. You can join as many tables as are needed. Suppose I want to see which authors have written books for the publisher that's called All Techo Books. Well, now I need to join 4 tables, and I need to use a where clause. Not a problem. Here's name, that's the publisher name, the title, which is the book title, the last name, and first name. Publisher connects to book via the pub ID. We've done that before, but now the book connects to book author using the ISBN. The book author connects to the author using the author ID. And I only want to see all Techo books where the name is that. I don't want to see everybody. I just want to see them. I restrict that with the where clause, paste it over here, and then I will run it. And so here we are. Let's go down and look at the results. All Techo books. I didn't even need to put the name because they're all the same, but I can see it here. How to Choose a Computer, Richard Straight, 1 Hour Negotiations. You can see which authors are working for all Techo books and the books that they're writing. As I mentioned here, a good database diagram can help with this. Now, this is a very simple database. In the real world, especially if you're working for a medium to large size company, you can have hundreds of tables in a large-scale database. It's important to learn these principles here when we're working with something small. Here's the exercise. 3 things to work on. Clear this out. Code a SQL statement that shows the average price charged for books written by Albert Singer. You can still use aggregates. Everything that you've learned so far, you can continue to use. We've done nothing that prevents you from using any of the earlier topics. Now, number 2 is to code a SQL statement that shows the total number of books written by Michael Fari. And the third one is, what are the least number of books an author would need to write to be the author with the most number of books written? That's a little bit tricky. Think about that one a little bit. The answer is easier than you might expect. This lesson is on joining multiple tables with the on clause. Now, I almost always use the using clause since what I'm looking for is generally equality on columns that have the same name. So if the database is designed properly, you'll have more situations that are like that than are not. However, not all databases are modeled completely correctly. We may need to use the on clause when the column names are different, even though they represent the same data. Or another use is if you need to join on a compound condition. Say I need to get the author and publisher table together, and I'm looking for where the authors live in the same city and state as the publisher. So I've got the author's social security number, city, and state. Now notice I'm using table aliases here. I have author A and publisher P. So I have A city and A state because I want to just show them from one table, not from both. Since they're going to be equal anyway, it should be the same information, but I still need to make that determination up there. SQL's not smart enough to say, hey, they're the same, what the heck, you don't have to tell me. You do have to tell it. Join, publisher, on, now is the key word. A city is equal to P city, so author city is equal to publisher city, and A state is equal to P state. So I may want to do that because, as is shown on the popular cartoon The Simpsons in Springfield, there are about 17 different Springfields in America. Many things repeat, so I want to be sure I'm referring to the correct city in the correct state. These compound conditions you've seen used in a where clause, but you can use them in an on clause as well when it makes sense. Let's look at one more example. Say this is going to be conceptual. Say your company has just acquired another publishing company, and now you have 2 author tables. We'll just call them author 1 and author 2. So you need to look for duplicate rows because some of these authors have been working for both publishing companies when they were separate. So conceptually, you would look for the last name and first name from author 1, and I call that A1, join author 2, A2. I would actually need to qualify them up here too with A1 or A2 because the names are the same. Now we say on A1 last name equals A2 last name and A1 first name equals A2 first name. Again, that gets them together on an AND condition and pulls them back into the result set. Our simple little database that we're using is fairly well designed. Column names are the same when they represent the same data, even if they're on different tables. But that won't always be true. So I made up a version of our database and gave the tables slightly different names so we can practice the on clause in a database that's not so well laid out. You downloaded all of this when you downloaded the entire database that I gave you from the file that you loaded into Oracle Apex or what other area you wanted to run this. I made up a Z version of the database diagram, so I changed the author table to Z author. And one change I made here is I took out the author ID and I made the social security number the primary key. Not usually a good idea, but I did it here. Instead of a book author, I have a Z book author, And I still have an author ID column, but this time it actually contains the social security number. So it's the same data, but with different names. The book table I left alone, as I did with the ISBN number. But down here, the publisher, I added a Z publisher table, and I changed the column name from pub_ID to publisher_ID, so it's not exactly the same name as in the book table. This gives us enough differences so we can be forced, if you will, to practice using the ON criteria. What I'm doing here is not so radically different from what you'll find in the real world. Not everybody is the best data modeler and follows the best practices in all cases. You will find this kind of thing often enough if you're working in the proverbial real world. I'm going to hide the diagram. I've described that change to you, and here's the diagram that we were just looking at. I've included it in your working files as well. Here's the first example. We're going to select the book title, last name, first name, from book, because I left that alone, but I'm going to join to the Z book author using the ISBN, and I'm going to join to the Z author using ON, this time, author ID equals SSN for social security number. So the author ID column is in the Z book author table, but the social column is on the Z author table. The data just needs to match. SQL does not care what you use. I think we had a funny example earlier where I matched the zip code to a book count or something like that. SQL is not going to inspect your statements to see if they logically make any kind of practical sense. As long as the data types match, it's going to work. I'm going to run this, and we can see the results here, and everything is kind of together the way we normally expect it would be when we got to use the using clause with a better designed database. That's good. Let's go ahead and let's try another one. This one gets the publisher name, title, last name, first name. On Z publisher, with a book, again, we have to use an ON publisher ID spelled out to pub ID. Because the names are different, I don't have to qualify these names on the table because there's no confusion. And if they were the same, I wouldn't use the ON clause at all. I'd use the using, just as I've done here, where the ISBN number is still the same as it was before. So you can mix and match here. I can use the ON and the using. It doesn't matter. You use whatever makes sense or whatever the SQL requires you to do. And we're doing all Techo books as it is in this database. So I'm going to copy and paste it in, and then I'll go ahead and run it. We have the Techo books and the titles and the authors. So that worked very well. Let's go on to an exercise. Using this database, which I've included in your working files, use the Z author table instead of author, the Z publisher instead of the publisher, and the Z author book author table instead of the book author. Number 1, code a SQL statement to show all books written by Sunshine Publishers. List the title and price. Number 2, code a SQL statement to show the books written by Michael Farhay. This lesson is on eliminating duplicate rows from the results. When you join 2 or more tables together, you can see duplicate information is repeated in the result set. For example, if I wanted to know all the different states that the authors lived in, I could do this. I'm going to go ahead and copy and paste this and run it. So we see the authors, but we also see the state. California, California, California. We see a lot of information. 23 rows. It would be hard just to see how many different states I had just by counting. I might have to write it down on a piece of paper. California once, Illinois, Kansas. And I'd go on and do it that way. Fortunately, SQL gives us a better way. Since I really just wanted to see the state, I could just change the statement to this. Really wasn't even interested in the authors. I just want to know about the number of states. So I'll go ahead and run this. And you can see California, 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 California. It's not very practical. Fortunately, like I said, SQL is going to give us a way out. We can eliminate the duplicate rows from the result set by using the keyword distinct. And we put that right after the select. So we have select, distinct, state. The distinctness applies to the whole row. In this case, I just have one column in this whole row, so it's pretty much the same deal as a column as a row. But I can have multiple columns in that row. and it would give me unique rows of information, not just the unique columns. We'll have to keep that in mind as we go. And Oracle has the word unique as well. You can use that instead of the word distinct. So I'm going to go ahead and run this. We just have the state repeated once. There's 8, so we have 8 different states. Our authors come from 8 different states. We can tell this in a glance now. It's pretty good. So that keyword distinct helped summarize the information that we really were looking for. We don't care about the repeats in this case. Not only can I see the distinct states, I can count them up as well. Here I saw there were 8, but say I was dealing with some other piece of data where that number could be quite large, 244 or something potentially, not with states, but with something else. I can put that distinct state inside of a count, an aggregate function. You can put one column in here. You can't do a multiple list with the distinct this way, but I can count them. It'll give me that number without having to look at the results at the very end of the statement. Let's go ahead and run this. And there you see. You have count, distinct state, 8. The number of results here was 1. Why was it 1? Because an aggregate always gives me one row of information. So one row in my results. But 8 is the number of different or distinct states that I have in the author table. You have to be careful, as I was mentioning earlier, that the distinct applies to the whole row. Basically, it applies to everything in the select list. Select distinct price gives us very different results than select distinct price, advance. Let's go ahead and run them just so you can see. Here's the first statement. And you can see we have null as the first thing. This sort of violates the rule of what we talked about earlier, which is that a null is never equal to another null. For this kind of purpose of distinction, it's going to treat them as if they are all the same. If we were dealing with a 100,000 row database and we had 4,000 rows with null on them, we don't want to print 4,000 rows in our results. For purposes of grouping this way and keeping things together, we use null as a separate, unique thing. We see the distinct prices. There's 10, including the null line. And you notice no price repeats itself. It's completely distinct. Let's go do it where we get the distinct price, advance and see how that behaves. Paste that in here. We still have that null group because we have null, null. But I've got $12.99, and I've got $12.99 again because it's got an advance. One of the $12.99 books has this advance. The other one has this. So it's the distinct grouping of price and advance that we're looking for. If we have another book that has $12.99 and $15,000 advance in our database, it won't repeat because it's the combination that's not repeating. That's what is distinct in this case. It applies to the whole row. If you want to use the aggregate, you come up and do count distinct state, and that will work. Let's go on to an exercise. Code a select statement to show the set of unique publication dates, but don't show any null values. I don't want to see anything like this. Code a select statement to show the last and first names for authors who have published books. I didn't ask to see the publisher. I just want authors who have published books. Think about that. Note, there are a few authors listed in the author table who have not yet published books. We've evidently contracted with them. We know we're going to have them write something, but we haven't assigned them to a book. So they're there. Think about how you get the right answer there. This lesson is on sorting the results using column aliases. You've seen already how we sort using column names, which is a good idea if you're going to bring the SQL statement into a programming language. You've seen how we sort by using the position in the select list, just a number, 1, 2, 3, which is great when you're working interactively. But you can also sort using the column alias, if you wish. Let's take a look at this statement. Price times year-to-date sales, and I gave it a column alias, in double quotes, of revenue. That will appear at the top of the column instead of just price times year-to-date sales. I'm getting that from the book table. I'm looking where price is greater than 20. But here I order by revenue, which is the name we put up there for the alias. And I can still use the DESC for descending. Should work just fine. So let me take that, copy it, paste it over here, and go ahead and run it. So you can see we have revenue, and it appears to be descending just fine. So that's an alternative way to sort. Just something I wanted you to know. Go ahead and try an exercise on that. Code a select statement to show the profit of a book. We use the formula price times year-to-date sales minus the advance, because we gave the advance to the author, so we haven't made any money until we pay that off. Use column aliases of profit and sort in the profit order. Be sure to eliminate any null values. The solution, of course, is at the bottom of this working file, which is called Sorting the Results Using Column Aliases.html. This presentation is on Assignment 6. Use a SQL interactive tool to run this, Oracle Apex, Toad, or whatever you've installed to run Oracle. Note that all the questions must be answered with a single SQL statement. The first question says, code a select statement that shows all the books and the authors who have written them, but only show this for the authors that are from California. Question 2 says, code a select statement that shows all the authors, the books they've written, and who the publisher is of those books. The results should appear in a sentence-like format in one result column. It would look something like this. Sharon Lockley has written a book titled I Am Special. It's in quotes, so you have to display it that way. That was published by Sunshine Publishers. So you want all the information to come out in that format. The third and last question is, code a select statement that will show the author's social security number for all the authors who live in a city and state that is the same city and state where one of the publishers is based. This presentation is on the solutions to Assignment 6. Everything can be answered in a single select statement, so let's look at the questions and answers. Code a select statement that shows all the books and authors who have written them, but only show the authors that are from California. We have the title for the books, the author's name, and I put in states. Join from book to book author using the ISBN number, and we join author to book author using the author ID number. But we need a where clause here because we only want to look at where state is California. Copy all this, paste it, run it. So there we are. They're all from California, these authors. Question 2. Code a select statement that shows all authors, the books they've written, and who the publisher is. The results should appear in a sentence-like format, like so. So here we'll have to scroll to see this. Sharon Lockley has written a book titled I Am Special that was published by Sunshine Publishers. So look at the select statement. Select first name, that's Sharon. Pipe, pipe. Put a space between first and last name. Pipe, pipe, last name. Pipe, pipe. I have a single quote and then I have a space. Has written a book titled, space, and then I have a double quote. The double and single quotes kind of run together on the display here, but it's a double quote and then it ended by a single quote, so we end the whole string or bit of text with the single quotes. But we want to wrap this title in double quotes, so I have to slip the double quote in there. Pipe, pipe, title. Pipe, pipe. Then a single quote and then a double quote again. This is the last part of the double quote we want to see. I skip a space. That was published by, skip a space, and then the single quote. Pipe, pipe, name, Sunshine Publishers. So give us a chance to use what we've seen before with the concatenation symbols in Oracle. I'm going to go over to Oracle Apex to run this for you. So here I am over in Oracle Application Express. Let's go ahead and make the print a little larger so you can see this a little better. So I've copied the statement in here, and I'm going to run it here. And we can see we have very nice sentence-like structure. Mark Hall's written a book titled 20 Meals You Can Make in 20 Minutes that was published by Binder and Smith. That is the answer to that question. Let me go back to the presentation tool. And here we'll look at question 3. Code a select statement that will show the author's social security number, or all the authors who live in a city and state that's the same as where one of the publishers is based. Here we're going to have to use an on. There's the social, a city, a state. because I gave A as a table alias for author and P as the alias for publisher table. So I get that, and I get on a city equals P city and a state equals P state. Let's go ahead and take that and we'll run it, clear that area out, paste it in, submit it, and you can see we have 2 rows, 2 different social security numbers, and the city and state that are the same. This lesson is on using the group by clause. Now so far, all of the summary information that you've seen has come from using aggregate functions that were processed against either all the rows in a table or the result set from looking at all the rows in a table. Suppose you wanted to see all the books that were sold for the entire database. You'd do something like this. Select sum year-to-date sales from book. Copy it and paste it. We get 1 row, as expected, 97,000 plus. Suppose you wanted to see how many books were sold by each publisher. Well, you could do it similarly if you used a where clause, but you would only be able to get 1 publisher at a time. You could look for the ones where Sunshine Books or something like that. Fortunately, we have something called a group by clause that will allow us to see those counts per publisher all at once. So we get multiple lines back in our result set that will give us summary information, but it'll be a summary about each set of rows, not a summary about the whole table. So the group by clause is the main thing we use to do this. So let's look at this example here. I'm selecting the name, which is a publisher name, comma, and then an aggregate function, which is sum year-to-date sales. That's on the book table. So I'm getting that from book, join, publisher, using the pub ID. Now I say group by name, order by 1. I'm going to order by the name. I'm grouping by the name, so this is saying to divide the table by publisher name. So all the different publisher names will be together. We know there's 3, because we've looked at the data before, so there's Sunshine Publishers, Alteco Books, and Binder and Smith. It'll divide it up by them, and then it'll apply the aggregate function to each set. So I'll get the year-to-date sales for each individual publisher. Let's go ahead and copy this, and we will paste it in here and run it. And there it is. We have Alteco Books, Binder and Smith, Sunshine Publishers. Behind the scenes, SQL makes a separate set of data for each publisher name and then applies the sum year-to-date sales. You see that I do have more than 1 row returned. So I sorted the results, which I didn't have to do when I only have 1 row returned, obviously. So don't need to do that. I know what you're saying. You're saying, but Steve, I thought you couldn't mix detailed information, like the name, with summary information, sum year-to-date sales. Well, that's still true if you're summarizing information for the whole table, or result set based on the whole table. But when you use the group by, the column or columns you use to define the subsets not only may be listed, they should be listed. They define the group, otherwise you won't know what applies to what. So it gives clarity to put those names there. Remember, it's not like we're repeating. When we put here, as you see in all publisher names, it isn't like Alteco Books, a listing of a single publisher. It's a group of publishers. If I had multiple ones on there somehow, I don't, of course, I would be summing them up to just show it there one time and then show the sum of the year-to-date sales per publisher. So you want them there. So here, in this example, I'm getting the average price of a book based on what type of book it is. To do that, I select type from book, group by type. I'm grouping by type, so I want to see type in the select list, and then the summary function, average price. Copy it, paste it over here, and we'll run it. And here we are. So we see down below, we've got 5 different groups. We even have a null group. As we know, nulls aren't supposed to be equal to anything else, but for practical purposes, they just sum all the nulls together and display them there. So you've got at least 1 null type, and the average price is null. But the things we care about most is the business, computer, cooking, and psychology, 4 different types of books we have. And you can see the average price for the books in those different categories. So this is good. This is what the group by is for. It's to get summary information. Now we can get rid of that null group here by putting where price is not null. That's one way to do it. I'll show you another way later. The where clause is applied first. It'll remove all the null values on price, and then it will consider grouping what's left. So let's go ahead and run this. And we see now we don't have that null group, and we have 4 rows returned. If you use a where clause, it must come before the group by. The where clause gets applied first, and then the remaining rows are grouped. Like I said, SQL's fairly free form, but the order of the clauses is important. So the where comes first, and then the group by. You can't change that around. Let's look at a mistake here, so you can see the error message. You have type price, average price, from book, where the price is not null. I'm saying group by type. I can't show price there all by itself if I'm only grouping by type. If I group by type, comma price, I could. That's a different grouping, but I could do it. But here it's a mistake. So let's go over to the Oracle Apex area and take a look at that. So I've copied the statement over here. I'm going to run it. And it says, not a group by expression. So you're going to look at your group and go, well, that looks like a group by expression to me. Well, it is. It doesn't give you a whole lot of information here in the message. You've got to know that up here, it's not a group by expression. Type is part of the group by expression, but price is not. So we'll go back to our presentation tool. Interestingly, if you happen to be working in a different database like MySQL, you may not get an error. You'll get inaccurate results. It'll put something in the price area that will be like the first or the last price that's shown in the details, but it won't make any sense. Oracle does it right, gives an error. It's not the correct way to code your SQL. Don't include anything in the select list when you use a group by, except group by columns and things that you find in an aggregate function. That's the only things that belong there. Could you use a group by without using an aggregate function? Yes. The group by would then kind of work like a distinct. Here's an example. If I select type from book and I group by type, it'll roll it all up and it'll be like saying down here, select distinct type from book. It'll give the same results. Let's go ahead and run it so you can see 5 results with the null group. And now we'll take the other statement and run that with the distinct. And you can see we get the same results, including the null group. So it behaves like a distinct when you do it that way. Now we have an exercise. Code a select statement that lists the number of books for each type of book. Include the null set in the results. And number 2, code a select statement that lists all the authors with the average advance that they've been paid for what they're doing. This lesson is on using the having clause. You've already learned that when you use the where clause, you're restricting the number of rows that will appear in the result set. You're limiting rows. Well, the having clause is used to restrict the number of groups that appear in the result set when you use the group by. Let's take a look at an example here. Here, I'm getting the average price of a book based on what type of book it is. Average price, type, from book, group by type. If I wanted to limit the price of the group, the average price, if I wanted to look where the average price is more than 25, that's the restriction, I would add the keyword having below the group by. And I would say having an average price of greater than 25. So let me copy that, and we'll run it here. And you can see that all of the average price groups are greater than 25. This one just by a little bit. There was another book in there. There were 4 categories and a null category as well that were eliminated. The business books were eliminated in this case. Notice that the null group goes away. Same reason when you look at something in a where clause, like you're looking for price greater than $20. You don't see any price equals nulls because nulls don't pass that test. So this is also a test. When you're looking at average price or average any column, if the column is null, to produce a group of nulls, it gets eliminated by that. You don't have to do anything else explicit to remove the null group. If you're going to use a having clause, it must come directly after the group by. Can't come before, or before the where, or any other place. It comes right after the group by. The group by gets applied first, divides the sets into groups, and then the having clause goes against those groups. It actually looks at the criteria of groups as if they were rows, and then it applies the criteria. Notice that I used an aggregate clause in the having. Having average price greater than 25. That's the most likely thing you're going to do with a group, because when you group data, you're generally looking for summary information on the group. Otherwise, you're just really getting another way of getting a distinct, and you might as well just use distinct. We're dealing with summary information, so that needs to be part of what we use to eliminate groups from our results. Don't ever try to put this in a where clause. You cannot use any aggregate functions in a where clause. Go ahead and look at the mistake here, just conceptually. Select type average price from book where average price is greater than 25, and I'm grouping by type, it doesn't matter. This needs to be in the having area. If I'm running an Oracle, I'll get this group function is not allowed here, which again gets you kind of confused. It doesn't tell you it's in the where clause and not the select list, but that's what you'll get in Oracle. If you happen to be running a MySQL, you get something like this, invalid use of group function. Again, wonderfully vague. Doesn't really give you the information. You'll have to kind of hunt around through it until you see what the error is. Could you use a having clause without an aggregate function? Yes, but the group clause will work like a where clause. I could say, select type from book, group by type, having a type equal computer. Okay, that's going to eliminate the groups too, because I won't even, I'll get all the other groups for psychology and business, and I'll eliminate everything but computer books. That works pretty well. However, when I do it that way, I don't get to do things like this. I can't put the title in there. If I want to see the book title and type, I don't get that. I don't have any summary information, so it's not really worth it. I can say title type from book where type equals computer. The where clause gives you a lot more flexibility for this sort of thing. By and large, you should restrict using the having clause to do things like this, to ask about summary information about groups, and make a restriction there. Let's look at the exercise now. Code a select statement that lists the number of books for each type of book for all types that have more than 2 books. Second one is to code a select statement that lists all the publishers with the total number of books that they've sold, but the totals should be under 40,000. I'm just going to look at our underperformers. This lesson is on using the having clause with compound conditions. Just as we saw when we used the where clause, we could use ands and ors to have compound bits of criteria specified to restrict rows. We can do the same thing with the having clause. We can restrict on more than one bit of criteria. Let's take a look at this group. We're going to group by the type, the book type. There's like computer and psychology books, that sort of thing. So in the group by, we put that column in our select list. This defines the group. And now we're looking at the average price of the book and however many books were sold of that type. So now in the having criteria, which is applied after we group the books, according to this, behind the scenes, the having clause uses the criteria to eliminate groups that don't meet the criteria, so we don't see them in our result display. I want books that have an average price of more than $25, and I want books that have sold more than 20,000 books. That's the sum of the year-to-date sales. So let me copy this in, paste it in here, and now we'll run this. And here you see I've gotten one row back. So there is one group, just cooking books, meet the criteria of having a price that's greater than 25 and a number of books sold greater than 20,000. This works even when you use a multiple column group. For example, here in the group by, I have type and price. In this select statement, I'm going to be grouping things by the unique combinations of type and price. So type could appear more than once as long as the price is different. So we're going to group that all together, and again getting a type, and now to get the whole group defined, we put the column names that we're in the group by in the select clause as well. So we have type, price, average price, and the sum year-to-date sales again. I've changed the criteria a little bit in the halving. I'm now looking for an average price that's greater than $10, and the total number of books sold to be greater than 5,000. So I'm going to copy this statement, put it over in the SQL window. I will hit the button, and here you can see we have multiple groups that have come back. Business $12.99, and we have business $29.99 that meet the criteria of a book greater than 10, and the number of sales of the books greater than 5,000. So they both meet that criteria, as do all the rest of the rows. So we have business and computer and cooking books that meet that criteria. Let's go on and look at an exercise. Code a select statement that lists the author name, the number of books that they've written, and the number of books they have sold. Show the authors who have sold over 5,000 books. Also show authors who have written more than one book. You'll use compound conditions to solve that. You can look at this file in your working files having with compound conditions, then scroll down to the bottom to see the answer. This presentation is on Assignment 7. Now, using a SQL interactive tool like the Oracle Apex tool I showed you, or Toad, or some other tool you'd like to use, go ahead and work out the answers to the following questions. Please note that all questions can be answered with a single SQL statement. Question 1. Show the type of book and the average price of book of that type, but only show book types that have an average price of more than $30. Question 2 says to show which types of books an author has written and how many books the author has sold of that type. In the last one, code a select statement that lists the author name and the number of books that they've sold. Show authors who have sold between 5,000 and 10,000 books. Some different criteria in each question. Work them through, get them to work, and then in the next lesson, you'll see the solutions. This presentation is on the solution to Assignment 7. Let's go ahead and look at the first question. Show the type of book and the average price of a book of that type. Only show book types that have an average price of more than $30. So we need the type and its average price. Since we're doing it that way, we have to put type in a group by, and of course it is from the book table. We use the halving clause to restrict, to only get average price more than $30. So let me go ahead and run this, copy it, and paste it in the SQL window. Now I'll run it. And you can see we have one group, a computer group. That's the only type that has an average price of their books that's more than $30. Let's go ahead and move on to question 2. This is a little different. Show which types of books an author has written and how many books the author has sold of that type. The group is a 3-column group because we want summary information about the author and the type of book. So we use 3 columns. To get all this information together, of course, I have to join on 3 tables. The author information is in the author table. The type information is in the book table. And actually, the number of books sold is in the book author table. When we count the ISBN in the book author table, that's going to get us the number because we have 1 row in that table per author per book. Year-to-date sales, of course, is in the book table. Take a quick look at the database diagram again to refresh your memory. The author ID, of course, all the author information. The book author with the 2 primary keys, author ID and ISBN together. The book table with ISBN. Publisher table down here, but we don't need it right now. Let's copy this statement. Clear out what we had before. Paste it in here. And run it. We have some results. Let me scroll down a bit. And we can see we've got all our authors here. Let's see, did we get 2? Yeah, here we do. Michael Farhay has written a business book and a cooking book. one each, but different counts on how many books were sold. Are there any other with 2? Yeah, we've got Spencer McDouglas with a business and psychology book, different counts. We've got Ann Singer, who's listed twice, cooking and psychology, and different books and different number of books sold. We're getting what we asked for, in this case, a 3-column group. Let's go back up and take a look at question number 3. Clear this out. Code a select statement that lists the author name and the number of books they've sold. Show authors who have sold between 5,000 and 10,000 books. So in this case, I'm getting summary information about authors. So I don't need the type as part of the group. I just need the author, last name, and first name as part of the group. So that's the question to ask yourself. What is it that I'm summarizing? And there's your group. So in this case, sum of the year-to-date sales. Same 3-table join, author, book. Now here we have sum, having some year-to-date sales between 5,000 and 10,000. You, of course, could have done this with the mathematical operators of looking at something of equal and greater than to 5,000 and less than or equal to 10,000, but I used the between to show you that it works here in the having clause as well. So let's go ahead and get that statement, copy it, and paste it in the SQL window, and now I'll run it. And you see we have 2 author groups. Honey Carson, Michael Farley again. That's because they've sold between 5,000 and 10,000 books. Anybody else, if we took that criteria out, we would more likely get more groups. But in this case, it's just 2. This lesson is on using the IN operator. Now, you've learned how to use logical operators like and or in a select statement. The or, in particular, can be very helpful in getting rows that match a set of data. For example, you might want to get all the authors who live in the 3 most populous states, California, Texas, and New York. So if you wanted to do that with what you know now, you might write a select statement that looks like this. Select last name, first name, state, from author, where state equals California, or state equals Texas, or state equals New York. That's not too bad. Might get a little unwieldy if you were looking at 10 different states, or state this, onward. There is, fortunately, a shortcut, an easier way to look at a list of values in an or-like fashion. So I can use the in operator here. I don't use equals. I specify in, and then in parentheses, I put a list of values that I want to be true. So this reads, from author, where state is in this list. If it's one of these guys, I want to see it. If the state is in California, or the state is in Texas, or the state is in New York. And I'm using the 2-character abbreviation, of course, because that's how the data is stored. Definitely easier than writing a lot of ors. So let's go ahead and run that. I'm going to copy that over, paste it in here, and we'll go ahead and run. So you can see I've got no authors in California or New York. Is that true? Let's go ahead and take a quick look, and we'll see if we have it there. I'm going to take out the where clause. This is a nice thing about working with a small set of data. You can go ahead and just look at everything and get a feel for it to make sure it looks right to you. So let's look at the results. Anyone from Texas? Apparently not. We've only got California authors that met that criteria. That's okay. This statement did what we asked it to do. Show us the authors that live in California or Texas or New York. Well, we had none in Texas or New York, so none came back. But this list thing is a great little shortcut. It's going to help us later on when instead of putting a list of values in the parentheses, we're going to run another select statement that will generate a list. That's called subqueries, and we'll learn about that later in class. So remember, instead of using an equal sign, you use the in operator. You put equals there, doesn't work. Everything has to be comma separated. It'll work with any data type. You can look at dates, you can look at numbers. With numbers, of course, I don't need the quotes. Remember that anytime you have a literal number, you don't put it in quotes. And as I mentioned, we will be getting into something called subqueries, where we use another select statement to generate the list that would be inside of the parentheses with the in clause. And that can be very handy. Let's go ahead and look at the exercises. Clear this out. Code a select statement that lists the number of books for each type of book for computer, psychology, and business books. I only want to see computer, psychology, and business books of that type. And you got to give me the number of books that are in computer, psychology, and business. So that implies some summary information. Looking down at question 2, code a select statement that lists all the publishers with the total number of books that they've sold for all books that received an advance of 4,000, 5,000, 6,000, or 7,000. So we're looking at these 4 values, and we want to see the total number of books for books that are in those various ranges. You can get this using the inoperator.html file in your working files area. Scroll down to the bottom of the file and see the solutions that I came up with so you can compare your work. This lesson is on using the between operator. To check a range of values, we can always use the AND operator and make sure that the value is between a low point and a high point. Here's an example. Get the title of a book, its price from book, where the price is greater than or equal to 20, and the price is less than or equal to 40. Go ahead and run that, copy it and paste it over here, and then we'll run it. And you can see that the books are all between 20 and 40. This one book is exactly at 40, but that works because we said less than or equal to 40, so that's correct. Let's look at a couple more examples. We can use other data types as well. We have text data types or date data types, so let's look at a text. So here I'm looking for the title and price from the book where the title is greater than or equal to D, and the title is less than or equal to T. So let's try that one first. Now I will run it. You can see that we've got D, dealing with behavior problems, stop and smell the hummus. Were there any T's in our books? The way to check is to go ahead and run the whole thing without the where clause. Gosh, yes, there are. There's the psychology, treats, and more treats. 3 books that start with T. So why didn't we get that? Less than or equal to T. Well, it's a little bit of a quirk. You have to be careful. When we have T and TH and TR, it's not going to be evaluated as being less than or equal to T. TH is greater than T. So the only way we would see a book is if the book was named T. When you're using something like this, you got to remember that the outer limits are defined by the next letter out. I would be looking for less than or equal to U if I really wanted to see those T books. Let's take this other select statement. We're looking at the title and the publication date, where the date is between June 15th, 2012, and it's less than or equal to June 30th, 2012. I'll copy that, paste it in, and then run it. So we see we have June 15th, 2012, a bunch of those. We have 18th, which is between those 2 dates, and the 22nd, and we have one that's exactly on the 30th. Okay, this works fine. I've not just given a partial date here. I've given the exact date, so it's looking and includes it in the range, because I said less than or equal to. Same thing with the 15th. There is another operator called a between operator that we can use as an alternative method for querying ranges of information. Now this works with all the data types as well. We use between and to get this statement to work. I've got title, price from the book, where the price is between 20 and 40. I don't actually say is. I say price between 20 and 40. That's what we had before with the mathematical range. So let's see if we still get a working statement. Copy that, paste it into here, and now I'll run it. We've got, where's my break-even point? $21.95, and we got our $40 book that we had before. So it behaves the same way using the between and the and in there. So we specify the range. These ranges are inclusive. So it's like less than or equal to or greater than and equal to. So that's the way the between works. There's no way to tweak that. It's always going to be inclusive on the ranges that you specify. One little caveat here that I'm pointing out is that while the between is a bit easier to read, if you're dealing with a large set of data, it generally will run slower to use the between. It doesn't matter if the tables are a few hundred rows or maybe even a few thousand rows, but if you start getting to tens of thousands or hundreds of thousands of rows, you're going to want to consider not using the between and using the ranges just for speed purposes. Let's use the between now with the text like we did before, between D and T, and also with the dates between the June 15th and the June 30th date. So I'm going to run those two. Let's run one at a time here. Copy it in. Submit it. Here we see the results. So we've got the D book that we had before because this is bigger than just a D, so we get it. And we don't see the T's again because we don't have a book that's just called T. TH or anything beyond just T is considered to be greater than T. Let's go ahead and run the other statement with the dates where I'm using the between method instead of the greater than or equal to. And you can see we have the same results. We have the June 15th dates, the June 18th, 22nd, and 30th, just as we did before. So life is good. It all works to use that alternative method if you want to. You must use mathematical operators, however, if you don't want the range to be inclusive. For example here, if I'm looking for prices that are greater than 20 and a price that's less than 40, I don't want to use between because it'll include 20 and 40. You might be able to do something like 20.01 or something like that if you wanted to use the between. It probably is clearer to just go ahead and do the mathematical operators. Copy this, paste it, and run it. And so you can see now, we still have the $20 books, the same ones we had before, but we don't have that $40 book included that was there before, because we only wanted things that were less than 40. Move up and take a look at the exercises. First, code a select statement that shows authors who received an advance of at least $10,000, but not more than $30,000. Then, code a select statement that shows authors who appear as the second or third person listed on a book. All these can be done with a single select statement and using the between operator. This lesson is on using the like operator for pattern matching. Now, so far, whenever you have a specified criteria, you are looking for an exact match, like you're looking for an author last name that was equal to Smith or something like that. But SQL does provide a way to match on simple patterns. For example, if I wanted to find all authors whose last name started with an S, I could use something like this. Select last name, first name from the author, where last name like S, and you put a %sign. Now notice these are between single quotes, so this is a string or textual information. So you can't use equal sign here, you have to use the keyword like, because we're looking for pattern. So let's go ahead and run this, and I'll talk more about how this works. Copy it, paste it. So you see, I have Singer, Singer, Ann Singer, Albert Singer, Marge Smith, straight last name all starts with S. The % symbol that we see over here, when it's used with a like, it has to be used with a like, not an equal, it means to consider any number of characters to be a match. So when I'm looking for last name, like S, I'm saying look for the first character to be an S. With the % sign, that means whatever comes after the S, I don't care. Consider anything a match. Doesn't matter what characters follow that S. As long as S is the first character, I want all of them. And I have that here. It matched on the Inger and the Myth and Straight and Tsuko, whatever. Doesn't care how long the word is or how many characters they have. It considers it a match, as long as we get an S at the beginning. It's another way of saying match all last names that start with S and have any number of characters after the S. You may be familiar, for those of you who worked in Microsoft Windows, you use an asterisk to match on file names. You're looking for file names that begin with F, and then you put an asterisk, .text or something. So the asterisk behaves in a very similar way as the % sign. Now you can't use the asterisk in SQL, but a lot of people are familiar with this kind of pattern matching, so I mention it. Let's see what happens when I put the % sign in front of the S instead of after it. You see, I have % sign S, and I made it a lowercase s. go ahead and run it. What this says is find any number of characters before a little s. There's a little s in Adams, because we're looking at last name here. So Adams and Douglas. So we're essentially saying, I want last names that end in s. So I just put the percent sign after the s. So let's go back down to where we were. This gives us the ending s. So essentially, I'm looking for where all last names that have any number of characters before the s. That's what the percent sign means. So I did use the lowercase s, so I would get a match. In Oracle, of course, it is case sensitive. If you're using a database like MySQL, it might not be case sensitive. Let's see what happens when I put the percent sign in front and after the s. Same statement, last name, first name, from author, last name like, percent, s, percent. I'm actually going to go over and run this in the Oracle Apex area. And here we are. So I'm going to paste the statement in. And it's good usually in Oracle Apex to get rid of any extra lines that might be in there. It gets confused sometimes. I'm looking at lowercase s. Now what this means is find any number of characters before an s, find any number of characters after an s. Let's run this. We find s at the end like we saw before. Oh, there's an s in Carson, s in Castillo, and in this version of Carson, and the ending Douglas. It said any number of characters before or after. So we got the end s's as well, because any number of characters after the s could be 0. Clearly when s is at the end, it's 0 characters after that, and it's still a match. The one thing we didn't get is anybody's last name who starts with s. I'll show you how to do that here in just a moment. Oracle does provide some functions that can help with making something behave in a case-insensitive manner. However, we're not going to learn about them until later in the class. So there is an alternative way, a simple way that we already know, that will allow us to find those names that begin with a capital S. We simply add an OR condition in here. We have last name like s, percent, or last name like capital S, percent. So that'll pick up the ones that have the beginning. The term for this percent thing, it's a wildcard character. That's the term we use for something like that. And we're going to learn another one in a moment. Let's go ahead and take this, and I'm going to paste this back into the Oracle Apex area. Here we are. That's the statement we had before. Paste it in here and take out the tab keys. So now we've got our OR statement here. So we had 5 rows returned when I didn't have the capital S. Let's see what we get now. This little thing in Oracle Apex, it limits the number of rows that come back. I'm going to bump that up. I'm going to run that. And there they are. Singer, Smith, Straight, Suko. We saw them before. So now we've got all of the last names that have an S in them in the beginning, the end, or the middle, and it doesn't matter what the case is. Suppose you want to find a specific character in a specific position. You might want to find all the authors whose phone number prefix is 836. Not the area code, but the prefix. So here's a way you can do it. You would think that you could do this. Last name, first name, phone number from author, where phone is like 836, and put the percent in front and at the end. While that will find all the phone numbers that have an 836 prefix, it would also find 836 pattern anywhere. At the end of the number, part of the prefix, it would find a number like this. See here, there's 836 at the end. So that would come back as a match, even though the prefix is 567. That's not really what we want. So there's a way to force the issue, and that's with another wildcard character. This is the underscore right here. The underscore wildcard character is looking at the exact place you put it. Wherever it's found the first, the third, the second. It says, bring me anything back from this character. There's just these 2 wildcard characters, the underscore and the percent sign. The underscore means to return all characters in the exact position in the text where the underscore is placed. Here's an example. If I wanted to match for all 3-letter words that started with C and ended with T, I'd specify C underscore T in the like area of the where clause. So I'd have like where, some column, C underscore T. It would match words like cat, cot, cut, etc. because it doesn't care what's in the second letter. It cares that the first letter is C, second letter can be anything, third letter must be T. And in this case, I'm only looking for 3-character words. That's conceptually how that works. Let's see an example of it actually working. But we're going to go back to our phone number example and the 836 prefix. So I could do this. Last name, first name, phone from author, where the phone like, tick. I have 4 underscores. It looks like one big long line, but actually I typed the underscore character 4 times. Because the way phone numbers are stored in this database is you have the area code, a space, and then the actual prefix. It's hard to see because they do all run together, but there are 4 of them there. This essentially says, match for anything in the first 4 characters. And then the next 3 characters must be 836. And then %sign says, after that, I don't care what's there. Match anything. I'm going to copy it and paste it, and we'll run it here. And here you go. You have 836, 836. Now, I may or may not have a conflict in the data if I had used the %sign on both sides. Let's go on and look at an exercise. Code a select statement that'll find all authors whose last names begin with MC or MAC. Number 2 is to code a select statement that will find books whose titles end with a question mark. Third one is to code a select statement that will find the letters ING embedded anywhere in the title of a book. And lastly, for number 4, I want you to code a select statement to find all books that have the letter OO or OM in them as the second and third letter of their type. That's the book type. It should be the second and third letter of the book type. It has to be OO or OM. And all of these can be done with a single select statement. This lesson is on outer joins. Before we get into the subject, I want to introduce 2 more tables into the database that we're using. The editor table and the book editor table. Now each book may have more than 1 editors assigned to it, and each editor may work on 1 or more books. Logically speaking, we have a many-to-many relationship between book and editor, just like we had a many-to-many relationship between book and author. Let's look at the latest updated database diagram. So I've added the 2 tables over here to the right of what we had before, because I have the relationship between book and editor that's modeled with this association table or intersection table that is composed of the 2 primary keys of the 2 associated tables, ISBN and editor ID. Together, they are the primary key on this table. Now, I didn't put any other attributes of that relationship, just simply the primary key itself. So we have one-to-many relationships to this intersection table. But this is going to allow us to do some new things. Now, here in the editor, we have an editor ID, which is not the same thing as an author ID. It's a different number. And editor does have a social security number as well, last name, first name, and a phone number. But after that, I put the editor position they might have, like managing editor or copy editor, and their salary. This will allow us to do some new things with SQL, some new columns to select on. Close that, and we'll move on. When you've joined tables, you've only returned a row to the result set if there indeed was a match. If you didn't have a match, you rejected it and you didn't bring it back. For example, here's where we matched. E for editor. Remember, we can put table aliases down here from editor E, join author A using the social security number. I'm using the social because I'm looking for where editors and authors might be the same person. The editor and author ID won't give me that information, but the social security number most likely will. So I'm going to list the editor last name and first name and the editor position when there's a match. So this is a hardwired match. And I should get 2 rows back. So let's go ahead and run this. And there you are. Mike Lance is a project editor, but Mike is also an author. And Sylvia Parry is a managing editor. What if you wanted to see all the authors? No matter what. I just want to see all the authors. I want all the names. But if one of those authors happens to also be an editor, I'd like to see some indication of that. So this is where the concept of outer join becomes useful. we change that statement a little bit. We just add 2 words to it, almost the same as it was before. Instead of just join, we have left outer join on the editor. So what this means is when you have left, that means the table to the left. Now I could bring this line up to the side of author, and author would be on the left. But it's the first table listed. And what this is saying is, the table on the left, I want everything from. Anything that matches any criteria. Now I didn't put a where clause in here, so I haven't restricted the data in any other way. I simply said, give me the authors from the author table, and do an outer join on that author table with the editors matching on the social. So the way an outer join works different from a regular join or an inner join is I get everything from the author table, but I'm only going to get information from the editor table if we happen to find a match on the social security number. If we don't have a match, I'm going to return a null. In our tool, you'll see the little word null there. How do we know? Here I'm listing the author name, a last name and a first name, and the editor position. So we're only going to see something in the editor position if there is indeed a match. If there's no match, we're still going to see the author, but we're going to have a null in there instead. I'm going to copy it and then paste it, and we'll see how this behaves. We've got all the authors. They're in order. Null, 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 null. Most tools, again, will show you a blank here. I have the little null coming out just to let you know what's really going on behind the scenes. It's not spaces. But here we see with Mike Lance and Sylvia Perry, project editor, managing editor. Those were the 2 rows we saw when we insisted on having an exact match. Here we don't insist on that, but we do get to see the position if there is indeed a match. So it's sort of like the second table, the one on the right, if you will. The last one listed is sort of optional. Show me the information if you got it. If you don't got it, just put a null there. I don't want to see the author anyway. So that's what this left outer join stuff means. This is what the left does. It gives you a priority on which table to give priority to. Now, if I reverse this, let's go to a right outer join. If I just go ahead and keep the statement and I put right outer join instead, what that says is take the second table, the table on the right, the editor table, and let's give it priority. That means I want to see everything on the editor table matching on the social to the author. And I only want to see author information if I get a match. So let's see how this behaves. I'm going to copy it, paste it over here, submit the statement, and now we can see kind of a funny thing here. I don't list an author at all if I've got managing editor, project editor, copy, copy, and here I have the 2 exact matches. That doesn't seem very useful. Probably not what I really wanted. Let's try something else. If I want to see all the editors and then some indication that the editor is also an author, I need to show the editor last name, not the author last name, and the editor first name, the editor position. And now I'm going to show the author last name if it exists. Okay, if it doesn't exist, it'll be null. And I just decided to title that column also an author. We don't have any other really good columns to put in there, so I'm just going to borrow the author last name. If we get a hit, then we know they're in both places. Now I switched the tables around. I put editor first, editor E, left outer join author, because that's really what I like to do. I am in the habit of always putting the table that wins, the one that I want everything from, I always list that first. And that way I always use a left outer join. I never use a right outer join, because I figure if I know the table on the right is the one that I want, I might as well list it over here and use left outer join. I find that less confusing just always to use the same one, but you should know that there are right outer joins and what that means should you encounter them in your code or someone else's code. So you'll see me sticking with left here. Let's see how this behaves. Paste it. And we'll go ahead and run it. And now we see something a little bit more meaningful. All the editors' names, what kind of position they have, and then we've got a null in the last name if they're not also an author. And here's our 2, Lance and Perry. Remember those from before. Those are the correct editors that are also authors. Let's go down and let's take a look at another example. So here, selecting the last name, first name, and author order. Remember, that's the order that an author appears on a book, like 1, 2, or 3, from the author table, and we're going to join with the book author using the author ID. So this is not an outer join. This is just a regular join, a simple join, or an inner join is sometimes called, but I just call it a join. I'm going to run this first. So you can see going down here, we have all the authors really, and where they fall in a book. We don't see which book or anything because we only joined to the book author table, but we see we have a bunch of information here. Let's go back and let's change this. I'm going to make it a left outer join to the author table. Again, that means we want everything from the author table and information from the book author table if we get a match. And the only information from the book author table is this column right here, the author order. So let me select this, paste it in here, and now I'll go ahead and run that. And now you see, we do have what we had before, but we've got a few nulls in here. I've got null and Marge Smith. I've got a couple of authors here that don't have any books. Might seem a little odd to have authors in the system that don't have books yet, but you never know. Someone may have been hired for a project, but they haven't been signed to anything specific. So that's what the left outer join showed us. So now we can do outer joins with multiple tables. Now I want to see the title information, so I'm going to do author, which is a left outer join to the book author table, and then book will do essentially a left outer join to the book author table. So it's like we've done before, but this time we may see more nulls. So I'm going to take that, paste it in, I'll run it. We have nulls. 1, 2, 3, 4, 5. We got 5 nulls. Last time we only had 4 nulls. I'm going to break down what we did. I'm going to break it into 2 steps. I'm going to look for author left outer join on book author. That's what we did before. And here I'm going to do book author to book. I'm going to do the second half of that join and see what we get there. In fact, here we know we get 4, so I'm going to just go ahead and jump down to this one. And I'm going to paste it in here. And then we'll go ahead and run it. And you will see I have 1 null. So that means I have this information on the book author table for an author ID. I have an ISBN, but I don't have any title out there. I don't have anything on the book table that matches this ISBN. So that's probably a hole in the database. The database would be, say, to lack integrity. You don't want to have orphans out there, things that are referring to things that aren't there. So this is one way that you can use an outer join to help look for those if you're going to clean up data in the database that may have been corrupted. I'm also going to show you a way to try to prevent orphans from happening like that with the use of constraints, and we'll learn about that in a later lesson. Here we are to exercises. So we've got 2. Code a select statement that will find all publishers and show the author's name, city, and state if they live in a city and state where a publisher is based. And these are all outer joins. Number 2, code a select statement that will find all authors whose last names begin with MC or Hunt, and the titles of the books that they've written, if they've written any books. Otherwise, display a blank. In our tool here, it shows up as a little null, but the tool you're using, it may just show up as a blank or a hyphen in Oracle Apex. As always, to see the solutions, you'll scroll down to the bottom of the outerjoins.html file that's in your working files. This presentation is on assignment 8. As usual, use the SQL interactive tool of your choice, like the Oracle Apex that I showed you how to install an account on. All of these questions below can be answered with a single SQL statement. Question 1 says, code a select statement that shows all books and all authors who have written them, but only if the book has been assigned to it and the book title begins with the letter T. We don't want to see any books that don't have authors assigned to them. In question 2, you should code a select statement that shows all the editors who have a salary between $50,000 and $100,000. List their position as well. And in question 3, code a select statement that will show the titles of all the books that have the word stressed in them, whether or not stressed is capitalized or not. This presentation is on the solution to assignment 8. Let's look at the first question. It asks you to code a select statement that shows all the books and the authors who have written them if the book has been assigned an author to it and the book begins with the letter T. So we want to see the book title, last name, first name of the author, the book. So we're doing a left outer join on the book author table and a left outer join on the author table because we only want to see the author if there's an author assigned to it. And then we further restricting with the like T %. So we only want books that begin with T. Let's copy and paste this in here and look at the solution. And here you can see we have 3 books that begin with T. The first book here doesn't have a last name or first name in it because we use the outer join and no author has been assigned to this book at this time. The other 2 books, of course, have an author, and they show up that way because it was a hard join, so we get them. The thing about outer joins, of course, is we get everything on the one side, in this case from the book table, and only the stuff to the right if indeed there is a matching row. If not, we see nulls. And again, my tool writes in the little word null just to make it clear that that's what it is and not a blank or a space. Normally you would see whatever the presentation tool wants to show you. In Oracle Apex, for example, I believe it shows a hyphen when it's null. Alright, let's move on to question 2. So code a select statement that shows all editors who have a salary between $50,000 and $100,000. List their position as well. Editors have a position like managing editor or copy editor, that sort of thing. We have the editor table that we're looking at. And we list the last name, the first name, and the editor position and the salary, because I want to see the salaries. This is not an outer join. We're not a join at all. We're just going against the editor table. I'm giving you an opportunity to practice using the between operator. Between 50,000 and 100,000. Order by 1, 2, 3. That was part of this chapter's lesson. Let's put that in here and submit the statement. And we can see that we have 4 editors here. Copy, project, copy. Will have that criteria. I believe the managing editors make a bit more money and don't fall within that range. Let's go down to the last question, question 3. Code a select statement that will show the titles of all books that have the word stressed in them, whether or not it is capitalized. So the key thing is, until we learn how to use specialized functions to sort of force a case-insensitive search, we have to deal with the case sensitivity. So I have the statement here. I'm getting the title of the book, where the title is like, and I put percent stressed, because it's lowercase stressed, or title like capital stress. So I'd be looking for that word with a capital all through the title as well. By using the OR criteria here, we'll get it in both cases. Let's go ahead and run that statement. Copy it and paste it over here. I'll run it. And here we are. Are you stressed for success? Because it was a capital letter, we wouldn't have got it had we just used that.
Subscribe now and press the bell icon. Never miss an update.
This lesson is on how subqueries work. Now, one of the key ways we use a subquery is with something called the in operator, which you've seen before. Recall that an in operator matches a column against a series of values. And we've seen this before, so let's take a look at another example. I'm looking for the last name, first name, and state in the author table, and I only want to look at the authors that are in the state Illinois, Utah, and Michigan. I use the keyword in here, so it's looking for anyone in that list. This is a shortcut you may recall for using a bunch of ORs. We don't have to say where state equal Illinois, or state equal Utah, or state equals Michigan. This is a shortcut. So let's look at that first before we move on to the subquery. I'm going to copy that and paste that and submit it. And you will see we have Michigan, Illinois, and Utah, and we have 4 authors in our database that match that. The values in that list can be generated by another select statement instead of keyed in directly to the statement like we did. If I want to find all authors who live in states where a publisher is based, I could first go look at the distinct states in the publisher table. And I'd see that they're California and New York. I would look them up. In fact, why don't I go ahead and do that? Select. I'll just do star from publisher. And then we'll submit it. And you can see I didn't even use distinct. So few here, New York and 2 from California. So that's the list. Alright, so we see we have just these 2 values. I could look them up manually like I just did, and then key them in. We're in California, New York. And that would work just fine. Let's issue that statement, paste it in here, and now submit it. And you can see we have a bunch of authors from California. We don't have any from New York. But that's okay. We don't have any from New York. SQL worked correctly. We just don't happen to have an author that lives in New York. The question was here to try to find any author who lived in the same state as a publisher, and this is the correct answer to the question we asked. Take a look at this. Instead of generating that list manually, running a separate statement, writing down and keying it in the statement, I can get this dynamically. Let's look at my in list. Now I took the parentheses, here's in, and I put them down below just to make this a little clearer. Between the parentheses, instead of a list of things, I have select distinct state from publisher. So it would just bring back California and New York. Now I don't want to do select state from publisher because, as you can see, I have a lot of people in California. I might have California repeat a bunch of times. Right now we're working with a very small table, but if we were working with a table that had tens of thousands of rows in it, you wouldn't want to ask the same question or generate a list over and over again. So the use of the keyword distinct is a good thing, so we just minimize the size of that list. What happens is, we run this statement first, and then behind the scenes it generates the list, and then it runs the whole statement. This stuff here between the parentheses is called an inner query, and the stuff that is on the outside is called the outer query, in the most simple case. So distinct, as I mentioned, could change in the real world. We could buy another publishing company who was based in Utah, then all of a sudden we would get a different answer. We might get different authors, probably would. SQL statements, when they run, they're true based on the snapshot of the data when they do run. If the data changes, you get a different answer. But that's okay because SQL is about asking the right question. When we're doing querying like this, when we're selecting, it's forming the statement to ask the right question. The answer to that question may change over time because the data will change over time. Conceptually, subqueries can be nested as deep as you want. I don't have to just have 2. I could have an inner query, and that inner query could have another inner query, and it could have another inner query. And this could go on for as long as made sense to do so. So the deepest nested select statement gets run, and it comes back with a series of values. And then it feeds that to the statement above it, and it uses it, and if it generates more values, it feeds it to the next one up the chain. So you'll see a few of these examples as we go along. It's important to remember that the values generated by a SQL statement must match the kind of value being compared to in the left in the in operator. So this is a statement that would be a mistake. I say, last name, first name, state, from author, and I say, well, let's find where the city is in the list of distinct states from publisher. Well, I don't want to compare a city to a list of states. We're never going to get a match. SQL doesn't care. SQL's not going to check our logic. City is a text field, state is a text field, and it'll try to compare them. We get 0 rows back, of course. You have to make sure you're comparing like values. Doesn't make logical sense to do it that way. Let's look at another common error when you're using subqueries. You must compare one column to a list of values generated from one column. At least that's in the simplest case. We'll learn a more complicated way later, but for now, it has to be one column to one column. So again, we're getting the names and state from author, where the city is in select city, comma, state from publisher. We can't compare a city to a city and a state like that. It's not a valid comparison. And likewise, you can't put select star in there, like get everything back and compare city. You can't compare city to everything on the row. You should just select city from publisher in that case. You want to get the proper list to compare to. Now we're ready for some exercises. Name some advantages and disadvantages to generating an in list with another select statement. Think about what would be good about this and what would be bad about this. Of course, you can go to the working file, how subqueries work, and look at the suggestions at least of what I think are advantages and disadvantages. Now we'll get a chance to practice some more of this with the in list in the next lesson. This lesson is on subqueries with the in operator. Now the in operator will always compare the values in a list for equality against the value in a column specified. Now these values must be of the same data type. You should always compare numbers to numbers, dates to dates, and text to text. Now it is okay to compare a text column to a series of numbers as long as all the values stored in the text column are numbers as well. SQL does not check your logic. The comparisons should make sense. Most often, you will be comparing the same data values, such as a city column, to a list of city values returned from another table's city column. So that would make sense. Here's how I generally like to format a subquery. I put the outer select over here to the left, select from where, and then the order by at the bottom. The inner select statement, I push in a little bit. Here I've just pushed it in a couple of spaces, but you can indent or use some other form. So it makes it a bit more obvious that this is an inner query that's going to run first before we process the outer query. This inner query will return a list. You can see here we have select distinct author ID from book author, group by author ID, having a count greater than 1. Let's look at that. I'm going to take it out of the parentheses, copy, paste it over here, and let's just run that statement by itself and see what we get. You can see we have a list of author IDs, and it's in a column, 336, 390, 609, but for our purposes, it'll be just like we typed in 336 in parentheses, comma, 390, comma, 609, comma, yada yada, and close parentheses inside of here. So that's what will really be replaced with. That's how it will behave. Now once we have replaced this select statement with what it returned when it processed, these 6 numbers down below, we'll run the outer query, which will look for the author ID in this list, one of these values. It will make sure that the author ID is equal to one of these values. Otherwise, it won't be returned to us in the result set, which is last name, first name, wrote more than one book. So that's what this is doing. I'm bringing back the author IDs from the book author table, and I'm grouping by author ID and getting summary information. I'm asking where the count star is greater than 1. So these are authors who have written more than one book. And then I use that list of those authors, and then I print out the information about the author. Notice that I use this expression here in the single ticks, wrote more than one book. So we can see how that behaves. And I'm going to run this whole statement. 6 authors down here. Let's put it all together. Paste it in there. There's the inner query. It's all together. Let's run it now. And you can see I have 6 authors. Now we don't see their author ID. We used the author ID to decide which authors we wanted to show. But we're not showing that. We're showing last name, first name, and it wrote more than one book. So you can see it here. Maggie Blue wrote more than one book. Ann Singer wrote more than one book. The way the statement, of course, is processed is what I just said. We run this inner query first, get this list, and it looks like this. And then we go ahead and run the whole thing together. You can think of it, after that select statement is run, that it's reduced, if you will, to use kind of a mathematical term, to this. I could take this whole list over here and move it right to the right of the in, and that would be fine too. But this works. Remember that SQL is very free form. It's just the order of the various clauses have to be this way. Select, from, where, order by, etc. Remember, if another row is added to the book author table that maybe added another author that has written more than one book, the results would change. That's okay. SQL's about asking the right question, or at least select statements are. There's more to SQL than select statements, as we'll see. With the subquery, you can get results from a table using information from that same table. And that's new. The inner query says, select distinct price from book, where the title is like how. In other words, the title begins with the word how. And so we get the whole thing. I'm going to take this statement, and we'll go ahead and run that part of it. We don't run it with the parentheses here. Let me clear this out and paste this in. Select distinct price from book where the title is how. Run it. You can see that we have one book, $29.99. Now I didn't get anything but the price. I don't want to see title and book here because I really just feeding a list of prices back up to this outer query. So I'm finding out whatever book starts with how, I'm getting a list of the prices, and I want to see all the other books that have the same price as books that begin with how. It doesn't have to be the same book. It could be a book that began with what that had the same price as a book that began with how. Let's run this all together, and I'll take it and I'll paste it in. Run this, and here we see analyzing the obsessive, $29.99. Gluten-free or die. They're all the same. And we can even see the book with how in it. There's only one. So we only had one price come back. If there'd been another book like How to Do 1 Hour Negotiations and it was $19.99, then we would see books as well that were priced at $19.99. Clear this. As I mentioned earlier, we can nest subquery statements. For example, if I want to see which authors sell books that cost $12.99, I can do it like this. Now this is starting to get kind of big, so let's start from the innermost query. Let's bounce down, and you see how I indented again. I had the first inner query indented a couple spaces, and then this one was indented a couple more spaces. Notice that each inner query has to end with a ending parentheses, a right paren. So I have two here because the second one goes to balance this parentheses out. You can do it either way. Some people like to bring that parentheses down below. Any format will work. I'm saying I want to see authors that sell books that cost $12.99. First, find out which books sell at $12.99, and we'll run this query. We'll run it all by itself. So I'm just returning the ISBN number because I'm going to use that. I'm passing that list up to the book author table, and that's the only thing I can compare. I can't pass a title from the book table up there because there's no title in the book author table to compare to. So I have to get this list first. So let's go ahead and try this. And we can see we have two ISBN numbers. Scroll down a little bit. This is run as we've seen. The statement then is reduced to this. It's the outer query, the inner query, and now the inner query, the most inner query, has been reduced to being these two values. So now we run this part of it. We can run it just by itself. Let's take it down here. Grab it here. I've got it pulled out. We'll run it just by itself. Put it in there, and we'll run and see what that does. So now we have a list of author IDs because that's what we wanted to find. Select author IDs. So those author IDs are these three. So now we have the outer select, which is now reduced to last name, first name from author, where author ID is in the list of these three items. 336, 845, 1022. 336, 845, 1022. Let me put that in there and I'll run it. We see we have three authors sell books at $12.99. Let's prove that the whole thing works running together. So I'm going to back up, go back to the original statement, and I'm going to copy it, and then I'm going to clear this out and paste it in here, and now we'll go ahead and run this. And now you see we have the same thing before as when I stepped through it a piece at a time. The nested subquery works. All right, let's take a look at the exercises. Here we have exercise 1, where you should use a subquery to find the books that are published by Sunshine Publishers. This is something that we did fairly early on in class with a join. Now I want you to use a subquery to do the same thing. The second one is find all editors who have written books that were published. It's a little trickier than it looks. You need to nest your subqueries to get all the things connected using a subquery, which I want you to do for this exercise. This lesson is on subqueries using a comparison operator. Now, for most subqueries, you're just going to use the in operator to compare a column value to a list of column values brought back by another select statement. Now, that type of comparison is always looking for equality. Wants to find out where the column value is equal to one of the values in the list. Now, there's another kind of subquery where you can use a regular comparison operator. Things like the equal sign, greater than, less than sign, that sort of thing, instead of the in operator. When you use a comparison operator instead of the in, however, the inner query must return exactly one single value, one row, one cell. Otherwise, it's an error condition. It can't produce more than one. It can't produce 0. That would be bad too. That would also be an error condition. What's one way that you can be absolutely sure that you're going to get one value returned from a select statement? From using aggregate functions like average or sum, count, they all bring back exactly one value. If you just get one of them, you'll get one cell as well. So let's look at this select statement that I've set up using a subquery. So we have select the title and price from the book table. But I want to find that where the price is greater than the average price of a book on the book table. When you have something in parentheses like this, that's the in list, if you will, that we used before. But now, in this case, we're going to compare it to a single value. That's the only way we can use a comparison operator like the greater than sign. So an average price will come back with some number. We won't even know, if we run this statement, what that number is. The inner query, that's the query between the parentheses, calculates the average price and then returns that value to price is greater than and puts that value in there. We don't get to see what that value is. If we needed to, we would need to run this inner query all by itself to get that value. But if we just want to know which books cost more than the average price, we can do it like this. So let's go ahead and copy and paste this into the SQL area. We'll run it. And here we have some titles. We see books that are 29 and 42, and we have to assume that that's greater than the average price. So the way this is processed, of course, is we run the inner query first, or SQL does behind the scenes. So we'll go ahead and run it just so we can get a feel for what's going on when the SQL statement is processed by the computer. And here we are. We have the average price is $27 and something. So that's good. If we did this manually, if we didn't know about subqueries and we wanted to ask this question, we would have run this query first, got that number, and then typed it into a statement like this. Title, price, book, price is greater than that, order by 1. And we get the results. I'll go ahead and run that just for fun. Copy it in there, and begin to run it. And here we are. We've got the results, the same results we had before. The 9 rows, $29.99 appears to be the lowest price book that's greater than 27, and it works the same way. Note that with the original subquery, we see a list of books that have a price greater than the average price of a book, but we do not see the average price of the book and what it really is. To get that, as I mentioned, you need to run a separate query. One thing we did here is use information about the book table to get other information from the same table. We found the average price from the books, and then we use that average price in another query about books. This is one of the nice things you can do with a subquery. Here's another example. When I see something like this is just on a personal level, my eyes almost immediately drop to the subquery. I almost look at this first. This is actually the inner query of the subquery. And I think, okay, what's going on there first? Because I need to understand this before I understand the rest of the statement. So I'm selecting the sum of the year-to-date sales minus 30,000. That's an expression, but that still is going to bring back one single value. I'm going to get the sum year-to-date sales minus 30,000 from the book table, but I'm only going to be looking at books where the price of the book is less than $20. When all's said and done, this is going to run, and it's going to come back with a single number. And then I'm going to run this statement, title, year-to-date sales, price, book, where year-to-date sales greater than whatever that number is that's calculated by that inner query. And then we order it. I'll run the inner query. And then we have down here 14,415. So we run the inner query, and now let's go ahead and take that and we'll plug it into the statement as if we did it that way originally. We'll take out the subquery and I'll just put in the value that was returned over here. Copy and paste it over to the statement. Clear that out. And then I'll run that. And you see I have 3 books. Are you stressed for success? Fresh and easy. 20 meals you can make in 20 minutes. See the prices. We see the year-to-date sales. Now let's go back and run the whole subquery together and see if we get the same thing. Run it. And we do. Everything is the same. The system works. Clear this out. You can use a subquery with a having clause. Often used with a where clause, but you can use it with a having clause as well. Let's look down here at the inner query. Select the average year-to-date sales from the book table. That's going to resolve to a single number, which is now going to go in the having clause. So I'll be selecting type with the sum year-to-date sales from book, and I'm going to group by the type. But I want the types that have an average year-to-date sales greater than the average year-to-date sales from the book table. Paste it in here. And here we are. Business, 30,000. Computer, 12,000. Cooking, 43,000. So that's greater than the average year-to-date sales per book. Look at the exercises. So here's the first one. It says to code a select statement that shows a book title and the year-to-date sales for books whose year-to-date sales is greater than the smallest value for zip code on the author table. As I note here, it's not particularly useful, but it's fun. Again, all SQL really cares about is the data types, if they are exactly the same data type or if they convert correctly. In US zip codes, they're all numbers, so it'll convert to a number. If you're using zip codes from Canada, for example, they won't, so this wouldn't be a good thing to do. Exercise 2, code a select statement to see which editors are getting paid the highest salary. That's interesting. Go ahead and give that a try. This lesson is on subqueries versus joins. Many subqueries could be written just as well as joins. For example, we have one here. I have select title, and I put an expression that's just is published by all Techo books from book, where the pub ID is in the list that's returned from this inner query, which is select pub ID from publisher, where name equals all Techo books. Okay, so it's going to return a list. It's going to be a list, but a list of 1. We're using the in list here. You can't be certain that something's going to come back 1. Here, we can look at it and we go, well, come on, we know we only have 1 Techo books. But never sure. Someone puts in another all Techo books by mistake with a new pub ID. It would be weird, but it could happen. It's good to get in the habit of using the in. The in is the safest to use in this kind of scenario. It is possible you would also get null back. If someone removed all Techo books from the database, all of a sudden nothing came back, the in operator would not blow up, if you will, and stop working with a fatal error. It would try to process it. You'd get no books back, of course, but at least it wouldn't be an error condition. Whereas if you used an equal sign here instead, you would get an error condition if it brought back no rows. We're going to get the pub ID for all Techo books, and we're going to run it. Let's go ahead and copy that, run it. We've got 5 books here, published by all Techo books. We could have written that as a join, like this. Get the publisher's name, the title, book join to the publisher using pub ID, where the name is all Techo books. And we'll go ahead and run it. You can see we have the same 5 books, so life is good. It's pretty much the same kind of thing. There are some differences, and we'll talk about that. Often a judgment call on which one to use. Sometimes you just do whatever feels the best. Feels comfortable to do a join, you do a join. If a subquery seems clearer to you at that moment, you use that. However, here's some considerations. If you have a very large set of data, tables with hundreds of thousands of rows, it's often quicker to use a subselect, to use a subquery, because that statement is processed and then the other statement is fed those data values, and then it is processed. So it doesn't have to figure out everything all at once, so to speak. Now, if you do need to see information from more than one of the tables, then you have to use the join. the subquery only allows you to see columns from the outer query. Look over here to the right. Here we see name and title, right? Because we've joined the information. But if we go back to that subquery for a second, notice I can only get title, and then I have to put a comment as published by all Techo books. I can't put the name down here because it's not joined, at least in a normal subquery. There's ways around it, but frankly, as you'll see in a later lesson, it's not worth it. It's better to use a join if you want to see the information all together. Another advantage to using a subquery is that you can compare a detail value to an aggregate value. For example, where price is equal to, select average price from whatever table. Additionally, you can base the results of the outer query on the results from an inner query using the same table. Can't do that easily in a join. There's a way to do that with something called a self-join, but that's generally more complex and it's harder to understand. It's harder to visualize. I'm going to show you a little bit of that in the next lesson. Let's go over to the exercise. Take the following select statement that uses a join and rewrite it using a subquery. So here we have title, cost, $12.99, written by Ann Singer. It's a book. Book author. Author, getting where price $12.99, last name Singer, first name Ann. So you're going to need to nest the subquery more than 2 levels deep to get this to work. This lesson is on subqueries versus self-joins. A copy editor with an editor ID of number 9 might be managed by the managing editor with an editor ID of number 5. Pull that up on the database diagram for a second. See, we have an editor. We have an editor ID. We don't have a managing editor ID in here, but we're going to pretend that we do for this thing that I'm going to explain to you. Imagine, if you will, that the editor table includes another column called Manager Editor ID, and it holds the editor ID of the manager, or the manager's editor ID. You could find the manager of a copy editor with a subquery like this. Get the last name, first name of an editor, where the editor ID is in the manager editor ID, from editor, where ID equals 3. I know the editor ID of the manager is 3. I could pull it together and pull the actual manager editor ID, and then compare the editor ID to that and get it. This is just an inner query. It uses the same table as the outer query. If I wanted to use the concept of a self-join, this is a table joining to itself. The only way you can get this to work is to have different table aliases. And this tricks SQL, if you will, into thinking that there are 2 copies of the same table. So here's a way to rewrite it. This gets a bit confusing. Let's go down to the from clause first. From editor, I give it the alias E1. Join to editor, alias E2. On E1 editor ID equaling E2. Managing editor ID, because I'm trying to get the managing editors for the editor. I'm going to find out where the E1 editor equals 3, and I'm going to show the E2 last name and the E2 first name. So you can see this can kind of make your head spin a little bit. Personally, I find this a bit hard to visualize, and I just about always use a subquery instead. However, you should be aware that self-joins do exist in SQL. You might stumble across them in your travels, and so I don't want you to tell anyone that I didn't tell you about them, so here they are. The idea that you might ever use a self-join is when a table has information in one column that refers to information in another column. The classic example is very similar to what we just did, but you think of it more generically as an employee. You have an employee row. It has a column for the ID of the employee, but it also has a column for the manager's employee ID. I'm employee ID 33, and I'm managed by employee ID 22. However, the employee ID of my manager, well, he's also an employee. So that manager ID will have a separate row in the table that has that manager ID as just the employee ID. This kind of relationship, when a table sort of refers to itself, it's called recursive because it refers back to itself. There's things to do in database design to handle recursive relationships, but I'm not going to get deeply into them here. But that would be the kind of clue that you either need a self-join or you need a subquery if you have a recursive relationship. Interestingly, in this example, the manager ID on the employee row, it's actually a foreign key back to the primary key of employee ID. So this is the first time you see the foreign key, which is usually a column from one table that refers to the primary key of another table. In this case, it's a column in a table that refers to the primary key in the same table. It makes sense if you just say, hey, I'm going to carry the manager ID on every employee's row. It's not that hard to understand conceptually, but it does get a little confusing as you're trying to visualize using it. Here's the exercise. I want you to think of another example of a recursive relationship that you might encounter in the real world and in a real world database. Go ahead and experiment with coding a self-join and a subquery to see how they would differ. This presentation is on Assignment 9. Use the SQL interactive tool of your choice for Oracle, like the Oracle Apex tool I showed you how to use in Chapter 1. All of these questions can be answered with a single SQL statement. First one, code a subquery select statement that shows all book titles published by Sunshine Publishers and all Techo books, but only for books that have sold more than 5,000 books. Question 2 is, code a subquery select statement that lists a publisher and all their books that have been given an advance that is less than the average advance. Lastly, question 3, which is to code a subquery select statement that lists all authors who live in a state where all Techo books is based. Work on that. When complete, go on and move on to the next lesson, which will show you the solutions that I came up with. This presentation is on the solutions to the questions posed in Assignment 9. So let's take a look at question 1. Code a subquery select statement that shows all the book titles published by Sunshine Publishers and all Techo books, but only for books that have sold more than 5,000 copies. So let's look at this as a subquery, and we can see that we can select title. Remember that using a subquery, the outer query, or the one on the top, can only show columns from the tables referenced in the outer query. The columns referenced in the inner query are not available to us using this kind of subquery. I have title, and then I have an expression here, just a text expression. It says, by Sunshine Publishers or all Techo books, and then I have year-to-date sales. So I'm getting that from book, and I'm going to get it where the pub ID from the book table is in the pub ID of the publisher table, where the names Sunshine Publishers or all Techo books. But I have more criteria. I have here, and the year-to-date sales is greater than 5,000, because that's what I asked for. So that will restrict this further. I could rewrite this as a join, like so. I have the name, title, year-to-date sales, publisher, join book using the pub ID, and then I put all the criteria together. Name of Sunshine Publishers, or name all Techo books, that's in parentheses, and year-to-date sales greater than 5,000. So both of those will bring back the results I expect to see. Let's go ahead and run the join first this time. And you see we have 2 books. Usability testing, are you stressed for success? And we see the year-to-date sales. Now, as a subquery, I'll go ahead and take it this way instead of the join we just showed. Copy, clear this, and paste it. And you can see we have the same books. Usability, are you stressed for success? And then I have this literal, by Sunshine Publishers or all Techo books, and the year-to-date sales. Notice we lost some precision because with the join, I could see exactly whether it was Sunshine Publishers or all Techo books that published this particular book. Here, I just know it's one of them. I don't know which one. So there's some disadvantages to subqueries. Let's look at question 2. Code a subquery select statement that lists a publisher and all their books that have been given an advance that is less than the average advance. Going right to the inner query here, select the average advance from book. Now I'm going to look where that advance on a per row basis is less than whatever the average advance is. So I'm going to pull that back. So I get the name, title, and advance from publisher joining to book where the advance is less than the average advance. I want to print that back. So let's go ahead and run that. Copy, clear this, paste it, and we'll go ahead and run it. And you can see we've got all these criteria here. Less than the average books. We used a less than sign this time. So it's less than what the average advance was for a book. Let's go ahead and look at question 3, which says to code a subquery select statement that lists all authors who live in a state where all Techo Books is based. Clear this, and we'll look and we see, first I get the state from the publisher table where the name is all Techo Books. And when you see problems like this, the temptation is to go run a statement like this yourself or go look at all the data in the table and find out, oh, I know what state that is. That's California. And then just plug California in there. Don't want you to do that. You want to take advantage of the inner query using a subquery and just write one statement that gives you the information that you need. This is going to pull back California. So we're going to have a list of 1 in parentheses California. The last name for the author, first name, and the state where it's in that list. Let's go ahead and run this. Copy it and paste it in there. I'll submit it. And if we look down here, we've got all these California authors. Clearly, all Techo Books is in California. This lesson is on how data is organized in a relational database. One of the main reasons for storing and managing data in a relational database is to reduce data redundancy. For example, the author's first and last name are stored in the author table. They're not stored again in the book table. Might seem to make sense to put them in the book table, right? You needed to find out who wrote what books, you'd have all the information together. But if we need to get that information, we instead join the book table all the way back with the author table to get it all back together. This keeps us from having redundant data. If we have redundant data and an author changes their last name, for example, then we have to change it consistently in all places it's referenced. So by reducing this data redundancy and using the joining operation, we can avoid that hassle. The only data that's commonly and frankly necessarily repeated are stored in the foreign key column. This is what allows us to connect the information in the tables back together. So, how do we design a relational database so that it follows these rules of non-redundancy? How do you know how to make the connections between the tables? In this chapter, I'll show you 2 of the main techniques used for designing a relational database, which is also known as data modeling. The first technique is called entity relationship modeling, and the second technique is known as normalization. We're just going to go through them briefly here, and in the next chapters I'll go into more detail. You know that all data stored in a relational database is stored in a grid-like structure called a table. Sort of looks like a spreadsheet. When creating a relational database, the first thing you do is think about something called entities. An entity is essentially just a person, place, or thing that you want to keep track of. For example, if you're a publishing company, you want to keep track of books. You want to keep track of authors. These are people, places, things you want to keep track of. Now, you've been working with a book table and an author table, but before you get to the point of building tables, you need to start with the conceptual design involved with the author and book entities. Let's take a look at the chart here. The relationship between books and authors is many to many. An author can write 1 book, or they can write more than 1 book. And a book can have 1 or more authors. That's also called many. So the conceptual diagram looks like so. Notice that I have the crow's feet, this over here, on both sides of the diagram. So this indicates the 1 or more, or many, going on each side, many to many. Now you've already seen that when we do physical tables installed in the database, that we need a table in between that called an intersection table to help manage those relationships. But conceptually, it's a many to many between author and book. So the overview of database design. If you need to design a relational database, you need to gather the data that you need to track. You say, okay, look, I need an author's name, I need their phone number, any book titles and the kind of book it is, what type, is it a computer book, cooking book? And then when you get all this data together, you try to group them into these logical entities. You then determine what is the relationship between those entities, one to many to many, etc. Lastly, you apply these normalization guidelines that are going to be used to reduce data redundancy. We'll get more deeply into that in the next 2 lessons. But for now, this is just a simple exercise. Think about what organizations or companies you have worked for and what kind of data was being tracked there, what was being stored and managed, what kind of entities you think were used in the design of the database that you were using at that company or organization, whether employees, departments, or something else. Now think about that. I have a suggested scenario at the end of this lesson. You go to your working files, a lesson on how data is organized in a relational database, and go to the end of that to see my notes. This lesson is on entity relationship modeling. Now, entity relationship modeling, or just ER modeling for short, is the process of identifying what persons, places, or things that you're going to track in your database, and discovering the relationships between those persons, places, or things. The persons, places, or things you identify are called entities in database speak. Ultimately, an entity will be used to help design and create an actual database table in the database. An entity, for example, an author, has attributes. For example, an author has a first name attribute, a last name attribute, a phone number attribute, etc., etc. These attributes will be used to help define the columns that will go on the database table that will be built from the entity. When doing data analysis, you may begin grouping data into the entities and attributes. However, with ER modeling, you will just concentrate on the entities themselves and their relationship to each other. Now, data analysis is inherently different than data modeling. The analysis of data is simply figuring out what your organization needs to track in the database and just gathering data items. Once you have the data items together, that's when you begin this process. Here is some data that a real estate company may want to track. Houses, agents, clients, sales price, offers prices for homes, that sort of thing. A lot more than that, I'm sure, but that's just a first pass. So let's move on. What in the data list is an entity, and what might be considered an attribute of an entity? House seems like an entity since it can have attributes like the address of the house, the number of bedrooms, sale price, that sort of thing. Right away I noticed that sale price is probably an attribute of a house and not an entity itself. So what about the agents? Would it be best to have separate entities for an internal agent and an external agent? An internal agent is working for our agency, and the external real estate agent is someone we have to deal with. Or should an agent be the entity by itself, and what type of agent they are would be an attribute? There's always choices to be made in database modeling. There's a certain creative process. You need to figure out what your particular organization needs now and how it might grow, and that can affect how the model would be different perhaps from your organization to another one doing a similar thing. For this example, I'm going to go with 2 separate entities and store the external clients with the external agent. I have a client, which means our client, someone working for us that we want to help purchase a house. So I have an agent internal and an agent external entity and a house. Now I realize real estate agencies sell more than just houses, but this is just to keep it simple. So we now want to get into discovering the relationships. I'd like to make an important note here, though. As we get into dealing with entities and creating tables, always make sure that you name them in the singular. Because really when you name a table, for example, like we have an author table, not authors table, even though you think, well, I've got lots of authors in there, why not author? The author table is really saying this is a type of entity. We are going to store entities of type author in the author table. So that's why you keep it singular. That's considered correct in database modeling. Let's look at this very simple diagram. A house can be bought by only one client, but a client could buy more than one house. So you have a one one-to-many relationship from client to house. Okay, see that? And the many part of a relationship is represented by this crow's foot. Many in database speak really represents one or more. Sometimes zero, one or more, depending. So our client here with just a single line means one of these can have more than one of these. Moving on. What about offers on a house? A client could make more than one offer on a single house or multiple houses, and a house could have more than one offer made on it by clients of ours. However, our agency has a rule that we will not represent more than one person at a time to a particular house. So we're not making our clients compete with each other. Now the relationship between client and house is still one-to-many from our perspective. And that's what's important. It's what your organization's needs are. What is the relationship of an internal agent to house? An internal agent can sell or list more than one house, but a house can only be represented by one agent. At least that's true in our agency. Might not be true in somebody else's agency, but that's the rule we're going to enforce. Remember that I'm modeling data for a single real estate agency, not all the possibilities in the world. The data I track only needs to reflect my agency's information. So sometimes this can be confusing. People think, well, gosh, you could have two of those. Well, you could in the world, but you can't have two of them here because we have a rule that says you can only have one in our company. So make sure that you understand the needs and rules of your organization and model accordingly. An external agent can list or sell more than one house to us, and a house can be listed or sold by more than one external agent. Could be different agencies representing the house, theoretically. One advantage to having separate entities for our agents is we can track more information about our own employees, our internal agents. An internal agent can have more than one client, but a client will only have one agent of ours. Maybe in the real world they've got another agent somewhere, but we don't know about them or track them. An external agent may have more than one client that they're representing to us, and theoretically, that agent's client could be represented to us by different agents concerning different houses. But since we are tying external clients directly to their external agents in our database, we will not try to track external clients as unique entities. For example, if Joe Smith is represented by Sally Jones on House 1, and Joe Smith is represented by Sam Mathers on House 2, as far as our database is concerned, Joe Smith is two different people. It's simply not our concern to track external clients except as they relate to a particular house that we represent. We do not need to track what an external agent is up to with his or her clients, except how it relates to our agency. Let's get a sense of where we are now with the diagram. We have kind of house at the middle of everything. Here's house. And a client of ours, these are our clients, can bid on more than one house. One of our internal agents can represent more than one house. An external agent can represent more than one house to us. We've got a lot of one-to-many relationships going on between these particular entities that we're tracking so far. Now again, this is a simplified view of the world. A real estate database is much more complicated than this. Now we're ready for the exercise. You have been using a book publishing database for SQL statements practice. Look at how the raw data might have looked to a data analyst before this thing was even built. Let's see, we got book titles, author last names, author first name, author 2 last names, author 2 first, publisher names and address, published dates, price of books, advance to the authors, yada yada. Okay, so without looking at the database diagram that I've already provided, try to create an ER diagram of your own based on the raw data. This is stored in your working files area, and you can see it, and you can scroll down to see the solution. This lesson is on normalization. Now, that's a funny word. It means to normalize the data, which is just a fancy way of saying we're going to continue organizing the data so that data redundancy is greatly reduced. This process is most often done after the ER modeling is completed. The normalization guidelines are rules we can apply to the entities that may result in breaking up some of the entities that seem to make sense to stay together into smaller entities that will reduce data redundancy. As we go through the process of normalization, each step will bring the entity or table into various forms. Now, the forms I have there in quotes. These normalization forms describe the state that the entity or table is in, according to the normalization rules that have been applied to them. Now, it may all seem a bit strange now, but it will become clearer as you learn these normalization rules. So here's how it goes. When you apply the first set of normalization rules, the entity or table will be said to be in first normal form. When you apply the second set of normalization rules, the entity or table will be said to be in second normal form. When you apply the third set of normalization rules, the entity or table will be said to be in third normal form. Fortunately, this is usually where you stop the process. Now, there are other normal forms to find. There's a fourth and fifth and so on. But the goal of most data modelers is to bring the database into third normal form. A database is said to be in third normal form when all of its tables are in third normal form, or they're at least in third normal form or greater. Now, in this presentation, I'm giving you a practical definition of the normal form. This means that I've simplified the definition so you don't have to deal with academic terms and other complications that will just make it harder to learn at first pass. You can go onto Wikipedia or onto Oracle website and you can get a much more detailed definition of what these normal forms are. But for here, I'm trying to give you a beginner's feel for it. Let's move on. This is first normal form, kind of a definition. A table is in first normal form when the data in each column couldn't be reasonably broken down into further smaller pieces. And also, there are no repeating groups. Alright, so what's a repeating group? A repeating group, for example, is something like pet 1, pet 2, pet 3. If I were keeping track of how many pets someone had, there's problems with that. What if the person has 10 pets and I've only provided 3 columns? Or what if they have no pets? I've provided 3 columns and there's nothing filled in them. So there's a way to handle this. So there's something that we can do to remove a repeating group from a table and put it in first normal form. So let's take a quick look at the tables we have so far. This is harkening back to the entity relationship process we did in last lesson. We have the client, this is our real estate client, and they have a name, address, phone, house that they're either buying or selling, offer 1, offer 2, offer 3. If multiple offers were made on the house itself has an address, a listing price, and a sold price. The internal agent, the one working for us, has a name and the years they've been with our agency. And an external agent has a name and they have an agency. It could be multiple different agencies, so we gotta list their agency in here. And their external clients that they may be working with. So they might have 1 client, 2 clients, and however many clients. So conceptually, this is where we are at the moment. So first we need primary keys on the tables. I've said that it's often good to use a artificial numeric primary key. It helps out later with joining and that sort of thing. So look, I've got the client table and I made up a client ID. It's a primary key. The house has a house ID, for example, also PK for primary key. Our internal agents, I'm just going to call them agent ID. And the external agents, I put an EXT prefix on the agent ID, also as the primary key. So that gets us in the neighborhood of where we need to be dealing with primary keys. Now, as you can see, we're going to further break this up and we'll need more primary keys. Now, this whole kind of notation I'm using here with the table or entity name to the left and the column or attribute names in parentheses to the right, this is known as relational notation. There's various versions of this, but it looks substantially the same. Table name, and then parentheses has the attribute or column name. So now, let's go ahead and remove the repeating groups. Repeating groups, pretty easy to spot here. We have offer 1, offer 2, offer 3, house 1, house 2, client 1, client 2, yada yada. So the way we do that is we pull these things out into separate tables with their own primary key. But not just a primary key of the offer, but also the primary key of the client, so we know how to tie them together. So we get a duplicate primary key. Now, offer is interesting because offer really has something here called house as well. So the offer needs to include the client who's making the offer, the house on which they are making the offer, because you can't just make an offer into outer space, you have to make it on a particular house. So I've added here a column called offer date. I'm going to assume that only one offer is made on a particular date. That may or may not be true. There's probably a better way to do this, but this gives you the concept that each offer can be made on a particular time, and it's different from any other offer. So the offer here is the amount they offered, and then the client name doing the offering. So client, house, offer date, all three of these have a hyphen PK on them to indicate that they're part of a combination primary key. Now we had houses over here, house 1, house 2. So for the agent, so our internal agent, here's our internal agent, but the houses that they're dealing with are here. Here's the house ID and the agent ID. Now notice that I have PK and FK on two of these columns. In this case, the two PKs indicate that it's part of a combination primary key. The FK indicates that individually, this is a foreign key to another table. The agent ID goes to the agent internal table. The house ID by itself goes to the house table. But together, these two columns are the primary key of the agent internal house. So you can have 0, 1, or many houses per internal agent. And we have a similar kind of thing with the clients for the external clients over here. External agent ID, external client, so forth. And it'll pull it back in. And this is per house because I made a rule that I wanted my external clients to be associated on a per house basis. I didn't want to track them as unique individuals in the world, only as they pertain to a house that's being represented by an external agent. Alright, so this is going to end part 1 of the presentation on normalization. And when we come back, we will pick up with breaking this up into first normal form. This lesson is part 2 of the normalization lesson. Now, we had finished picking some primary keys on the tables as we had them so far, with client house, client ID being for client, house ID being for house, etc. These are artificial numeric keys. We also began to remove the repeating groups. So things like where I had offer 1, offer 2, offer 3, I pulled into a separate offer table where I had the client making an offer on the house, and I made an offer date be part of the primary key in such a way so we could make a new offer on every day. And the offer is just the amount that was offered, so forth. And I put the client name here. You may notice here in several places I put a PK and an FK. Well, the PKs altogether indicate that this is a combination primary key of the agent ID and the house ID. But the FK on a column indicates separately that it refers to another table. So agent ID here is a foreign key to the agent table here, the internal agent. And house ID is a foreign key to the house ID, the primary key of the house ID in the house table, and so forth. So let's move on and look at the rest. So the next thing I need to do is to break the data up into its smallest reasonable parts. Generally, you break names into stuff like first name, last name. Now you probably have a middle initial, a salutation, a suffix, yada yada. You can have more. But I'm going to just keep it simple and use first and last name here. An address would be into city, state, zip, phone, and the street address as well. So you can go farther if you want. Phone numbers are often broken up into their area code and sometimes prefix and suffix. So you need to determine what your particular organization needs and how far you need to go with this. That's why I said it should be the smallest reasonable part. What's reasonable for your organization? What is it that you want to track? Now, I've got everything broken up now into the parts like last name and first name, and the addresses are broken down to city, state, zip, and street, etc. Now let's talk about what second normal form is. In order to be in second normal form, a table must be first in first normal form. And then no non-key column must be derived from another non-key column. Now by non-key, I mean non-primary key. Often the primary key is just called the key. But we can't have any other non-key column inferring we can get the value or determine the other value simply from the non-key column. So let's look at an example. We're going to go back just for a second here. If we look at the data here, if I know who this is, say by their last name and first name, I know where they live. I know their city, state, zip, etc. So this last name, first name is inferring all this. So we want to get rid of that. So going back here, I take this out. I need it, of course, here in the city, state, zip, street. I need it with a client ID because it has to be somewhere, but it's completely inferred by that. There's no non-key column that's inferring anything. Likewise, the agency has the last name, first name, years with agency, etc. we pulled out the address info where it was just being inferred by the client or the name itself. So let's go into third normal form now. Now, third normal form happens when a table is in second normal form, follows all the rules, and then all of the columns in the table, or all of the attributes, are fully dependent on the primary key. Now, where I have a combination primary key, they can't be dependent on just part of the primary key. They have to be dependent on the entire primary key. So, for example, if I remove first name and last name, here, I know the client ID implies first name, last name, and address. In other parts of the tables where I had first name and last name, I took it out where it didn't make sense. I didn't need to carry it here in the offers, for example. I didn't need to carry their name. Once I know the client ID, I can join to this table and get the first name, last name, address, etc. So it's not just dependent on part of the primary key. Go through and look at that. And notice how very little data I have. Here I have last name, first name, street, city, state for the client, and I don't have that any other place. Now, I have an agent that has a last name and first name, but that's different than this one. So the agent ID infers agent name. Now, I don't have to rename them because I know this is the last name of the agent internal table because I can qualify it. And here, the relationship between a house and an internal agent is just agent ID and house ID. I don't really need anything else in that table. From those tables, I can join back the tables that these are foreign keys to and get any other information I need. So we're reducing the data redundancy pretty much to just the foreign key values that repeat themselves. Now, you may recall from the BookHub database that we're using that sometimes attributes, brand new attributes, can be derived from a relationship when we create a new table, like an offer table. Well, for instance, here, offer table, I added something called accepted, yes or no. Well, a client doesn't just accept something. A house isn't accepted or not accepted. The offer, the whole kit and caboodle here, has either been an accepted offer or not. So we can have that column just be going with there. Also, a house that's assigned to an internal agent, we can keep track of the date that that house was assigned to that agent, etc. So we look for ways to do this. Now here's a very easy way to remember if a table's in third normal form. Popular thing when you swear to a judge in a trial is you promise to tell the truth, the whole truth, and nothing but the truth. So third normal form is a table is in third normal form if every non-key column is dependent on the key, the whole key, and nothing but the key. That's an easy way to remember it. Often people kind of do second and third normal form at the same time. It's very easy just to make sure things are not dependent on any other non-key columns and to make sure that they're fully dependent on the entire primary key. As you get more familiar with this, you'll find that you'll just fall out pretty much quickly into third normal form. So let's look at the exercise here. So you have been using the book publishing database for SQL, doing the statement practice. So let's look how the raw data might have looked like to a data analyst. And this is just some of it, but might have had author 1 last name, author 1 first name, author 2 last name. So they knew they had authors, they knew they had publishers, and they had books. So publishers book 1, publishers book 2, a published date, price of the book. And we knew we paid the authors advances, so advance to author 1, advance to author 2, and yada yada. You can look at the database diagram to get a better feel for this. But try to not look at the database diagram and put this data in first normal form, and then go through the process of putting it in second normal form, and then try to put it in third normal form. Now fill in any columns that are inferred by the data, like, the author has an address, then you break the address into its appropriate parts. As always, you'll find this in your working files, and you can scroll down to that file to see the solution that I propose for this exercise. This ends the lesson on part 2 of normalization. This presentation is on assignment 10. Now I've created a problem here for you to get a chance to exercise creating an ER model and to apply the normalization guidelines. So let's look at the situation. You have a company, XYZ Incorporated, and they've analyzed some of the data attributes that they want to track in their database. They need your help to organize the attributes into database tables and develop the correct relationships between the tables. So let's use the attributes below to answer the questions that will follow. They need to keep track of the department name, job title, social, security numbers for their employees, employee name, address, phone number, that sort of thing. They need to know the employee department number and job code, the salary for their employees, and the job description for their employees. Let's go down. Question 1 says to create an entity relationship diagram for the entities required to model this data. Now you have to discover the entities. You need to look at the data attributes, pull things out, and try to realize what is a person, place, or thing to be tracked, and what is an attribute of that person, place, or thing. So get it into entities, make a little diagram, and then use the lines with a crow's foot to be able to make a simple data model. Now question 2 says to apply the normalization guidelines to decide what columns go with each entity. And I'd like you to express that answer in the relational notation format that I used in the video lessons. Now, for example, you had a table named SumTable, and then you had the column names or attribute names which followed afterwards. Put the -pk for primary keys and the -fk for foreign keys. This presentation is on the solution to assignment 10. Now, I gave you a problem where you had a pretend company, XYZ Incorporated, and they had some data attributes that they had analyzed that it was your task to organize into a data model using the ER modeling and to apply normalization guidelines. So we had things like department name, job title, social security number for their employees, employee name and address, phone number, employee department number and job code, salary for the employee, and the job description for the employee. Now let's look at question 1 to create the entity relationship diagram. Now the way I saw it, we had 3 entities. We have a job, which has a job description and a job code that the employee may have. And the employee also has a department that has a department name and department number and that sort of thing. So we have employee, departments, and jobs. So a job may be held by many different employees. People could be more than one employee, could be a payroll clerk, for example. Likewise, a department would probably have more than one employee. But in this model, an employee will be in only one department and have only one job. In the entire world, there are some cases where an employee might have 2 reporting relationships to 2 different departments. But in our model, we're going to keep it simple and just use the rule that an employee may be in one department and have one particular job. Now that we have that, move on and look at the normalization guidelines. So you apply the normalization guidelines to these entities and to the columns that we had. And we're going to use relational notation format. So here's my 3 entities: employee, department, and job. So I gave the employee an employee ID, made that the primary key. SSN is short for social security number. I gave them all last names, first names, street, city, zip, phone, salary. You notice that the columns are broken down into their subparts, into the smallest reasonable pieces that they should be. Sometimes, like I said, phone numbers are broken into area code and broken down further, but in this case, we'll just leave it the same. Now, I have department number as a foreign key and job code as a foreign key. And if you notice, the department table has the department number as a primary key, and the job table has a job code as a primary key. The job has a job title and a job description, because that's what's implied from this. And the department number, if you know the department number, you know the department name. You're not going to have the same name repeated twice for a different department number. So here, this is how we tie that information back in for the employee. So this should be a reasonably good model for a simple set of data.
Subscribe now and press the bell icon. Never miss an update.
This lesson is on creating tables. Now, after your data model or your database design has been developed using the ER modeling and the normalization technique, you're ready to create the physical tables in the database. Creating a table simply defines its structure, making it ready for data. It doesn't actually have data when you first create the table. That data will be added later. Now, SQL is an all-encompassing language. It is the language we use for creating and managing a relational database. And as you've seen, of course, it's also the language we use for querying the database. It'll be the language we use for doing security and anything else about a relational database. So SQL is much more broad than just the select statement. It's the standard for doing so. Every major computer vendor, Microsoft, Oracle, Sybase, any of these companies, they all have a version of SQL implemented. They take the SQL standard and then they write the software to follow that standard. Let me just give you the idea by showing you a simplified view of the create table syntax. This is the keywords create table. Instead of select, we now have create table. Here's what it might look like syntactically. Create table, you give it a table name, and then you have an opening and closing parentheses. Now you specify column 1, whatever that's going to be. It could be last name or something. And then you give it a data type. You say what kind of data is going to be stored there. Character data, numeric dates. In several cases, you have to give it the maximum size that would be allowed to be contained in that column. And then here, you're going to specify some kind of constraint. This is going to constrain the data perhaps a little bit further than just the data type. We don't always use constraints, but if we use them, we put them here. And I'll show you examples in a moment. So then we have a comma. And then we have column 2, data type, size, constraint, comma. And then the 3 dots for just as many columns as you need. And then the last column has a data type, size, and a constraint. But notice the very last one you specify, no comma. That's an error condition in Oracle, and sometimes it's hard to debug. But don't put a comma in the very last one you define. Now here's a simplified example using that simplified syntax. So here's the create table statement. Create table, I'm creating an employee table. So I just make this word up. You choose what's a meaningful table name. It describes the data that you're going to store there. We always define this in the singular, so we're following the idea of it being an entity type. It's not really an entity by itself. Each row on the table is an entity of the entity type, this employee ID. So that's what a table really is. You're saying, I have employee types inside this table. That's what the data that's going to go on there. So if you can remember this and talk very precise in this way, it'll make you look good in a job interview. All right, so here's some columns. Employee ID. It's a number. It can be up to 9 digits long. And the constraint on it is it's a primary key. So we know what that is. It has to be unique. It has to not be null. The last name field, or column, I've defined as a varchar2. Remember that Oracle has a little bit of a quirk where we use varchar2, not varchar, to define character data. And since I said 40 in here, it can be up to 40 characters long. A name longer than that is going to be truncated. And I've specified a constraint that it should be not null. In other words, it's required. Okay, first name's the same deal. Department code, I said, is a varchar2 field, and it's 3 characters long at the most. The null word here means that nulls are allowed. It's not a required column. Technically, that isn't even really a constraint. It just says, it just notes it. Later on in our create table statements, we'll actually take that out because that is the default behavior. I have a salary. Salary is a number. It's 8 characters, or rather 8 digits, and 2 of them are going to be considered to be decimal places. And then we have hire date, and we give the date as the data type. We don't put a size on the date. The dates are handled internally by Oracle and just work. Not null and no comma at the end. I'm emphasizing that because it's easy to forget, especially as you go on trying to create tables for the first time and make changes. You may add another column at the bottom of the table and forget that you need a comma on the column up above where you had no comma before. So pay attention to that. So since SQL is the standard specification, 90% or more of SQL software developed by computer vendors is the same. Most of the stuff is the same thing that you have before. Now, if you're using, say, MySQL instead of Oracle, notice the difference between the data type specifications. Instead of number, they use the word numeric. Instead of varchar2, they use varchar. And so there it is. There's not that much to change. And primary key, not nulls, all the same. So it's usually a very easy deal to go from one database to another. You go to an Oracle, to a Sybase, to a Microsoft shop. It's usually not real hard to make the switch. Now, table names that you come up with, they should be descriptive and follow whatever naming standard that might be imposed by an organization you're working for. You don't need to avoid long table names because you have table aliases when coding SQL select statements that can make the rest of your select statements shorter. Aliases are actually used a lot, even in SQL code that ends up in computer programs. It's easier to read, frankly. You just use the long table names in the from clause and then use aliases everywhere else. Now the column name should be reasonably short and descriptive, and abbreviations are fine as long as they're meaningful. The column names cannot begin with a number. Gotta start with a letter. There may be some other things like underscore, $sign for systems programmers, but generally you should start yours with a letter. Now each column needs to have a data type associated with it. The data type describes and enforces the kind of data values that can be stored in that column. So there's three broad categories, three main categories of data types. There are character or text data types, there's numbers, and there's dates. And the dates also can be with times defined as well. Okay, so you can have a date time. So let's take a brief look at character data types. But before we do finish with character data types, we'll end here and take a little break, and we'll pick up this discussion in the next lesson. We're back to character data types, continuing from our last lesson. And with character data types, the ones most often used is the varchar2 or the char data type. Now the char reserves positions in memory whether you need them or not. If I did char 10, I'd be holding 10 little buckets to hold characters. And if I store a name in there that's Lee, L-E-E, I'm wasting 7 of those. So generally you don't use char. Sometimes I've used char 1 if I'm sure it's only going to be one character long, like a flag that's Y for yes and N for no. But you can get by pretty much just using varchar 2 if you want to. The limitation of varchar 2 is 4,000 characters. That's not usually a limitation that much. You have to specify it if you want that many. Varchar 2, 4,000. But there are larger text fields you can get in there, and you use something called a blob. B-L-O-B, binary large object data type. And you can store a very large bit of text in there should you need to. There's restrictions with that, and I'm not really going to cover that here in any real detailed way, but I'd like you to be aware of it, because if you're in a case where you need more than that, there are things you can do. So now technically, now this is interesting, the varchar data type, there is a varchar without the 2, and nowadays it behaves exactly like a varchar 2. For historical reasons, varchar 2 is preferred when you're coding an oracle. There's some history behind that, and it's basically become the standard. So if you're doing Oracle, I recommend going with the flow, using varchar 2 so you're consistent with everybody else that's coding Oracle. So now, numeric data types. The number data type, and that's what it is, it's spelled number. The data type stores fixed and floating point numbers. Floating points are just decimals, essentially. They have decimal places. Fixed numbers do not, like integers, whole numbers, and that kind of thing. Numbers of virtually any magnitude can be stored and are guaranteed portable among different systems operating Oracle database, up to 38 digits of precision. So you need to have a pretty large number to run into a limit when you're using the number data type. So the basic syntax here, you give a column name, you say it's number, precision, and scale. Well, I don't think that way, so let me give you an example. This is the formal definition. The way I think of it is this. Let's do it with a simple example. You can get sophisticated with this precision scale stuff, but I want to deal with what we mostly use. So, number 7. That says I'm going to put an integer, whole number of some kind, and the most number of digits I can have is 7 digits. Here's an example. 1, 2, 3, 4, 5, 6, 7. So that's like 1 million something. You don't actually put the commas in there specifically when you add to this database, but we'll get to that later when we learn how to put the data in. Right now, just conceptually, that's the number that would fit, 7 digits. No decimal places. Now, if I say 7 over here, number 7, comma 2, I still get 7 digits, but the last 2 of them are considered to be decimal places. So it defines a number with 2 decimal positions. 7 digits maximum. So in this case, I can do 1, 2, comma 3, 4, 5, dot for decimal, 6, 7. So I can't get a million in there. That would be too big. So if I needed to get a million dot something something, I'd have to make the number 9 here to get that to work. This is a date data type, or date time. It does put point and time values. The date data type stores the year, including the century, the month, the day, the hours, the minutes, the seconds. After midnight, and I believe it has milliseconds in there as well. Oracle Database uses its own internal format to store dates. Date data is stored in a fixed length fields of 7 bytes each. You don't even really have to worry about it. It just handles it. It has the century, year, month, day, hour, and second. Okay, so when we get into inputting and output of dates, there's a standard Oracle date format of DDMONYY. The MON is a 3-character month. So here's an example. You actually say 13 for the day, hyphen, NOV for the month, 1992. And there's rules about governing whether that's 1992, 2092, blah, blah, blah. It's actually kind of an awkward format. Interestingly, the Oracle Apex tool uses functions behind the scenes to make the format be like this instead. It would be November 13th, 1992. You'd spell it out. So that's what we're using here, and I recommend that. There are functions we'll learn about that allow you to deal with dates in different formats to get things into the Oracle way that it needs to store it, and to get it out the Oracle way into a way that you need to see it. So it's a pretty easy thing to do. So stay tuned on that one. Little summary here. For the number data type, you do specify a number or a number, comma, number between the parentheses. You saw that up here. Let's go back just for a second. Number 7, that's a number with a number in there, and this is a number, comma, another number. So you have to put that sizing in with a number data type. When you use varchar2 data type, you do specify a number between the parentheses as well. That number is the maximum characters that can be held by that column. So you're restricting the column. If I put 40, after 40 it gets truncated. It's gone. You lose the data. It's not an error condition. It'll just be truncated. So you need to think about what would be the maximum size you'd reasonably want to put in there. For date data type, you do not specify a number. It's in an Oracle internal format. It will handle it. It's a beautiful thing. So it is a standard practice to not specify if nulls are allowed. We only specify where it's not null, as you see over here. Where I had nulls before, or the word nulls, meaning nulls were allowed, I just have the comma here. Now I could have put the comma, tucked it right after the parentheses, but this works too. And you can see that I took those nulls out. So we don't really need that. When it's not specified, it's alright to not fill in a value for that column, and we can still insert a row into the table. So this should work fine. Now the constraints that I've put at the end after the data type, column name, data type, then constraint, this is where you put them, right after. You skip a space, put a constraint name, and then a comma. So it is constraining. It's constraining data. A not null, for example, says, I constrain this data to have something in it. And it's got to be of the right data type. I'm not going to let you put this in the database with nothing in it. The primary key constraint goes a little farther. It says, sure, it can't be null, but also that value on that column, on that row, has to be unique across the entire table. That's what makes it a primary key. We can use that column, or set of columns, to ensure uniqueness of a particular row. Won't be confused with any other data, any other row's data. The order with which you specify columns does not matter to SQL. However, it is generally a good practice to specify the primary key column or columns as the first columns listed in the table definition. It's not required, but generally a good idea. Other than that, you just define the columns in an order that makes the most sense. For example, it kind of makes sense to keep the first and last name next to each other. Group things that make sense together and down the list. Alright, let's look at an exercise. Now suppose you want to create a table to hold data for a Little League baseball team. So you're going to organize the following data items that I'm listing here for team members and use a create table statement. I want you to write a create table statement that makes sense. So look at this. Okay, we need the name of the player, we need their phone number, we need to know what position they play, their address, hitting percentage. We're going to express this as a .300 if they have like what they call 300% or 300 batting average. So we'll put .300. The player hits 3 out of 10 times. They've got a .300 percentage. Okay, so that's how you're going to express it. And then we're going to keep the date that they joined the team. We're going to track that on the row for each player. So this is what you need to do, though. You need to think about any columns you may need to create. A lot of this information you wouldn't put in as is. For example, the name. You don't just put someone's name in there. You put their first name, their last name. If you want to take it further, you might put their middle initial. Salutation, whether they have a junior or third after the name. You can take this as far as you reasonably need to go, depending on the needs of your organization for which you are building this table. That's the main thing. Does it make logical sense for what you're trying to do? Alright, I have a solution down at the bottom of this working file, and that ends our lesson on creating tables in a relational database. This lesson is on specifying keys. Now you need to be concerned about selecting a primary key when creating a table. You may also need to select a foreign key as well. In this simplified example of a create table statement, you see the words primary key specified to the right of the employee ID column. Here's the employee ID, and over to the right we have primary key. Now that will enforce the rule that the employee ID's value be unique on every row in the table. Can't be repeated for any employee. And it will also enforce the rule that it be not null. Now you don't have to specify not null. The primary key will do that as well for you in this case. Just as a reminder, the primary key automatically enforces the rules that the column value be not null and must have a unique value within the table. If you have a primary key that's composed of more than one column, you're going to need to specify this differently. I'll show you below. Here is the create table statement for the book author table that we've been using. You can see we have create table, book author, various columns specified. All of them are specified just not null, no primary key. But at the bottom, we have primary key, and then we say author ID, comma, ISBN, because we have a combination primary key on this table. It takes both the author ID and the ISBN number to ensure uniqueness on a row of the book author table. Now, also notice when you add primary key as a clause to the bottom of the column list in a create table definition, you do have to add a comma after that last column. If you didn't have that there, you wouldn't need the comma there, but here you do. So you put it at the end. You could put it at the end for just one column as well, but it's required if you have it as two or more. So let's talk now about a foreign key constraint. Now, we've already talked about foreign keys, and you may remember that a foreign key is any column or a combination of columns in one table whose values refer back to the primary key value of another table. The database itself, though, doesn't automatically enforce the foreign key rule unless you specify a specific foreign key constraint. Now, for example, if I wanted to be sure that there was always a publisher in the publisher table for every publisher ID that was referenced in the book table, then the create statements might look something like this. Bring this up a little bit so you can see both of them. This is the normal create table statement for the publisher. Pub ID, name, so forth. This is the primary key. Nothing exceptional here. But down here in the book table, we of course have a primary key for the book table, but down all the way below, I've bolded it to make it stand out. We have a comma, again after the last column, and then we say the word constraint, pub ID. In this case, we're giving this a name. We're just making this name up. Pub IDs, FK for foreign key, on the publisher table. You don't have to follow that system. This is just something I chose to do. There are other ways to name your constraints. We'll learn later that when you name a constraint, you can do other things with it later to enable it and disable it if you give it a name. Now, it's not just any constraint, it's a foreign key constraint. So I'm going to say what the foreign key is. It's the column called pub ID. And there's the pub ID column here on the book table. Okay, so I'm saying that is what the foreign key is. But the database still doesn't know what it's referring to, or what table, or whose primary key. So I put it on the next line, but you could put it out to the right if you'd like. I now say references publisher, that's the other table, and the column or columns that it references. So now the database itself will enforce the rule. If I try to delete a publisher out of the publisher table, and there are references to that publisher in the book table, the database won't let me because I specified this constraint. It's sort of a little traffic cop that I put on the table to make sure I don't accidentally make that mistake. Now we're ready for an exercise. Create a department table with a primary key of department num, and then create an employee table with a primary key of employee ID and a foreign key constraint on a department num column that's in the department table. As always, you can get this in your working files area, and I have a suggested solution at the bottom of this file. This lesson is on the check constraint. Now, just to review constraints a little bit, a constraint places further restrictions on what data values may be stored in a column. The first constraint, of course, is the data type. Things are numbers, they're dates, they're character data, and that restricts the data to be in those formats. The next most common constraint is the not null constraint that we've had, and that makes a value in the column essentially be required if you want to add a row to the table. You've also learned about the primary key and foreign key constraints. Primary key has the extra criteria. It must have a unique value across the whole table. And the foreign key constraint refers back to the value of another table. The foreign key constraint is usually named. The primary key and the not null constraints are generally not named. Now there's another useful constraint called the check constraint that allows you to specify further restrictions on what value is allowed to go into a column. So let's take a look here at this create statement. Create table employee, I put a primary key on it, on the employee ID. Also, on the salary, I put a default 0. That means that if I add a row to this table and I don't put in a salary, I forget to or don't have it for some reason, it will default to 0 instead of defaulting to null. Now at the very bottom here, I put in constraint and I gave it a name, salary check. And I said to check the salary column to make sure that it's less than $150,000. If it's equal to $150,000 or more, it'll fail this test. And thus, the database management system will prevent that row from being added into the database. So let's go ahead and I'm going to take this statement and we're going to go ahead and put it into the Oracle Apex area and run it there. Alright, so I have the statement over here and I stuck a 77 on the employee table just because I have a few versions of an employee table in my area and I'm hoping not to get a duplicate. So here we are, we've got the default 0, the primary key, and the check on the salaries. Let's try running this and see what happens. So it says the name is already used by an existing constraint. Now what that means is that salary check is what's being used, so I need to give that a unique name. So I'll try calling that salary 7, just to give it a unique name. So that's a good error to get. Let's try this again. This time it says the table was created and it did not have a problem with the salary name, salary check. So salary 7 check is a unique name. Every database object needs to be unique in the database so it can keep track of things. So how are we going to test whether this thing works or not? I'm going to use this Oracle Apex area to go around and use the object browser, and we'll use that to try to insert a row that violates the criteria and see how that goes. So let's go back to the SQL workshop. And then I'll look at Object Browser. And now we scroll down here looking for our table name. And there it is, Employee 77. So I'll click on that. And over here we have Data. So I can click on the data. And right now there is no data. But I can do an insert row. You're going to learn how to do that with SQL later. But right now let's just use this tool and see what happens. So I click on that. And it says to go ahead and put in some information. So I'll put 001 for the employee ID. Try my name, and put in Steve. A department code will be 003. Salary. Now here's where we have the risk, right? The salary needs to be under 150,000, so I'll say 200,000. The hire date, try this with the hire date and see if this is the right format. Actually, I believe it's 10/01/2013. So let's go ahead and we go down below and we have to find the button. So over to the right here a little bit where we create the new row. Let's click that. And it says error, check constraint, Steve Perry test. That's the workspace I'm in, Oracle Apex. But there's the name of our constraint, salary 7 check, is violated. It's violated because I made my salary too large. So it does work. The database will enforce the conditions that you put on the data. Let's go back to the SQL interface. So here we are back at that statement, and we'll move on. Now you can specify conditions by using an AND or an OR in the check constraint criteria. For example, I have another create table employee. It's the same pretty much as before. Constraint, salary check, check that the salary is greater than or equal to $10,000 and the salary is less than or equal to $150,000. So we're not going to let anybody get paid less than $10,000. In fact, I changed the default over here to $10,000 so I didn't violate the constraint. If I made it default 0, I'd automatically be in violation of that constraint. So I came back over to the Oracle Express area, or Apex, and I have an employee 88 this time. And I have the constraint, I called it salary 88 check, and I just brought this down to the next line, check salary greater than or equal to 10,000, and now I have to say, and salary is less than or equal to 150,000. So both these things have to be true for this to work, and down below I have the end parenthesis. Let's give this a whirl and see if this runs, and it does, creates the table. Now we'll go back to the browser, and we'll see if we can make this check work. Let's go down. We have table 88 this time, employee 88. We'll look at the data, of which there should be none, but then there's the insert row. Okay, so I'll try again. I'll say employee ID 2, last name Perry, Steve, apartment code 444. Salary is going to be, I'll say I'm not worth very much, $7,000. The hire date will be 10. I'll use the same thing I used last time. And let's see if this violates it. I have to go up and go over. Get that button to appear. Let's try it. I believe it's that button there. So it says check constraint is violated. There's the create button. So if I try this again, 01, Harry, Steve, apartment code 333, and this time I'll put a salary in that's valid, 12,000. And the hire date will be same thing. Go back up, hit the right button, click it, and we'll see if it comes through. And this time we got a row created, and you can see the row there, ID 1, my name, and there's my salary. So it allowed the data in correctly. All right, let's head back to the presentation. And now it's time for you to start this yourself. Create a department table that enforces the rule that the department number must be between 100 and 900. This lesson is on creating indexes. Now, indexes are something that is used to increase performance, just another way of saying speed, usually the speed of our queries. Indexes provide logical pointers to a physical location on the database. It's not something we need to worry about. We don't think about where the physical location of the data is, but the database management system does. And if we want queries to run faster, often index creation is something that we need to do. Now, a table index is similar to an index for a book in that it allows you to find information quickly. For example, if you were looking at a book index for the word Canada, you might have a 600-page book and find out that the word Canada appears on page 44, 56, and 123 through 124. A lot easier to find Canada using that index. You don't have to read every page of the book looking for it. That would take a lot longer. It's a similar concept with database. Some of the differences between a book index and a table index are, well, most books do have an index. An author creates them almost by default, or a publisher perhaps. But a table may or may not need an index. The creator decides usually whether columns, if any, should be indexed. There are other players that can get involved in the indexing game. That's the database administrator may add indexes or delete indexes to improve performance on a database behind the scenes. It's not something you have to be the table author to necessarily be able to do. Now, with a book, the reader decides whether or not to use a book index. But with a database, the DBMS itself decides whether or not to use a table index. There are algorithms that it goes through to determine whether that would be faster to use an index or faster to not use an index. Not something you need to think about. All happens behind the scenes. Now, unlike a book, which usually just has one index, tables may have many indexes. With a database, indexes are updated automatically each time that the data changes. Now, indexes are transparent to the SQL developer. SQL provides no syntax whatsoever that allows you to refer to an index in a query. Using a select statement, you can't say, select this using this particular index or not. Not your choice. Once an index is created, the database management system will make the decision on whether or not to use the index. Indexes may change frequently, so it's not something that you need to worry about. Now, they're created with a create index statement. Here is the create index syntax. Now you have the keyword create, just like we had when we had create table, only this time we're going to create an index. But between the word create and index is the word unique. Now notice it's in square brackets. That means it's optional. You may need to create a unique index, you may not. We'll talk about that as we proceed through this lesson. Now after you create an index, you give it a name, a particular unique name in the database, and you have to say what table you're going to index. So you say on table name and what column or columns are going to make up the index. Perhaps better put, what columns are indexed in the table. So here's an example. Create index. I give it this name, pub ID index, IDX, on the book table and on the pub ID. So it's the pub ID on the book table is what's being indexed here. So it's good practice to plan your indexes, but you can change or add or delete indexes later. That's just a choice either of a developer or a database administrator. Now, when we use more than one column, it's called a composite index. And you may use a composite index when two or more columns are searched as a logical unit. For example, it's common to look for first name, last name, or the other way around, last name, first name. The columns don't have to be listed in the same order in the index as they were when you created the table. For example, down here, create index, author name index, just a name I gave it, on the author table, last name, first name. But on the create statement, I believe first name came first. It's not important. You can index it any way that you find it to be useful. Now, here we are back to the unique index. Remember, unique is an optional word. If you need something to be unique across the whole table, you want it indexed, but you only want one and only one occurrence to happen on a row in the entire table. You have to specify the word unique on this index. Now, you've seen the primary key constraint, and it always has a unique index built for it behind the scenes. So it's not something you need to worry about explicitly on the primary keys. However, you can add a unique index to other columns if it makes sense. So here's an example down here. Create unique index, editor, social security number, short for that, SSN, index, on the editor table, SSN. So this ensures that we won't repeat somebody's social security number on the editor table. It's not likely that someone's going to have the same social security number, but you could make a data entry error. And this will allow the database management system to catch your error before you go too far. So what are good columns to index? And generally, the primary key, which of course is done automatically with a primary key clause, columns that need to be accessed in a sorted order. If you have values in a sorted order, it speeds things up tremendously to have them indexed. Columns that are regularly used in joins, where you're saying where such and such is such and such, or join this table using such and such on the other table, then it's important to index those columns. That can really help with pulling the joined information together. Now, columns that might be searched for a range of values, remember we used the between, or we used find some value that's greater than this and it's less than that. Looking at a range, indexes will increase the performance and speed of your query. Now, some indexes that are not useful might be columns that are seldom referenced in a where clause or in a join, columns that perhaps can only have 2 or 3 discrete values, male, female, red, white, blue, something like that. Especially if they're evenly distributed across your tables, then the indexes don't really help very much. It actually slows things up to use them. Fortunately, Oracle and other database management systems provide tools where you can pre-check out how your SQL statements are going to behave using the indexes ahead of time, and you can make determinations before you go live on what's the most optimum way to code your queries. Okay, we've reached the exercise portion of this lesson. Number 1, create a unique index on the social security number in the author table. 2, create a non-unique index on the editor name columns. As always, you can see this, it's in your working files, and you can see the solution that I suggest at the bottom of that file. This lesson is on modifying and removing tables from the database. You can modify an existing table. You accomplish this with the alter table statement here. And so you can add a clause to a column. You can use an add clause to add a column. You can use a modify clause to change a column. And you can use a drop column clause to drop a column. You may want to do this in some cases if you have a table that is in production in some way, lots of data in it, and you don't want to take the table completely down, recreate the data, or offload it and reload it in a new format. Sometimes there's small changes that you may need to an already existing table that you can do with this alter table statement. Now here is the alter table command syntax. The alter table is a table name. That's what you say. The keywords are alter table, and you give it the table name. Now here we see add, and you see an up and down pipe called modify, pipe, drop column, pipe, column name. Now the pipe means or in syntax land. So you're going to do an add clause, a modify clause, a drop column clause, or you're going to do something with a new column name and a definition for the column. So we'll look at some examples here. First, we have an example of an alter table with a modify. So here, we're going to change the author table, alter table, author, and we're going to modify last name column to have a varchar 2 of 80. So it might have been 40 before, but we want it to be a little bit larger. We found someone with a last name that was too large to fit in the maximum limit we had specified. So we can go ahead and change that on the fly. Okay to go larger. Going smaller may be a problem. So here we see the alter table with an add command, or an add clause. So we have alter table, and we're going to alter the author table. So we say add, and I have ext. That's a new column that I want to add to the table. It's for a phone number extension. So ext, and its data type is number 4. So that will add it to the bottom of the create table statement. It'll be conceptually the same thing as if I did that. Again, you can do this dynamically. You may have a working table in production and you realize, hey, I need another column. So you can use an alter table command to do that. So these are some modification guidelines. A column must be as wide as the data it already contains. In other words, you can't shorten it, especially if it's going to clip something off. It won't allow that. If a number column already contains data, the size cannot be decreased. Again, you can go greater, but not less. You can add or change default data, and it doesn't affect the existing data. All right, let's look at the drop column aspect of the alter table. It can only reference one column per execution. So you're not going to drop multiple columns with an alter table statement. You're going to do one at a time. If you need more than one, then 2 alter table statements are required. Once you delete the column, it is permanent. You can't recover or undo it in any way. You'll have to recreate it if you need it. You can't delete the last remaining column in a table. In other words, you can't have a table with no columns. Gotta have at least one. Doesn't make sense to have no columns. So here's an example. Alter table author. The keyword is drop column, and now we get rid of that extension. We decided we didn't want to carry that after all. You can actually rename a table. It's not something I've ever done live and direct, but you can certainly do it. So rename to is what you need. So the old name's no longer valid. So we have an example. Rename author to book writer. So we have a book writer table with all the data, new name, but we don't have an author table any longer once we issue that statement. Don't recommend you use it too often. Now let's talk about deleting a table. The key command is drop table. Okay, now when you drop a table, you get rid of the entire table structure, the thing that you did with the create statement, and the contents as well. So it's as simple as this. Drop table, sum table. So you need to be real careful. When you drop a table, it's gone. I often wondered why they use the word drop table instead of destroy table. If you create a table, you wouldn't think you'd drop it to get rid of it. But that is the key word you have to use, and that is standard SQL. Let's look at another way to get rid of data. There is something called truncate table. Now, the difference between a truncate and a drop is the truncate doesn't remove the structure of the table. It essentially deletes all the rows, but it's got a special criteria in that it does it pretty brutally. There's no recovery from deleting these rows. I'm going to show you in a later lesson how to delete rows from a table, including all of them if you want. But when you use the standard delete, your data can be recovered through a buffering thing called a rollback segment. So, but you truncate the table. So why would you do that? Why take away the protection you might need on a table? Well, if you're in a hurry to get rid of the data and recreate the data, like in a data conversion project, this can be very handy. Often deletes have restrictions on constraints and this sort of thing, and it's much, much quicker if you allow the truncate to just chop off all the data and proceed again. So again, use with caution. You will not get a backup of it when you do it this way. And now we're ready for the exercise. So try to alter the editor table to make sure that the editor last name is larger than it currently is. Add a birth date column to the editor table. Then create a temporary table named stuff and remove it from the database completely. So remember that you can restore our database to its original condition by using the method I showed you to originally load the data. That will restore everything back to the way that you had it. So as we go along deleting data, you want to get it back. We just need to run that script in Oracle Apex again, if that's what you're using, and then restore the data to its original format. This lesson is on using more constraints. Now, as you've seen, we can add constraints to existing tables. We use the alter table command to do that. We can add a not null constraint on using the modify clause of that, and some other constraints that can be added using the add clause. So typically, we add a not null after the column name when we're doing a create table statement. Well, let's say you've created the table, filled it with data, and you realize that there's a column that you probably should have specified as not null, but forgot to or didn't realize at the time, and you want to add that constraint later. So we can make a special constraint with a not null that can only be created at the column level. It's only added to an existing table using the alter table and modify command. Alter table book, modify year-to-date sales not null. Now that doesn't change anything else about the year-to-date sales, its size or that it's a number and what have you, but you're just putting a not null onto the year-to-date sales column. So another constraint we normally put on at the create table time is the primary key constraint. No duplicates are allowed in the reference column and null values are not permitted, so it is not null. However, for some reason, if you created the table and you didn't specify the primary key at table creation time, you could add it later with the alter table. Alter table book, add a constraint, and you give it a name here, book PK for primary key, and then the keywords primary key and the column you want to make a primary key. In this case, we're making the title a primary key. ISBN is a better choice, but this just shows that you could do this. Title should be unique on the table, so it would work. So next in our hit list here is the unique constraint. Now, the unique constraint is a lot like a unique index. It does enforce the rule that no duplicates can be allowed in the reference column from across the whole table. So if I put a unique constraint on my last name of Perry, that means no other person could have the last name Perry. Probably not a good constraint to do that, but that would be the effect. Null values are permitted when you have a unique constraint, so nulls are okay. So here's how you add it. Alter table book, add constraint, and you give it a name, book title, in this case UK for unique, and the keyword unique, and I'm going to make the titles unique on that table. Let's move on. This is one reason you would like to name your constraints, even not nulls or primary keys, potentially. You can use the disable or enable clause of the alter table statement. So look at the two examples here. We have alter table book, disable constraint, and we give the constraint name. Then alter table book, enable constraint. Okay, enable it. So you can turn constraints on and off with these disable and enable. The nice thing about this is you don't have to drop the entire constraint, get rid of it, and then recreate it. You can just temporarily remove it and then enable it again later. This is often done during data conversion projects when one company buys another company and they want to merge their database into the one that they already have existing. You go through some data massaging and often drop the constraints as you pull the data in. So that's one reason you might do that. So here is another option. We alter the table with a drop syntax. So we can drop a constraint. We can say alter table name, drop primary key, and then that pipe, remember that means or, the up and down symbol is a pipe. So we can drop primary key, we can make something unique, we can constraint name. So this is the syntax of the whole thing at large, but here's where the drop primary key comes. So alter table book, drop constraint. In this case, I drop the constraint on the constraint name. Notice it's not column name, it's the constraint name. Alrighty, now we're ready to do some exercises. Go ahead and create a table that looks exactly like the book author table, but this time just call it author book. Don't specify a primary key when you create it. Then go in and add a primary key constraint to it using the alter statement. And the second exercise here is to add a unique constraint to the name in the publisher table. We don't want any publishers to have the same name. This lesson is on adding data to a table. Now, the insert statement that you see here adds rows to a table. We can't add just columns by themselves. We have to add whole rows with information filled in for the various columns. Now, there's two basic ways to do this using an insert statement. We use the values keyword, and we pass values to go in the columns that we want to populate. We can also do a subquery. You've seen subqueries before, but we can put a select list below the insert statement and get it to run. And so we can populate many rows into a table by having multiple inserts happening. For every row in the sub-select, it creates an insert row for the super select, for the table we want to insert into. This is the basic insert syntax. You have the keyword insert and then the keyword into. Now you give the table name you want to insert into. We're only going to insert into one table at a time. Now notice that this is between square brackets here, this column list that's between parentheses. That is optional. You don't have to specify a column list. I'm going to show you how to skip that and when you can skip that. However, for the rest of this class, on all the exercises and all the assignments, I require that you specify the column list. Notice this says column 1, and below the values keyword, we have another list. We have a list of values. So constant 1 goes into column 1. Constant 2 goes into column 2. Everything has to line up. These columns and values must be equal. In other words, it must be the same number for them to work. All right, so let's look at an example here. If you were adding values to every column defined for a table, then, as I mentioned, you don't have to specify the column names. Now, the values entered have to be in the same order that were specified in the create table statement to get this to work. Okay, so publisher has a pub ID, it has a name, then it has street, city, and state. Notice I can wrap things around on an individual line. And so I don't have any list after publisher for the columns because it's going to fill them all in for the table. Let's go ahead and run this. I'll copy it and I'll paste it over here and see if this lines up okay. I'll go ahead and click the submit SQL statement. Notice that it says 1 row affected. So that's what we're expecting. 1 insert statement per row in general. So we insert into publisher values and it lined it up in a single line. So let's check our work. Let's go look at the publisher table now and see if everything looks good. To select star from publisher. And then we'll go ahead and click that. And there we are, Jordan Incorporated, 55th Avenue, Camden, New Jersey. So everything worked pretty well. Let's move on. Here is an example 2. If you add a row using less than all of the columns defined for a table, you must specify the column name. Now that's SQL's issue. My issue is I want to see all of the column names listed. It's important to practice that way. Most SQL ends up in a computer program at some point, and listing the columns is important. Let's take a look at this style here. Insert into publisher, pub name, pub ID, values, 7, health tech. So 7 maps into pub ID, health text maps into name. And so that should work. Each column must match a value in the list. So if I have 2 columns here, I'd better have 2 values down below. You will get an error if you don't. Now the columns do not have to be listed in the create table statement order. I could have put pub ID second and name first. That would have been fine. Then I'd have to switch the values as well. As long as they line up, everything's fine. This can get very unwieldy when you get 20 or 30 column table that you're filling in or inserting rows. And so sometimes it's easier to put each value in each column on a separate line. It can make it a little bit easier to troubleshoot if you have problems. And you will have problems. Everybody does with long tables. So let's go ahead and copy this and put it in here, and we'll see if this works. And it says, rows affected, 1. So insert in the publisher, pub ID, name, da-da-da. Okay, well, let's check it out. Let's go ahead and look at the publisher's table once again. Select star from publisher. Submit the statement, and there we are. Health tech, 7. Null, null, null. That's okay. We did not require these columns to be filled in. So we can go back later and update them if we'd like. So let's move on and we'll look at another exercise. So here's a third example. We use the select statement as a subquery to an insert statement. So let's look at this example here. Insert into author. Author ID, first name, last name. Select editor ID, first name, last name from editor, where last name equals Penny. This adds all the editors with a last name Penny to the author table. Okay, let's look at it. We select editors where the last name's Penny. And notice that these fields all match up. Editor ID matches to author ID, first name to first name, last name to last name. These all have to be the same. Before I run the statement, let's go look at the data and see what we've got here. Select star from editor. So I have an Ann Penny. Okay, so Ann Penny. Is Ann Penny already an author? Let's go ahead and take a look. So just the one person? Looks like we just have one. Okay, so Penny, Penny. Now, remember, if you want to see things in order, you have to use the order by. Order by. Okay, so Penny, Penny, Penny. Doesn't appear to be any Penny in there. All right, so let's go ahead and try this statement. One note here is that you need to have compatible structures. When you're inserting from one table into another, the matching columns must be either of the same data type or they must convert to the correct data type. For instance, if you have a character data type that has numbers in it and you're mapping it into a number data type, that'll be okay. As long as there's no character data in that character data type and it's all numbers, it'll map all right. Here we are at the exercise. Just one exercise, and it says to write the statements to add a new book to the database. So think about what statements are going to be needed here to get a new book in successfully, all the references and what have you. Its title is Confused by George Takei, and it's published by Sunshine Publishers. Any insert statements that you use should specify the explicit column name. So I didn't give you that much data, so just go ahead and make up any data for any other column that's required. So you can just play around with it. The idea is to get a sense of how you insert into a database and insert in all the tables where you get the references correctly, so everything connects the way it's supposed to. This lesson is on changing data in a table. Now the key statement we need to do that is called an update statement. This changes existing data in a table for a single row, a group of rows, or all the rows in a table, depending on how we do it. Let's look at the update syntax. Keyword is update, and then we give the table name. We update one table at a time with a statement. Then the next keyword is set. So I set column name number 1 to expression number 1. So this is some value or evaluates to a value, and then it gets set to the value of that column. And then if I have more than one column, I put a comma, and then I put column name 2 is to expression 2, and so forth. As many columns all the way up to all the columns on the table. Now you can see here that the where condition is in square brackets, which means it's optional. However, if you leave off the where clause, you are going to update every row in that table. More often than not, that's not what you want to do. So be really careful to put that where clause in with the update statement, or you're going to do more than you expected and have a mess on your hands. So these expressions do need to be the same data type. You don't want this to be a date and this to be a number. You want numbers to go to numbers, characters to characters, and dates to dates, and that sort of thing. Let's look at some update examples. Now the first one says to change the price on all the books in the book table to $17.99. And it says update book, set price, $17.99. I don't want to do that, okay? Trust me, it'll update everything. I'm going to go ahead and do this one down below that's a bit more precise. I'm going to look at the book called Analyzing the Obsessive, and I'm going to change its price to $17.99. So I would do that. I'd update book, set the price to $17.99, same as above, but this time I have a where clause, where title equals Analyzing the Obsessive. I'm going to show you a little trick. I'm going to take the where clause, and I'm going to put it up here. In front of the where clause, I'm not going to do an update right off the bat. I'm going to do a select from book. And this will let me take a look at the data before I update it. Here we are. Analyzing the Obsessive, $29.99. So I'm going to lower the price on this book. So here's what I can do. Again, frankly, I'm a little obsessive. Bring that where clause up there again. And I almost never code the word update without having a where clause right underneath it, just to feel confident that I'm not going to update all the data in the table at once. So, update book. And then I'm going to set the price. Set price equal $17.99. So this will update it, and then the select statement will run again to see if the price has changed. So let's give this a whirl. And voila! $17.99 is now the price for Analyzing the Obsessive. Alright, let's move on and look at another example. This one says, double the price and add $1,000 to the advance for all books that have sold more than 10,000 copies. So we're feeling pretty good about this book. We're making some money, so we're going to try upping the price, see if it still sells, and we're going to give the author a boon. Now, I'm going to use my little trick again. I'm going to take the where clause, put it up here, and put a select in front of it. This isn't always practical to do, but we're dealing with a small set of data from book. Okay, let's go ahead and run that and see what we get. So we have 3 rows. So we got price 43, 25, 25. We're going to double that, so they're going to be pretty expensive books. And we're going to add $1,000 to the advances here. So again, I'm going to copy this, or actually I'm going to copy the where clause up above the select, and I'm going to do the update. Update, book. I'll go ahead and copy this information in. Bring it back a little bit more so we can read it. So set price equals price times 2, comma, advance equals advance plus 1,000. And then we'll select this again so we can see the results. So here the prices, should see those go up and the advances go up a bit as well. So let's give this a whirl. And here we are. Prices have gotten even higher and the advances are a little bit higher. So that seemed to work just fine. And this ends part 1 of changing data in a table. In the next lesson, we'll pick up with another example and a more complicated demonstration. This lesson picks up where we left off at the last lesson of changing data in existing tables. So, I'm here at something that I'm calling a demonstrated exercise. It's an exercise you can do first if you want, but it's complicated enough that I wanted to walk through it with you. Here's the exercise. The publisher, Sunshine Publishers, has been relocated to Seattle, Washington. All of the authors that have written books for Sunshine Publishers have moved to a Seattle commune at 123 Flower Street. Make the appropriate changes to the author table. So if you want to do this first on your own, go ahead and pause this demonstration and go ahead and work it out, and then you can come back and hear my explanation. For those of you who have stayed, let's move on. I want to show you what I came up with. So here we are. That's a pretty large statement. I'm using subqueries to get information all the way back up to the author table. Now, I'm interested in Sunshine Publishers, so I pass that pub ID of the book table. And I look for all the books that are by that publisher ID for Sunshine. So I get a list of books by ISBN number. I pass the ISBN numbers up to the book author table to get the list of all the author IDs who have written books that are published by Sunshine Publishers. So I've got this list, and then I feed that to the where clause of the update statement and make all of those guys now living in Seattle, Washington. As you know, I don't like to start with an update. I like to start with a select. So I've copied this over earlier, so I'm just going to paste it in here so you can see it. So here, it's the same statement, except the first 2 lines are a select statement instead of an update statement. We've got all these selects. So let's go ahead and run this and see how it behaves. So we see that we have a list of about 7 people, and they live in various places in Utah, California, etc., San Francisco. So these guys we want to ultimately all be now living in Seattle, Washington. I'm going to go ahead and put the update statement in, and I'm going to paste this in front of the select statement. I copied it earlier just to make this a little easier. So you can see it's an update, City, Seattle, Washington, and this where clause and all the subselects is the same as before. So we'll do the update, then we'll do the select again and see how the effect is. Okay, I accidentally hit the button twice, but that's not a big deal. We can see that the effects are here. We've got Seattle, Washington for all 7 of those authors that we were looking at before. So now they're all in Seattle, Washington. So this is a successful statement. Now it's time to do an exercise of your own. This is a little simpler. Reduce the price of all books by 20% if they have sold under 1,000 books this year. As always, you can see the solution at the end of this file in your working files area. This is changing data in a table. And this ends the lesson on using the update statement to change data that exists in a table. This lesson is on removing data from a table. Now, to remove rows, we use the delete statement. You don't use the delete to remove a structure of a table. That you use a drop table statement for that. That gets rid of the data as well. But the delete statement just deletes rows. If you wanted to get rid of a column value, you would use an update statement and just set that column to null wherever it matched the criteria you specified in the where clause. But the delete removes rows, just like an insert statement inserts rows. So now here's the syntax for the delete. You have delete from, those are the keywords, and then you give the table name. Now, you have an optional where clause. However, just like the update statement, if you leave the where clause off, you delete all the rows in the table. Notice you don't specify anything between the delete and from. You don't say delete star from. You just say delete from and give the table name. So here are some examples. The first one deletes all the rows from the book table where the price of the book is $2.99. So where price $2.99 from book, delete. Okay? So you'll only delete that book or books. However many have that price will be removed from the table. Now this is the one that you want to be careful of. Delete from book. It gets rid of all of the rows in the table. And while you might be able to recover, certainly you can recover here by using this restore procedure on how to reload the database anytime you need to. In the real world, you don't want to be deleting all the rows on a table, unless you're part of a data conversion project or something like that. Generally, it's not done. Alright, here's another example. Now this deletes all the authors who have the same last name as any managing editor. Now this is a subquery, like we did with the update and the insert. So we're going to return a list of last names here that are managing editors. I'll go ahead and copy that, paste it in here, and run it. And you'll see that we have two last names. Penny and Perry are managing editors. So we would delete anything from the author table that had a last name of Penny or Perry. You gotta be careful if there were two authors you had in mind with that last name that you wanted to delete. Someone else gets added to the database that has the name Penny or the last name Penny, they would be deleted as well. So you can have unintended consequences when you're using deletes and updates, especially when you use a subquery. So do be careful. I'm not going to run these statements. I think you've gotten the idea with the update and all that, but I'm going to give you a chance to run some in the exercise and then restore the database. So here is the two exercises. Go ahead and delete all the authors that live in Oakland, California. Then restore the data. And then number 2 is Sunshine Publishers has gone out of business. Remove all relevant information from the database. Now, think about this. I have some information actually in the solutions when you go to your working files and get this HTML file that contains this lesson. Go to the bottom and I have a little discussion on the kinds of things you need to think about when you delete things that may be referenced by other tables and the constraints that you've set up. This presentation is on assignment 11. So use your SQL interactive tool of choice. I've been using Oracle Apex. Now, one note, all these questions must be answered with a single SQL statement unless otherwise noted. And a second note, I want you to explicitly specify the column names that are being affected by the statement or statements that you use. So let's look at these questions. Question 1. Code a SQL statement to add Books R Us as a publisher to the database. The publisher ID is 7. The address is 456 Publisher Lane in St. Louis, Missouri. Question 2 says to change the type, this is the type on the book table, to geeky for any book that has the word computer or networking in the title. Now, it is case sensitive in Oracle, so I kept it with a capital C and a capital N here. You don't have to look for all possible combinations, just these ones that are specified. Now, the last one is to remove all the authors that live in Utah. That is your assignment that will exercise some of these principles that we've learned about inserting, changing data, and deleting data in the database. This presentation is on the solution to assignment 11. So let's look at question 1. Code a SQL statement to add Books R Us as a publisher. So we've got the publisher. We insert into publisher, pub ID, name, address, city, state. So this is the information. Numbers don't have quotes around them, so that's fine. And then Books R Us in quotes. The street and the city and the state are all in the single quotes. Now change the type to geeky for any book that has the word computer or networking in the title. So you know you're going to update the book and you're going to set the type to be equal geeky. But we need a where clause. And here's our old friend pattern matching. So where title like computer. And you can have computer, the % beginning and after, so it's contains in. So where computer is contained in title or networking is contained in title. So that will get you all the books that need to be updated to geeky. Question 3 says remove all the authors that live in Utah. There it is. Delete from author where state equals UT because we store our data in a 2-character state code. This lesson is on string functions. Now, string functions are a subset of single row functions in general. We've seen functions before that are used in group by, like the sum, average, and count. Those functions often affect more than one row. Now, a function, if you look at the first bullet point there, is a predefined block of code. It may accept data, and it may return data, or affect some change in the database. We've seen the ones, of course, that do multiple rows, but the single row functions operate on one row at a time. Single row functions are also known as scalar functions. Now, one type of single row function, or string function, is a case conversion function. These are used to alter the case of the data stored in a column or character string. And by case, I mean uppercase or lowercase, that sort of thing. So they're often used in a select statement. They alter the appearance of the data in the results. You can use these conversion functions to temporarily convert data. It doesn't have to be a permanent change to the database. You see something different in the results, you can use them in the where clause. And they alter the value temporarily for comparison purposes. Alright, let's look specifically at the lower function. It's used to convert characters to lowercase letters. Now, it can be used to affect the display of characters. Then you use it in a select clause. To modify the case of the characters for a search condition, it is used in a where clause. So let's look at the syntax and an example. So the syntax is pretty simple. You just the keyword lower, you see over here, lower, and in parentheses you pass the column name or some value. You can use a literal value. Technically, this would be lower expression. More often than not, the expression is simply the column because you want to affect the value of something that's in a column. It's not so useful to affect the value of something you key in because you could just make it lowercase. You don't need to apply a function to it to turn it into lowercase, but it will work that way. So here's an example, a very simple one. Select lower city from author. Why don't we go ahead and run that? I'll go ahead and copy it in, cut and paste, go over here, submit it. And you can see the results. Lower city, St. George, the S is small letter, Chicago. Everything begins with a lowercase letter. The normal mixed case presentation have made it all lowercase. So it works. Move on. The upper function, of course, works the other way. It converts all the characters in a string to uppercase letters. It's used the same way as the lower function. It can affect the display of characters in the select clause, in the select list, and you can modify the case of characters for search condition when it's used in the where clause. The syntax for the upper clause is very similar, you may see, to the lower clause. It's just the keyword upper, a column name, or value. So let's go on and show an example. So you see we have select city from author where upper city equals Oakland. So I'm using this a little bit differently. And I make a note here says that this forces a case-insensitive search. So what do I mean by that? A case-insensitive search. Well, if we look at all the city names, right? Here's the city column. And internally, as we're running this statement, we convert all of the cities to uppercase. Again, not a permanent change in a database, but on a row-by-row basis. Remember, these scalar functions or single row functions happen one row at a time. The database reads a row, makes the city uppercase, and then it compares it to an uppercase version of the word Oakland. Now, if Oakland were in our database as uppercase, it would be a match. If Oakland were in our database as lowercase, it would be a match. If it were mixed case, it would be a match. So, because since we take no matter what city is and we make it all uppercase and then compare it to an uppercase value, we are essentially making this a case-insensitive search. Let's go ahead and give this a whirl. I'm going to copy it, paste it in here, and we'll run it. And you can see that we have matches here. I didn't put anything else other than the city. I could have put the author's name and what have you. But I see Oakland, Oakland, Oakland. Now it matched to Oakland with a capital O and all lowercase because I did not change the original value. I just compared to all uppercases, so I'd always get a hit. So this is one way to do a case-insensitive search in Oracle. The downside is, if you do this on a table that has hundreds of thousands or millions of rows, there could be a performance impact because this function is going to operate on every row of the results, or every row of the database, or the table rather, as it's going through making this comparison. So it's something you have to evaluate on whether you want to do this kind of case-insensitive search or not, depending on performance. Now we're going to talk more broadly about character manipulation functions. So character manipulation functions manipulate the data by extracting substrings, counting the number of characters, replacing one string with another string, that sort of thing. Let's look at the first thing here, and we'll look at the substring function. The substring function is used to return a substring, which is just a portion of the original string. And let's look at the keywords here. So it's substr, substring, and then in parentheses, you put the column name, comma, and you put the starting position. Do I want to look at the very first position for the substring and move on? That's what I want to pull out. So I put that in. Now, if I don't put in length of string, notice that length of string is in square brackets. That means it's optional. And so the default will be the starting position to the end of the string. But if I want to do starting position for just 2 characters of the string, then I put the 2 in there. Sometimes this might be easier to see as an example. So let's move on. So here's some examples. To return a substring of the word hello, starting at the second character and continuing to the end of the word, use substring hello, comma 2. So it starts here on E. Now, for those of you who are familiar with other programming languages, often you start with a 0 for the first character. In Oracle here, they start with the letter 1, a more human way of looking at it. We think of H as being in the number 1 or first position. So that's the way it's done in database land. Interestingly, if you put a 0 out of habit, it actually converts it to a 1 for you automatically. But it won't do that for the rest of the positions. So better just to do it right. So we're going to start in position 2, which is number 2, and E, and to the end. So this would return hello. Okay, so E-L-L-O. Now, clearly you wouldn't normally be using a literal on the word hello. You would have a column name there whose value would happen to be hello. And that's what would be returned in that row, E-L-L-O. If we wanted to look at hello again, and starting with the very first character and continuing for 2 characters, we would say string hello, or column name, comma, 1, comma 2. So it says start in the first position, which is H, and go for 2 characters, so H-E. We should be returning H-E. Move on just a little bit and look at this other example. We have select, distinct, substring, and we have phone, comma, 1, comma 3. So it's going to look at the first position of the phone number and go for 3 digits. So that's going to be the area code if we store the area code in the phone number. So while we're going to return the area code, perhaps on the author table, we have many authors with the area code 937 and then some with 831, etc. So the distinct clause will apply against the entire result set. The substring applies on each row that's being evaluated. You got to keep that in mind on how these clauses are evaluated. Okay, we'll take a short break here and pick up where we left off in the next lesson. Picking up where we left off in string functions, here's another function. It's called the length function, and it's used to determine the number of characters in a string. So we have select length title from book. Let's go ahead and run that. It's just going to tell us how long the title is. I'll paste it in here. We'll run it. And here we see length 24, 21, 23. Now, if we wanted to see the actual title itself, which probably would make sense, I'll put the word title in there and we'll go ahead and run this again. We see now Silicon Valley startups, 24, 1 hour negotiations, 21, so forth. And we go on and we get the length, the number of characters, including the spaces, in the title. All right, let's move on. Here we see the replace function. Now it substitutes a string with another specified string. So let's look at this example here. We replace in the city column the word oak with spruce from the author table. Now I know I have a number of cities there that say Oakland, so now they're going to say Spruceland. Again, because it's in a select statement, I'm not actually replacing the values. You can do that if this were in an update statement, but in a select statement, it's only replaced during the length that the statement runs, not permanently to the database. Let's copy it and paste it here, and now we'll run it. So you can see we have St. George, Chicago, Rockville, Spruceland. There it is. That would have been Oakland. Spruceland, Spruceland. So the replace worked, again, just in what we see in our results, not back in the original database. Not the data has not been changed. Here's another function. This is called the concat function, short for concatenation. and we can put two character strings together, or more. So in this case, concat, city column, comma, the next value, which is a comma and a space, and you put that between single ticks, comma, and then state. So I'm going to get St. George, Utah, or whatever from the author table. Let's go ahead and take that and run it. I'll put it over here, and let's try this out, submit it. And here's the result. St. George, Utah, Chicago, Illinois, Rockville, Maryland. Now we could use in Oracle the double pipe symbol to concatenate these together, and I would say that's probably more often used than the concat, but the concat may help you in certain situations. Alright, here we are for the exercise. So let's take a look at this. I'll bring this to the top. So it says display a list of author names shown in the following format. Last name, comma, first name. No quotes. Don't put these double quotes around it. Go ahead and use the concat function. For example, if I were stored in the database, it would appear as Perry, comma, Steve. Again, no quotes. But I only want you to display rows where the city is equal to Oakland. Now notice I put this all lowercase. So I want you to use a function to make sure we get a case-insensitive search on the lowercase word Oakland. So keep Oakland in lowercase in your where clause. Alright, that's exercise number 1. Exercise number 2 is to display the author's last and first names, city, and state entirely in lowercase characters. But change all the states that are California to be Florida, with FL. But only do that for all the cities whose names begin with S. So these exercises are allowing you to not just bring in what we just talked about, but to remember things that we've talked about before and integrate them into the SQL statements. In the real world, that's what you're going to need to do. So I'm giving you a chance to reuse techniques that you've learned in the past. Alright, let's go back to the top. You can always see this file in the working files area, the string functions.html, and you can scroll to the bottom to see the solution that I've suggested. This ends our lesson on string functions. This lesson is on number functions. These are scalar functions or single row functions, and they allow for the manipulation of numeric data. Here are the 4 we're going to discuss. They're called the round function for rounding a number, truncate for truncating off a decimal place, mod, and ABS for absolute value. The mod is for remainder. So here is the round function, and it rounds a number off to the specified precision, essentially the number of decimal places. It's common to round something off to an integer, so we have here select title, price, round, price, comma, 0. That will get us to the integer. It takes away the decimal places. Now you notice in the select statement I'm showing price in its original format, and then I'm showing price as rounded. So let's put it in here and submit it. And if we look at the results, we'll see we have 40, and this is 40 without the 00. 29.99, it's been rounded up to 30, or 21.95 to 22, and so forth. So the rounding takes effect. So we see both the original value and the rounded value. The trunc function truncates a number off to the specified precision. So if I said select title, price, and trunc price, comma, 0, it'll actually get rid of the decimal place. It won't round it, it'll just chop it off. Let's go ahead and select this, paste it into here, and then we'll run it. And you can see that we have price over here at $40 and the truncated price at 40. That's the same as the rounded amount. But here, $29.99 becomes 29, not 30. When we round it up. In this case, we just chopped off the 0.99. So if we only wanted to chop off a single digit, we would change this to trunc price 1. Go ahead and try that out and see how that behaves. So here we are. We have 40.0, 29.9. Okay, we can't have decimal places still. When we use the trunc or the round, it behaves in the same fashion. We just specify what the precision is. Let's move on. Alright, let's look at the mod function. It doesn't mean modern. It means modulo, essentially, in mathematical terms. And it finds the remainder of a division operation. So if I put in a statement like this, select title mod 235, 16, it divides 16 into 235, and it doesn't give us the answer of the division, it gives us the remainder. So let's see how that behaves. I'll copy that and paste it. We'll go ahead and run it. And you can see we have 11, 11, 11, 11, 11. Well, that's because this statement here is operating just on a literal number, 235. So it's going to give us the same answer. So it evidently goes in however many times, and it's got a remainder of 11. So we can use a column name instead of a literal name there if we needed to do that. If we needed to get a division, a column divided by some value, what is the remainder? Let's give that a whirl here. I'm going to change this to price. And I'll put in the original price, and we'll go ahead and run this and see how this behaves. Interestingly, we have 16 into 40 leaves a remainder of 8, but it shows it as 8.00, and here, because we have decimals, we're getting 99, so we divided a number, and here 16 goes in here once, and then leaves 1399 as a remainder. So if we wanted this to appear as integers for some reason, we would have to nest functions, which I haven't really talked much about, but let's just say we wanted to do that. I can put round. I'm wrapping the whole thing into a round statement. So it's going to do the mod stuff first, and then it's going to round up to the nearest integer. So let's run this and see how that behaves. So you can see here, we have the price, and now it's rounded to the nearest integer because I've done that. So I've nested these functions. You can always do that. You can put a function within parentheses of another function and get that to work. Sometimes it can be confusing, so you want to be careful. But just be aware that nesting functions is allowed. So lastly, we come to the ABS function, which is absolute value of a number. Now that doesn't get you much unless the number is negative. The absolute value of 2 is 2. The absolute value of negative 2 is 2. I've done something here. I'm displaying select title and I say price minus 100. That'll guarantee that that's a negative number. And then I get the absolute value of price minus 100 because we don't have any natural negative numbers in our book. Okay, I'm going to come here, I'm going to select this and put this in here. Now, I'm going to even add the original price to the select statement. So price minus 100, absolute price. Let's see how this behaves. All right, so here we are. We get the results. So we see the original price is minus 40. Price minus 100 is negative 60. The absolute value of that is 60. Pretty much just saying we're getting rid of the negatives here. So it behaves and does what you need it to do. We are now ready for the exercise. List all authors and the books they have written and their royalty share in its original value, its rounded value, its truncated value. So authors, when they write a book, they have a royalty share. If the authors have written one book and they are the only author, the royalty share should be 1.0, which represents 100%. If they write it with someone else, there'll be a split on the profits. So show it in your original value, its rounded value, and its truncated value. Now, since it's stored as 1.0 and that sort of thing, or 0.65, you probably don't want to round it to the nearest integer. It might probably be 1 or 0. So maybe just round it to its nearest 10th decimal or something like that. Anyway, give it a whirl, and you can see what I suggest for a solution down below. When you go to your working files area, you'll see it there is numberfunctions.html. This lesson is on date functions. Now, date functions are used to perform date calculations or to format date values. Now, to illustrate some of these functions, I've added another table to the database called order item. So order item, create table order item. You've got an order number and item number, and they're part of the primary key down here. ISBN number for the book, and I have quantity, and I have the order date, and that's what I'm going to concentrate on. So now I have a published date in our database, and I have an order date for someone purchasing this. So I'm going to just use this to illustrate a function that calculates the months between two dates. So here is the months underscore between function. So it just determines the number of months between two dates. So I have select title, order date, pub date, round, months between, order date, pub date. Remember, I can nest, so I'm concentrating on this. I'm looking at the published date in the book table. So I look at the months between, and then I'm going to round this to the first position, just the number of tenths on the date. So to get this, I have to join book and order item using the ISBN number. So let's go ahead and run this. I'm going to run this in the Oracle Apex area. Let's copy that, and we'll go over to Oracle. So here we are in Oracle Apex, or Application Express. And one thing I really dislike about this Oracle Apex is it defaults the number of results you want to see to 10. So I try to remember to at least bump that up, because even in a small database like we're using, we often get 20 or 30 rows returned. So let's go ahead and do this. I'm going to run this, and you'll see we have order date, pub date over here, and the difference in months is 1.7. Because if you think about it, August 2nd to June, or actually the difference is really the other way, more thinking of June to August in this case, it's about 1.5 months or 1.7 months, so it rounds it off to that. And so you can get it to 0 if you want to by making the rounding 0 instead of 1. So that gives us a date difference. Let's go back to the presentation tool. Alright, let's pick up with the add underscore months function. This adds a specified number of months to a date. It's pretty simple. We just have here, select title, pub date, add months to the pub date, add 2 months to the book table. Let's copy it, and I'm going to go to the Oracle Apex area again. So here we are. Select title, pub date, add months. Let's give this a whirl and see what it looks like. So here we are, Silicon Valley. So this is starting in June, and now we've bumped it up to starting in August. We've added 2 to everything, and they're all, oh no, here's one that's October. So it put it up to 12. So that worked out quite well. Let's try something here. I'm going to add 3, and we'll see if we can get that to bump to the next year. Put in 3. I'll run this again. If we go down here, where we had 10, notice it says 10, 21 through 12, but it bumped it up 3 months. It was smart enough to know that it went to 213. So let's go back to the presentation tool. All right, here's another function. It's called the next day function, or next underscore day, and it determines the next occurrence of a specified day of the week after a given date. This is unusual. Let's look at it over here. Let's look next day, pub date. I'm saying, what's the next Monday after the publication date? Okay, just what's the next Monday? All right, let's see how it works. And here's the original pub date. And I'm running this on a Thursday, but it won't matter because we're looking for the pub date. Copy, go back to the Oracle Apex area. So here we are, select title, pub date. Okay, next day, yada yada. Let's go ahead and run that. And here we are. So it says it was published on June 12th, but the next Monday after that appears on the 18th. Okay, and likewise down here, 10/21st, the next Monday is the day after on the 22nd. Good to know. It can be a handy date function. Let's go back to the presentation tool. This is the next function. It's called the toDate function. Now it converts various date formats that you might pass a date to Oracle, and it converts it into the internal format that's used by Oracle. You might not have a date in the proper internal format, so you're going to have to convert it before we either update the database or we select it in that format. So let's take a look. Select title, pub date, to date, March 15th, 2014. And now this is the mask or the pattern. We say, look at this string I passed you. Know that this first part is a month, a long-term month. Know that the DD is a 2-digit date, and there's a comma, and then we have a 4-digit year. So it's going to make this conversion. Now here I'm not doing much more than displaying it, but I could, if I was doing any kind of comparison internal date, I'd need to do this. And also, more often than not, this is going to be used in an update or an insert statement where I'm actually storing a new date into the database, but I have it in this format and I need Oracle to understand how to get it into its internal format. We'll go ahead and run this over in Apex. Let's copy that. So here we have the select statement, the pub date, and I moved the next column down below because we have the full expression here. To date, March 15th. Let's go ahead and run this, and we can see we have an invalid character. Now, usually this is something a little flaky with that put in a space, but in this case I have a hyphen and an extra quote here. So let's just go ahead and take that out, and we'll go ahead and run it again. So here we are, pub date. And then it says to date, March 13th. So it's showing here in the Oracle native format. Apex is a little weird. This format here, the 03/15/214, that's what Apex uses, but the actual Oracle internal format is a 2-character day followed by a 3-character month, like JAN for January, and then a 2-character year. So it's a little odd. Apex, the tool, does it differently than Oracle, the system. So it can get a little bit confusing from time to time. Go back to the presentation tool. So how do you know what are the date formats to use? The date formats or the masks or the patterns that you need to recognize. So here's a little chart. You can look this up online, of course, but month is the name of the month spelled out, okay? MON is the 3-character abbreviated month, like FEB for February or APR for April. So MM, the month, is a 2-digit month, so forth. So this tells you, this little chart can help you out. Of course, you can look at the Oracle documentation online as well and easily get this chart. Now this is the toChar functions, the next function, and it goes the other way. it takes dates and numbers and makes a formatted character string out of it. We're going to look at a date. So we have select title to char pub date. However, it's stored in the database, Oracle internal format. But I'm saying I want to see it as month, day, and a 4-character year. I don't care how you've stored it. I want to see it looking like this. So let's go ahead and copy this, and I'll put this in the Oracle Apex area and run it there. Here we are in the Oracle Apex, title to char pub date, month. Let's run it. And here it is. We see June 12th, 2012. We see it in the format that we asked for. Over here, October spelled out, 5th, 2012. So it works. This little hyphen in Apex is what they do for null. Go back to the tool. We're ready for the exercises. Number 1, add 1 year to the published date of all books. You can just select that. You don't have to update the book, but you can if you wish. And number 2 is to list the published date of all books in the following format. MON, which is a 3-character month, day, comma, year. So we should see May, M-A-Y, or APR, or FEB, like that, not completely spelled out. This lesson is on limiting rows in your result sets and on something called the dual table. Let's look at limiting rows first. In Oracle, all tables have a hidden column called row num. Okay, to indicate the row number on the way Oracle is storing the database and the way it might come back to you in a result set. Now you can use it to limit the number of rows affected by a SQL statement. For example, you can say select star from author where row num less than or equal to 2. So that's saying give me essentially the first 2 rows when we do this. So I'm going to copy this and we'll go over to Oracle Apex and take a look at it. So here we are in Oracle Apex, and I have the statement, select star from author, row num less than or equal to 2. Run it, and it gives me 2 rows. So the first 2 rows that Oracle thinks are at the top of the heap are Albert Singer and Ann Singer. And so this can be handy if you want to limit what you're going to affect in a table, or if you just wanted to look at a little bit of data and suspect that the way that you coded your select statement, you may naturally pull back tens of thousands of rows, but you really only want to see 5 or 10. You can add to the where clause, where row num less than or equal to whatever number of rows you want to see, and that's how many you'll get. Let's head back to the presentation tool. So where this can be handy is when you want to limit the number of rows that can be updated or deleted. So the row num can add a little extra insurance that you're only operating on 1 row. Look at this. I have an example here. Select star from author where last name equals singer. Now I've seen already that that should bring back 2 rows. Now if I say delete from author where last name equals singer, mistakenly thinking that that's enough just to delete 1 row, I can say end row num equals 1. That will ensure that at most 1 of the singers will disappear. And then afterwards, I have another select from author where the last name equals singer. Let's go ahead and we'll run these in the Oracle Apex area. Now, in the Oracle Apex area, I can only run 1 statement at a time. So here we are in Oracle Apex. Select R from author where last name equals singer. Let's run it. And we get exactly those 2 rows we saw before, because there are just 2 rows. Now we'll go get that delete statement back in the presentation area. So here's the statement. I'll copy it. Here we are, delete from author, where last name equals singer, and row num equals 1. So notice we have Albert and Ann from before. Let's run this, and it said 1 row deleted. So we know we didn't get rid of both singers. So let's go ahead and run that select statement again that I'll get over from the demonstration area. Okay, so I copied it in here, and now we'll see who's left. Run it. And just Ann Singer is left. We got rid of Albert, but not Ann. Now you have to be careful. That may not be what we intended to do. But if you just got rid of 1 row by mistake instead of potentially tens of rows or hundreds of rows by mistake, this would have limited the damage. Here we are back at the presentation, and now we're moving on to the special construct known as the dual table. Now the dual table is a dummy table. It means it's just a placeholder. And the reason Oracle provides it is a select statement at a minimum needs to have the keyword select, then after that a column list or star, asterisk to see them all, and it needs to have a from clause and at least 1 table. You can't select something from nowhere, so it has to be selected from somewhere. There are some statements you might want to run, doing some math, for example, that have nothing to do with columns or tables that are existing. So the dual table is used to provide a dummy placeholder table to get SQL to run. If you look at it, it consists of 1 column and 1 row, and it's just got the value X in it. not useful for anything other than being a dummy table. So we use this table reference in the from clause. So here's an example. Select sysdate from dual. Let's go ahead and run that in the Oracle Apex area because sysdate is very useful actually. So here we are in the Oracle area. Now this, when we're running on a server, this is going to return the date that it is now, date and time that it is on the server. So if you happen to be using SQL in applications that you're running, getting the date from the server provides more consistency than using something like JavaScript to get the date on a user's computer. The user's computer can be completely non-standard, so this is a good way to get the current date and time. So let's run this. So there it says 5/15/2014. So we've got the date here. Okay, so let's take that. You can see that we had from and dual. I can't just run select sysdate. Okay, so you need that to get back. Let's go back to the presentation. Move on here, and here's a couple of more examples. I can just do some division. I can get the length of a name. So let's try the division first. So here we are back in Oracle Apex. I'm just doing some division. You may remember we did something like this before with a mod function. Let's run this. And so we see that it goes in 16 times, but it doesn't show the remainder, if there is any. Apparently not from that one, but if there is a remainder, we would see that as expressed as a decimal. Go ahead and do that just to see that happen. And so we get there as a decimal. If we use the mod function as we talked about earlier, we could pull that off as a remainder instead. Let's go back to the presentation and I will get the other example. Alright, here we are. Let's pick that up and go back to Apex. Format it back in here from dual. And so I'm going to get the length of Ranganathapuram and see how long that name is. So I click run and we get back 15. So there's 15 characters in Ranganathapuram. Back to the presentation tool. And now we're ready for the exercises. Round the number 1.6789 to 2 decimal places and display it. Exercise 2. Show the first 9 books in the book table that have a price greater than $20. You can find this in your working files on limiting rows and the dual table. This presentation is on assignment 12. Use a SQL interactive tool of your choice, like the Oracle Apex area that I've been illustrating, to work out answers to the following questions. All the questions must be answered with a single SQL statement, unless otherwise specified. And if there's any call for column names to be left in or left out, make sure that you specifically list them. Okay, let's go and look at these questions. So the first one says, display the book's title and price, but code a case-insensitive search for rows where the word computer or silicon is found somewhere inside the title. So you have to use pattern matching again for that. Question 2 says to list all the authors and the books that they have written and the price of the book, but put that in its original value, but also display the price where it's rounded to the nearest integer. The third question is to insert a new row into the book table. You can make up any values that make it work, but use a date function to pass the published date value in the following format. Move up here. Send it like April 1st, 2014. So send the date to that table that way in the insert statement. Use whatever function you need to get it stored internally correct in Oracle. So question 4 says, list the title and the published date value for the row you just inserted in question 3. But this time display the date in the following format, the 04/01/14. Question 5 asks you to round the number 3.14159 to 2 decimal places and display it with a column heading of pi. Lastly, in question 6, show the first 4 authors in the author table that live in California. So we've got some criteria there. And I do believe that ends it. It does. So this ends the presentation on assignment 12. This presentation is on assignment 12's solution. So let's take a look here. Go look at question 1. Display the book's title and price, but code a case-insensitive search for the rows with the word computer or the word silicon found inside the title. So title, price, from book, where lower title equals %computer, and I did that as lowercase. The word's actually stored with a capital C in there, but this forces a case-insensitive search. The same thing with silicon, so where it's that or it's like that. Moving on question 2, all the authors and the books they've written with their price in the original value and the price rounded. So last name, first name, title, price, there is the rounding of price to 1 and the title rounded. From author, we join using the author ID and the ISBN, like you've seen before. Now, question 3 asks you to insert a new row in the book table to make up any values. Use a date function to pass the published date value in the following format. So we're going to do it April with a long month. So here we have book, ISBN, title, pub date. The ISBN and title are the only not null columns that are required, and I asked you to deal with pub date. So I made up a new ISBN number. I gave the book Happiness in Doggyland, and then afterwards to date, and I passed the value like that, the way I have it, and there's the date format, long month, 2-character day, comma, and then a 4-character year, and that will get it inserted into the table. So question 4 says to list the title and published date for the row you inserted in question 3. Display the date in the following format. So now, even though we added it in a long month format, I want it to come out this time in this format. Select title to char is the function you need on pub date, and I'm saying show it to me like this, month / day / year from book. Question 5 says to round 3.14159 to 2 decimal places, column heading of pi. So here's the round, 2 decimal places. If I wanted the column heading, I would take the quotes, the pi here, and just put it after this expression, and that would give you the pi. So moving on, the last question is number 6, which show the first 4 authors in the author table who live in California. So author name, last name, the state. From author, where row num less than or equal to 4 and the state equals California. So that will do it for you.
Subscribe now and press the bell icon. Never miss an update.
This lesson is on creating views. What is a view? It's a permanent object that stores no data. So why have an object that stores no data? Well, what you do store is a select statement. So you create a name of a database object, a view name, and that becomes a stored select statement. So if you select from the view name, you run the select statement associated. Why would you want to even do that? There's 2 main reasons. 1, you can reduce complex query requirements. Now, you know how to do a 4-table join, but not everybody does. So you may have some users out there, some coworkers that have certain SQL skills, but not as advanced as yours. So you provide them with a view into all the information that would be returned from a 4-table join. And then they select against the view name instead of the table names. That simplifies the process from their end. They don't have to think about it. Now, the other reason to have a view is to restrict access to sensitive data. For example, if you have an employee table, there might be the employee's salary on that. Well, you don't want everybody to see that, so you create an employee view. You might just provide their first, last name, office location, their telephone extension, that sort of thing. You make the view available to anybody in the company, but the employee table itself is only available to people that have the right security rights to see that information. Now, we create a view using the create view keywords. No surprise there, you've seen create table, create index. Now we have create view. You can use a little option between the create, which is create or replace view, if the view already exists. That way you don't have to drop the view first and then recreate it. You can provide new column names if you want or desire to override the column names that are stored with the associated select statement. I'll show you how to do that in a moment. So here we have the create view syntax. So we have the keyword create, and then in square brackets we have the words or replace. That means it's optional. I usually use them because why not? I never have to worry about dropping and then recreating a view. So I say create or replace view, and then we give a view name. So that's something we make up. We can provide a list of column names if we want to override the column names that are brought back by the stored select statement below. We put this select statement after the keyword as. Now here's a create view example. Example number 1. So we create or replace view editor info, just the name I made up, keyword as, and now we just put a select statement. Here I'm selecting last name, first name, phone, editor position from the editor. That's not all the columns. Let's take a look at the database diagram. Here's the editor. They have editor ID, the social security number that I've left off, and the salary. So I don't want people seeing that, so I left it off the view name. Now when you create a view, nothing happens. It just creates the view. You don't see anything. So if you want to see something, you do something like this. Select star from editor info. Now you don't say anything in the select statement to delineate whether this is a table or it's a view. The view, for the purposes of selection, will behave just like a table. So let's go ahead and run this. I'm going to go back over to Oracle Apex. And here we are. I've copied the statement in, create or replace view. Let's go ahead and run this. It says view created. Well, whoopee. But if I want to see if anything happens, let's go ahead now and replace this with the select statement. I'm going to take that out, and I'm going to say select star from editor info. And I'll get rid of all this stuff here. But now we'll see if anything actually happens. I run it, and there we are. We have 6 rows returned. So these are the editors, and you notice we have last name, first name, phone, editor position. The same column names that I had before. For instance, if I wanted to just select last name, first name, I could do it from editor info. And there we are. We get the same thing pretty much as if we did it from the editor table. But I might not have security rights to the editor table, and I do have it to this view. Go back to the lesson. Here is example 2. So we have now create or replace view, and I call this books and authors as, now I have a 3-table join. I have the book title, last name and first name of the author. From book, join book author using the ISBN, join to the author table using the author ID. So I'm going to get just these 3 columns be part of this books and authors view. Again, I'm going to copy it and we'll go take it over to Oracle Apex. So here we are in Oracle Apex, and I've copied the statement in. And let's go ahead and run it and see what happens. Run, view created. Let's take this away, and we'll do a select star from books and authors. And there we are. We've got the book names. Now, Oracle Apex, as a default, just shows 10 rows. I usually go down and pick 100. I'd like to see all of the data. We go here and we can see gluten-free or die, and the first author and the second author, and so forth. I didn't put an order by on the statement, but you know, I could have. So let's do that. Order by 1, 2, 3. Let's try that. And here we are. Now we're in book order, and then we're in last name, first name, author within a book, like Lance comes before Singer on Fresh and Easy. You put the order by the view name just like you would on a table name. So this works out well. Let's head back to the lesson. So here we are with Create View Example 3. A little bit more complex. This time we're doing a similar select statement that we did before, but I'm overriding the column names. I have here create or replace view, books and authors. I have afterwards in parentheses book, comma, last N, comma, first N. For whatever reason, I want to abbreviate those column names. So let's go ahead and copy all that in. Go back to Oracle Apex. So here we are back in Oracle Apex, and I have create or replace books and authors. It's the same thing I had before, but this time I'm overriding the column names. Instead of having title, last name, first name, we're going to override it. So let's go ahead and run this. And now we'll go ahead and do a select against it. Get rid of this, and we'll run it. And there you are. But you see it says book, last N, first N. Same information. I didn't put the order by on this one, but you get the idea. Just a little note on this example. I can select explicitly using those column names, first name or first N, last N, etc. And I can use them in the order by as well, because they are the column names of the view. They're not the column names of the table. I didn't change anything back on the table, but because I created the view with those column names, those are the names. Generally best to not include an order by in the create view statement. Let the order by be done by the select statement that goes against the view. Let's move on. Now here is a warning. Every different database vendor, like Oracle, or Microsoft, or whoever else has SQL, has rules where you can use a view to actually update data But if you start getting involved in updating data with a 2-table or 3-table join, there's a lot of restrictions and there can be a lot of confusion. Where I worked, we just had the rule, don't do it. Don't update using a view. The recommendation is that you avoid it. So the last thing here is you can drop views. And it's simply just the word drop, view, and then you give the view name. So you have to know whether something's a table or a view to drop it. Let's move on and we'll do the exercise next. Here they are. The exercise says to create a view that lists all of the publisher names with the titles of the books they publish. And then after you do that, select from the view in such a way that it is in publisher name and title order. Exercise 2 says to create a view of the book table that does not include the advance column. We don't want to let people know how much money we gave the author. Name all of the view columns and make them different than the original columns listed in the book table. Select from the view in such a way that it is in book and price order. This lesson is on set operators. So set operators are used to combine the results of 2 or more select statements. Now this is different. In the past, we've pretty much just run a single select statement against maybe multiple tables, pulled it all together, and had one set of results. With these set operators, we can have more than one set of results, and then we can combine them following certain rules. So let's look at the 4 main types that we have. There is a union all, intersect, and minus. The union returns the results of all the select statements and suppresses the duplicates. For example, if I selected the last name and first name from the author table and the last name and first name from the editor table in a separate select statement, and then I unioned them, if there was an author in there that was in both places, say I wrote a book and I was an editor, Steve Perry would only appear once in the final set of results after we combine them with the union statement, even though there was a row from the editor table and a row from the author table. If I want to see everything, I use the union all, even the duplicates. And then I would see Steve Perry listed twice if I union alled in that statement. Now, the next 2 things are intersect and minus. Now, intersect says only return the rows to the result sets that are in common in both sets of results. So if I run a result set of all the authors, and then I run to get a result set of all the editors, I look where the rows are the same, and I only report those. Again, there's no duplicates. I just report the ones in common. That's where these 2 sets of rows intersect. The minus is kind of fun. It returns all of the rows from the first query specified, but then it removes any rows that were also found in the results of the second query. So it subtracts it, if you will, from the original set. And that's how you get a minus operation. Let's begin to look at some examples here. Here is union example 1, and it's a simple union. It's pretty much what I was talking about. Last name, first name from author, union, select last name, first name from editor. Now this order by, you only put at the very end of the whole kit and caboodle, the whole thing. So you're ordering by the final set of results after this union operation takes place. So remember that. Let's go ahead, I'm going to copy this, and I'm going to go over and run this in Oracle Apex. So here we are in Oracle Apex, and I'm going to go ahead and run this statement. And you will see I have last name, first name. Go all the way down, and I've got all these rows, 26 rows. Now, I don't know who editor or author is, but I have combined the sets of all their names. I can always run these select statements independently. Let me go ahead and take that out. I'll run that. And so I see that there's 22 authors. Let's go ahead and put this back in. And now I'll take out the first part of it, and I can run it. And I can see that there's 6, so 6 and 22 is 28. But we didn't get 28, did we? No, we got less because we did a union, and any duplicates are removed. I'm going to show you some techniques here in a little bit, but first let's go back to the lesson and let me show you some examples of the other union techniques. Here is a simple intersect. I've got the same select, last name, first name from author, intersect, last name, first name from editor. So we should now only find out what is in common. So I'm going to copy this. I'm going to go back to Oracle Apex. Here we are. Got the intersect, and I'm going to run this. So we got 2 rows in common. So that makes sense. We had 26 when we did a union. So we can see we got rid of these duplicates, the 2 duplicates. Instead of 28 rows total, we had 26. So that makes sense. Go look at another example. Here is a minus example. Same kind of select, last name, first name from author, minus whatever we find in the editor table. So let's select that, take it over to Oracle Apex, and we'll see how that behaves. So here we are back in Oracle Apex with the minus. Now what we're expecting is we're going to get all the results of the author, which was 22 before, and we're going to subtract out anything in common in the editor. And you may recall there were just 2 people in common in the editor, so we should subtract 2 rows from the author results and end up with 20 rows. So let's go ahead and run this, and there it is, and we've got a list, and there it is, the 20 rows that we were expecting. All right, back to the lesson. Now we have an example 2 of a union. This is really a union all. So we have last name, first name, author, union all, last name, first name. So we should see the entire 28 rows. So now we're back in Oracle Apex, and I've got the union all. So let's go ahead and run that. And we'll go down, and we see 28 rows returned as expected. Go back and look at another example. In this example, I'm going to use a string expression to help us see who came from the author table and who came from the editor table. I'm going to put author in front of this. I'm going to put a little string. It's just an expression. So author, last name, first name. Editor, last name, first name. Again, it's regular, but author and editor value will be different. So let me copy this, and I'll paste it into Oracle Apex. Now let's go ahead and run this union with the string in there. We run it, and look, we get author, 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 author. Down there, editor, editor, editor. So we see them all. There are no duplicates anymore, because editor Mike Lance is not the same thing as author Mike Lance. The whole row has to be duplicated. So we see Mike Lance in both rows now. We'll take another look at another example. So now we're back to another example. And sometimes you may find yourself in a position of trying to solve a problem where you really want to do a union, but you have an uneven number of things to be selected. For example here, let's look at the lower select statement, the second one. Select editor, last name, first name, and I really want to see the editor position if they're an editor. But the author doesn't have an editor position or an author position or anything to really correlate. So what I can do to make it even, I can put the word null there. I don't put it in quotes. I could, but then it would appear as null. But generally, just the word null. So still I have 1, 2, 3, 4, and here I have 1, 2, 3, 4. So I force it to look regular, which it must do in order to run properly and to be returned as a grid. Let's select this and run this in Oracle Apex. So here I am with the word null matching up with the word editor position in this union. Now we'll run it. And you see Apex represents a null as just a hyphen. And then we see copy editor, project editor, managing editor, etc. And so that is a way to make that union behave the way we want it to. But wait, there's more. You can have more than one, or rather, more than 2 select statements when you're using a union. So look at this. Last name, first name from author. Union. Select last name, first name from editor. Union. Book title, book type from book. And then I can order the whole thing. Now this doesn't really make a lot of sense. You probably would union another last name and first name. And I would do that if we had a table to do that, but we don't. So, like I said, SQL itself doesn't even really care about the data type here. It just wants to see the same number of positions in the select statement. And it'll take that data and combine it and give it back to us. So, let's have some fun here, and we'll copy this and run it in Oracle Apex. All right, here we are. Select statement, union, select statement. So we got 3. Let's run it. And here it is, last name, first name, are you stressed for success? That's a book title, Analyzing the Obsessive. They put it in order, black, blue, Carson, dealing with behavior. So it stuck everything together. Pretty big, 43 rows that return. Again, not particularly meaningful join, rather union. It is a kind of a join, but it will work, and you can do this for as many tables and many select statements as makes sense. Here we are at the exercise portion of it. Let's look at what we have. So 3 exercises. Code a union between the city and state of the author and the publisher table. Code an intersect between the city and state of the author and publisher table. And code number 3, code a minus between the city and state of the author and publisher table. So we're using some different columns, but just see how that behaves. As always, you can go to your working files area and go to the end of the working file on set operators and see my suggested solution. This presentation is on assignment 13. So use the SQL tool of choice, the Oracle tool, like the Oracle Apex tool I've been using, and answer these following questions. Question 1. Code a union between the first name and last name of the editor and author tables, where the first 3 digits of the social security number are 722. Use a string expression to indicate whether or not someone is an author or an editor. So this is a SQL statement. Question 2 is, take the solution for question 1 and put it in a view that creates a column name of type for the field that indicates whether someone is an author or editor. Don't change the other columns. First name and last name, leave those the same. This presentation is on assignment 13's solution. And so you were to use Apex or some other Oracle tool to work on these questions. So you were to code a union between the first name and last name of the editor and author tables, where the first 3 digits of the social security number are 722, using a string expression to indicate whether or not someone's an author or an editor. So here, select last name, first name, author. I put this at the end, different than what I did in the presentation on this. You can put it anywhere, it makes sense. From author, where substring 1 through 3 equals 722. You might have been able to do this with pattern matching as well. So either way would work, but there's a where clause involved. Then I union those results with the results of this with the keyword editor. And it's the same substring because we're looking for that area code prefix on the phone number. And then I order the statement. So now on question 2, I take the solution from question 1, what I just showed you, and I put it in a view that creates the column name of type in the field and indicates whether or not someone's an author and editor. Now the trick here was I said leave the last name and first name the same. Well, the deal is when you ever provide an override of any column, you have to override all the columns. So I really conceptually was only overriding type for author and editor, and I wanted last name and first name to say the same. So I just re-put them in there. I said create or replace view, person 722, last name, comma, first name, comma, type. So I repeated what was already there to get this to work out so I could override type. Last name, first name, author, da-da-da. Okay, you run that in Oracle Apex and should work just fine. This lesson is on transaction management. Now, transactions. A transaction is a logical unit of work. Transaction management means ensuring that a set of SQL statements is treated as a unit. Transaction management guarantees that either all of the operations are completed or none of them are. This has to do with saving changes to the database. There is a SQL statement to save changes to the database. It's called commit. It will save all the changes that you've made since the last time you issued a commit. In the real world, changes that you make to the database with the insert, update, or delete, they don't happen automatically. You have to issue a commit before they're permanently saved in the database. More often than not, SQL statements are issued from a computer program. So the computer program checks the status of these statements to make sure that they succeeded or failed, and then makes the decision that enough of them have succeeded to be a logical unit of work, and then issues a commit statement. Now there is a rollback statement, and that's an undo. It undoes all of the changes made to the database since the last commit or last rollback statement was issued. Again, this is more often used in programming, but if you're working with a database, even interactively, where you make changes to it and it's expecting a commit to save the changes, you're going to need to remember to issue that. Now here is an example, just a simple banking transaction. I want to transfer $100 from my savings account to my checking account. I go to the ATM and put that in. Now the first thing that might happen is there'd be a SQL statement that would update my savings balance account by $100. It would reduce it. That's the update. It would take 100 out. And then it would do another update statement that would increase my checking balance by $100. It would add $100 to that balance. What happens if the computer system crashes after reducing the $100 from my savings balance, but before increasing it in the checking balance? Going to have a very unhappy customer. This transaction management, which again is usually done in a computer application, will happen to check that both the savings update happens successfully and the checking account update happens successfully. When both statements have cleared the path, then a commit is issued and said, okay, save this, I'm happy. So that's what transaction management is all about, and it's one of the main things that a database management system like Oracle provides for. There is no exercise for this lesson. This lesson is on concurrency control. So what is concurrency control? How do you prevent simultaneous transactions on the same data from interfering with each other? Two people trying to update the same thing at the same time. Concurrency control means making sure that data is never operated on by another user until a change is completed. This is extremely important, especially in a larger database. One of the best ways to illustrate this is before we had concurrency control, we had something called the lost update problem. So let me give you an example. I'm thinking about going to Tahiti. And it's a whim, so I call up an agent and say, hey, I'd like a ticket to Tahiti tomorrow. So the agent says, checks the computer. And I say, hey, guess what? I have one ticket left. And he gives me the price. Well, let me think about it for a second. So I'm thinking about it. So another customer named Barbara calls her ticket agent from someplace else in the country, some other phone somewhere. Says, I'd like a ticket to Tahiti tomorrow. Her agent checks the computer and says, hey, guess what? I got one ticket left. Cool. Meantime, Barbara's thinking about it, and I say to my agent, okay, let's go for it. Buy the ticket. So the agent puts the information, buys the ticket, saves the information. I have seat 33, the last one available, to Tahiti. Barbara's agent is still waiting for her, and Barbara says, you know what? I think I want to do it. I'm going to go to Tahiti. So her agent has the information on her screen, hits the save button, and saves the information. So Barbara now has seat 33, clobbering my update where I had seat 33. So I go to the airport the next day and say, hey, where's my ticket for 33? And they're like, who are you? Sorry, we don't know anything about you. I get upset. They call security. It's not good. So this is what we want to prevent. And I'm going to show you how they do that. The solution involves something called row locking. So when the last scenario and the lost update problem, when my agent brings up a record, a write lock is placed on it. So for some period of time, my agent has this seat 33 waiting for me. And so there's a transaction lock that's on there. Once I say, okay, great, give me the ticket to Tahiti, the update goes in, the transaction lock is removed. However, when Barbara's agent tries to save the ticket, the agent is warned, says, the record's changed since you last retrieved it. And so they have to re-retrieve it to see what the change is. So they re-retrieve it and they find out the change is the ticket's been sold and it's no longer available for Barbara. So Barbara got in a little late and did not clobber my transaction. I'm going to Tahiti, Barbara's staying home. All right. Here is a simple way to place a row lock on some data when you are doing a select statement. Again, more often than not, these are done from computer programs. The SQL is issued, but we're learning it here interactively. So if you take it to the next level and start programming with SQL, you'll know what to do. So we're selecting some information from this table where the author ID is equal to 144112222. And now we say for update of city. So I've not only updated the row with a row lock, I've updated the particular column. So I can take it down to that level and say, this row, the author ID is this, and the column is city. I'm intending to update right now. So I can lock it at the column level. So it's a write lock on the column city for the row with the primary key of that social security number. So until that lock is released, either it times out or the person who's doing the update makes the change to the city, saves it, releasing the lock, nobody's going to be able to clobber that. If they've retrieved it in between the time I've retrieved it and made the change, they'll be warned that they've got to re-retrieve it to see the change before they make their decision. This lesson is on security considerations. There are basic security statements that can be used in Oracle to handle security. There is the grant statement, where you can proactively give a user access rights to a particular table or just to particular columns on a table. Correspondingly, there is a revoke statement, which removes user access rights to a table or to columns on a table. Let's take a look at the syntax. It looks something like this. The keyword grant. Now, in curly braces, with a pipe, this means you must pick one of these. So you have to say grant all or grant some particular privilege list. Generally, a privilege list includes things like can they select on the table, can they insert to it, that sort of thing. See an example in a moment. Then the keyword on, and then you give a table or a view to grant the security. You can put security on a view just like you would on a table. Now in here, this is optional, square brackets mean optional. You can provide a column list. So you can restrict the security statement that you're dealing with, this grant statement, to a particular column or set of columns on a table. Now you have to grant these privileges to someone. So you say to is the next keyword. And now again, we have the curly braces, which means we have to do one of two things. We either have to grant them to everybody, whatever we're doing, public, or to a particular list of users. The revoke statement is very, very similar. Revoke all privilege list on table or view and a column list from the public or a particular user list. Let's move on. Here are some examples. I could say grant. And here's the privileged list. Insert, comma, update on book, the book table, to Perry S, comma, Smith J. Now in this class, we're not dealing with individual user logons, but in the real world, we would log on to a particular database. And when we logged on to it, say I logged on, my name is Steve Perry, so Perry S might be my user ID. Now I'd need a password to get into the system. But once in, I'm identified as Perry S. And then anytime I tried to access a table to say I wanted to insert rows in the book table, it would say here on the basis of this statement that, okay, I have the right to do that. Interestingly, because I didn't grant all, I just did insert and update. That means I can add and change data, but I can't look at it. I can't run a select statement because I didn't explicitly say that. If I wanted to do the standard things, I would have grant, select, insert, update, delete. That might be a more common thing to grant to someone. You can also grant the ability to create or alter tables, this sort of thing. You can grant DBA type privileges. It's a powerful statement. You obviously have to have the authority yourself, the security to issue grant and revoke statements. So I've given these two users, Smith J and Perry Smith, this particular privileges. Now, revoke, update. Now I had update there on book for advance and price, Jones K. So presumably Jones K could update advance and price before, but we've removed the ability. Just from that statement itself, we don't know what other privileges Jones K has. Security can get quite complicated, especially when you get in a large organization. And so the vendors have invented tools, windows, and things to help out with this. So we can also use views to restrict access. So I can do like on a payroll table here. If I go up here, payroll table had name, social, and their department and salary. I might want to let a lot of people see the name and department of people on the payroll table, but not their social security number nor their salary. So I create this view, payroll general access, and then I say select name, department from payroll. And right after that, I might grant that view. I might grant all rights or perhaps select rights to payroll _ general access to all. And so we can do that as well. Now, as I was mentioning, security can get very complicated. You imagine a company with several thousand employees and having to figure out what can they look at, what can't they look at. A payroll clerk can do more things than just an average employee, but a payroll supervisor can do even more than that. So Oracle has something called groups, roles, and privileges. And you can usually they provide a windowing tools where you can put a user ID in a particular group or assign a role to a user or a privilege. And then what you do is you grant and revoke privileges to these groups, roles, privileges in the generic sense, like select, insert, update, delete. You grant them to groups, roles, and privileges in a capital letter sense. Nonetheless, doing it that way if you hire a new payroll clerk, you don't have to go through and assign all these different grant revoke statements. You just put them in the payroll clerk group. And then that new clerk has all of the rights and privileges of all the other payroll clerks. That's not standard SQL. These are tools. In particular, Oracle has Oracle Security that allows this to be easier to manage. It issues the appropriate SQL commands in the background from essentially a computer application. Now, Oracle sells advanced security tools. There's a link that I provided below for more information. So you can just go to oracle.com and look at their database security tools and read more about it. All right, we're here at the exercise. Note, while you won't be able to test these statements, we're not working with particular user IDs, go ahead and code them anyway. Just write them out in TextPad or some other text editor tool and get an idea of how you would do it, how these work. The exercise is this. Give these user IDs, PERIS and LANDEYT, LANDEYT, give the ability to make changes to existing data on the authors table. Except don't let them change the author ID column. And also allow them to add new rows of data, but don't let them delete any rows. Now, of course, they both should be able to see the data. So think about what you would do, what statement or statements you would use to make this happen. You can find this in your working files. This lesson is on stored procedures and triggers. Now, this is just a simple lesson to give you an idea of these database objects. They're used in the real world, and especially in larger database installations, you may need to be at least aware of them and how they work. So let's define a trigger. A trigger is a database object, and it's set up to perform automatic updates that are set up to execute when either an insert, an update, or delete is performed against the table. To give you an idea of the syntax, it is like a view in a certain sense in that we have a create or replace option, and then the keyword trigger. So we now have tables, indexes, views, and now we're creating triggers. So you give the trigger a trigger name, and then you have a label like before update or after insert, something like that. And you give the table name. There's an optional thing to do on each row. In this example, this is sort of an example syntax. There's a mini PL SQL type program with declare, begin, exception, and end. More generically, I'm going to show you this next slide. So conceptually, just as an example, you could create trigger record users or record users on authors before update as, and you could give a procedure name that you did write in something like PL SQL. Or you could give some SQL script, just like you did with a view. Something that you wanted to happen right before a row was updated or the table was updated. Some little bit of insurance. One thing we had used this for at a particular installation where I worked is we set up all of our tables, and we had hundreds of them. They all had insert and update triggers. Now, it was designed that there was always a column, or rather, there were always two columns on the table for when a row was created. We had the create user ID and the create timestamp. Likewise, when a record or a row was changed for some reason by some user, that was recorded in an update column, update user ID, and then an update timestamp. We always knew who was the last person to touch it. Now, instead of relying on computer application developers to always remember to do that, we set up triggers on every table to update those columns, which we insisted would be on every table. And that way, when someone did an insert, we'd fill their information into the create user ID and timestamp. And whenever any user issued an update, we'd put their user ID and timestamp. And that often helped when you needed to trace the source of some change to your data back to an individual person. Now, to talk about stored procedures a little bit, they are pre-compiled SQL statements that reside on the database server, and they may receive arguments or return data. And they may be more than just a SQL statement. They may have procedural code happening. More often than not, this is done with PL SQL, which when you're using Oracle, because it's a standard programming language or procedural language that works with Oracle SQL. And so these stored procedures can be called automatically from within computer applications. I used to work with a Windows-based tool called Power Builder. You can do it with Visual Basic. You can call it from a particular program. But you also can call it from a trigger, or one PL SQL program or one stored procedure can call another. So they do have to be explicitly called. Nothing happens automatically. We're not going to get into them here. I want you to be aware that Oracle does provide the ability for you to write custom single row functions. You know, we had functions like toDate or toChar or round or substring. You could write your own functions that would behave in a similar way. Add a bunch of X's function, and it would add a bunch of X's to the end of a column value. You could wrap that function, add a bunch of X's around a column name in your select statement or in an update statement. And as long as Oracle can find the function that you've written, you have it in the proper path, and your function runs and compiles okay, it'll behave just like the regular standard Oracle single row functions. So you do have the ability to write custom functions if that is useful. We are at the end of this discussion on stored procedures and triggers, and there is no exercise for this particular lesson. This lesson is on database integrity. Now, this is just a short lesson to discuss some of the ideas. Very often, people talk about database integrity. So here's a few kinds of integrity that a database should have. One is domain constraints integrity. These are the set of potential values for a column. Clearly, if something is defined as a date, you're putting dates in there, numbers, and varchar, you're putting text fields. And make sure that the domain constraints, what you said can go in there, is what's in there. And normally the database is going to enforce this, but there may be some exceptions. So that's one kind of integrity a database has. The other is an entity integrity. And the idea there is that no primary keys would have a null status. Nowadays, when we use the term primary key when we create the table, or we put at the end of the table primary key and we give the multiple column names that may make up the primary key, this constraint will enforce the not null status. This discussion of entity integrity is partly from the old days where one had to proactively add a not null to a primary key and create a unique index on it to get it to be a primary key. It wasn't automatic. Now, just simply putting the primary key will help make sure that you have entity integrity. Now, the third bullet here is the most popular to talk about. That's referential integrity. And this is the logical consistency between primary keys and foreign keys. It says there, no orphans. So what does that mean? An orphan would be a child without a parent. In the real world, well, it's like that in the database world as well. In the particular database that we're working with, we have a book table. And on the book table, there's a column called the pub ID for the publisher ID. So if we have a publisher ID on a book, and say it had a number of 1, 2, 3, well, we darn well expect that when we refer to the primary key of the publisher table, we should find a row on that table whose pub ID is 1, 2, 3, and we'll have all the other information about the publisher, their name and so forth, address. If it's not there, then you would lack referential integrity. The way to help enforce that, of course, is to proactively create a foreign key constraint. Have the database management system itself enforce that rule to make sure that you can't violate it. However, this is up to you to do. It's not automatic. When you put together a database, it doesn't know automatically exactly how you want to do a foreign key to primary key relationship. So if you want the database to police this for you, create foreign key constraints. If you don't do that, you risk creating orphans. The way that would happen, of course, is you'd have someone there on the publisher table, the 1, 2, 3, and then put a bunch of books to it. And then later on, somebody would come into the database and delete 1, 2, 3, even though there are records referring to it. Well, the foreign key constraint will prevent that from happening. It'll say, you can't delete this. There's people who say I'm their parent. I'm not going away. Just wanted you to have a little bit of information. Think about these concepts as they're talked about in the real world. This presentation is on assignment 14. Now, you do not need to run any SQL statements to answer these questions. Question 1. Explain the concept of referential integrity. Just write out a paragraph or two explaining what you think that means. Question 2. SQL statements, which are stored on the server and are defined to automatically execute when data on a table is updated, are called what? Moving down. Question 3. Which SQL statements are used to save or undo your changes to the database since your last save? And lastly, question 4. Which SQL statement is used to give users access to tables or columns on the tables in the database? And which statement is used to take away access to table or columns in the database? This presentation is on assignment 14, solution. Now, as I mentioned, you don't need to run any SQL statements for this particular assignment. So the first thing is to explain the concept of referential integrity. So a database has referential integrity when all of the foreign keys, the foreign key values, have valid references to a primary key value in a table. In other words, there are no orphans. For example, if a book is published by a publisher with a pub ID of 123, then the DBMS, that's the Database Management System, Oracle, will enforce the rule that 123 must exist as a value of a row's primary key on the publisher table. Then it is said to have referential integrity. Looking at question 2, statements which are stored on the server and are defined to automatically execute when data on a table is updated are called triggers. Now, stored procedures, which some people guess, are not executed automatically. They may be called by a trigger or by a computer application, but they're not set up to automatically happen by themselves. You need a trigger to do that. Question 3 says, which SQL statements are used to save or undo your changes to the database since your last save? Commit is the saving operation, and rollback is to undo those changes up until your last commit, or truly even your last rollback. So lastly, question 4 is, which SQL statement is used to give users access to tables and columns in the database, and which statement is used to take away access to tables and columns in the database? And so there is your grant statement to give access, and the revoke taketh away. This lesson is on implicit joins. Now, this is kind of legacy code. People don't code this way anymore, or shouldn't be. Before, we had an explicit join keyword like we've been using so far, book join publisher using pub ID, something like that. That's very explicit, clear that we're doing some joining. But when SQL was first created, and for many years, for about 20 years, there was no explicit way to specify a join. You instead had to do it implicitly by specifying connecting columns in the where clause. And so I'm going to show you examples of that. And here's an example here. If I move this down, you can see instead of doing the normal way, select name, comma, title from publisher join book using pub ID, we did it like this. We gave the select list as the same, and in the from clause, we merely listed tables that will be used. So publisher P, that's short for publisher, and the table alias, comma, book B. So that's not where we specified any joining criteria at all. Instead, we went to the where clause and said P, or publisher pub ID, equals B dot publisher ID. So these were connecting. These two examples aren't too hard to follow because it's a very simple statement, but things can get more complex. So we'll look at an example here where we are using some criteria. We have select, name, title, type, price from publisher P, comma, book B. Again, we just list the tables here. Now in the where clause, I start off by specifying the connecting columns. I say P for publisher dot pub ID equals B for book dot pub ID. So that connects, that joins, that is the join. No, I didn't have to put it right after the where clause. I could have put it at the bottom of the statement after an and. It wasn't relevant where I put it, but here I'm specifying them first. So after that, I have other criteria. I'd say, hey, I want to see where the book type is also computer and the price is greater than 20. So show me where these connect, but then and also meet this where clause criteria. We've done the same kinds of things before, that we had the join criteria explicitly specified in the from clause, not implicitly specified in the where clause. But I think it's important for you to see this and practice this, because there is a whole lot of code out there that's still doing it this way, code that perhaps was written a while ago and has never been changed. So you need to understand this works in SQL. It's legacy code, but you may encounter it in your own work. You should endeavor to do the more modern technique of using the explicit join keyword. So let's go ahead and run this statement in Oracle Apex. So here I've copied it here, and I actually pre-run it, but I'll run it again. And you'll see that we get 2 books in one publisher, all Techo books. Silicon Valley Startups, Usability Testing, they are both computer books, which was part of the criteria right here. And they both have a price over $20. So this meets the SQL statement criteria, and it joined up by using the implicit join information in the where clause. So let's go back to the presentation and look at something a little bit more complicated. Alright, let's now deal with criteria and a 3-table join. So, again, we have the select list at the top. So you can see here with the from clause, we simply have a list of tables. Book, book author, and author. We know if we did this explicitly that the book and book author would connect on ISBN, and we would know that book author and author would join or connect on the author ID column. So here we specify them implicitly in the where clause. So B for book.isbn equals BA for book author.isbn. And BA author ID equals A author ID. So you need both of those to get these 3 tables together. And then you start mixing in criteria. And the city equals Oakland. And the state equals California. So this can get very unwieldy when you have a lot of tables and a lot of different criteria. But again, this is legacy code. You will encounter this even just searching around on the internet when you're looking for answers. You will often see an implicit join instead of an explicit one. It's very easy to learn one way to do things and then take a while to grow and go with a more modern technique. So let's go ahead and run this in Oracle Apex. And so here I've copied the statement in to Oracle Apex, and I'll go ahead. One thing I'd like to do before we do anything is change this default rows of 10 to 100. And now I'll run it. And we see I didn't need it, I only had 6 rows, but I like to make sure. So 1 hour negotiations, Maggie Blue. You can see down here we have a book that was written by 2 people dealing with behavior problems, Linda Carson and Spencer McDouglas, all from Oakland, California, all joining this book information to the author information. Go back to the presentation. And now it's time for you to do an exercise. Just one here. Show all the publishers their books and the book's authors using the implicit join technique. No other criteria here. Just get everything to join together and be presented. It would be a good idea to put it in some sort of sorted order as well. This lesson is on the any or all modifiers. This is an alternate way to code a subquery with the any or all modifiers. These aren't used that often. Generally, there are better ways to go with the techniques I've shown you already, using the enlist and what have you. But again, this is legacy code. You will see it around from time to time, and I don't want you thinking that I didn't tell you about it. So let's go through it and see if it's of any use to you. So you can still use the in operator when the results of an inner query will have 0, 1, or more values. But once the inner query returns results, the outer query makes use of them. You've seen this before. Let's pull that up so we can see the whole thing. Inner query, select distinct publisher IDs from book. And then we're looking for the name of the publisher where the pub ID is in that set of distinct publisher IDs. Very simple subquery. Let's move on. Another way you can achieve this by using the equals any. So select name from publisher where pub ID equals any pub ID that comes from the inner query. So select the list of pub IDs or the distinct list of pub IDs for the book table. So as long as the publisher equals any of those, then show me the publisher name. Now, it's just as easy, I think even easier, to use an in list in this case. But just note, remember before, we couldn't use the equal sign by itself because if there was more than one pub ID that came back, and there most certainly would be from the book table, that would be an error. When you use an equal, just a standard operator like that, it must be equal to 1 and exactly one value returned from the inner query. You can't always guarantee that. So when you put the equal any, it removes that restriction with the equal sign, and this will work. Let's go ahead and run this in the Oracle Apex area. So here we are. I've copied the statement in. I'm going to run it now. And you see, I've got everybody. And that makes sense because the book table has a book for every publisher ID. So these are the 3 publishers that we have at the table, at least the publishers we originally had. And I want to then select the name for any of them that come back in the book. So we see all 3 publishers in our table. Back to the presentation tool. All right, let's look at this a different way. What if we used greater than any instead of equal than any? So I can have select name from publisher where pub ID is greater than any. That kind of sounds like the maximum, right? But it's not really. It's greater than the minimum because it would be greater than even the least amount that comes back. So let's try running this statement with greater than any. I'll go back to the Oracle Apex area. See here, I have the statement I'm about to run. It has pub ID greater than any, not equal than any. Let's run it. So we get 2. So all Techno Books and Binder and Smith. We don't see the other publisher because that was our minimum value in the pub ID. It was probably pub ID number 1. If we really wanted to know, we could put pub ID here just so we could see at least what the pub IDs were. And here we have 2 and 3. So our publisher with pub ID 1 was the minimum. So if it's greater than any, then it has to be greater than the least. So this is why these modifiers aren't used that often. This is not as intuitive as some other ways of doing this. Okay, here's another way to look at it. I've changed the pub ID to be less than all. Well, you can't be less than all. So the results we're going to get is none. Because if you're less than all of them, then the smallest one would be part of all. You basically get nothing back from this statement. Let's look at this. What about greater than all? Still have a problem. You can't be greater than all because if you're the maximum one, then you're part of all. Confusing, so there's better ways to do this using max or min if you wanted to do that as a comparison in a subquery. In the working file for this lesson, I have included this chart that can give you a little bit more information of how this would behave in ways that you're a little bit more familiar. So a greater than all is more than the highest value returned by the subquery. Less than all is less than the lowest value returned by the subquery. So it can make sense in certain situations, but not the way we were doing it going against the same table. Less than any is less than the highest value returned by the subquery. Greater than any is more than the lowest value returned by the subquery. Equals any is the same thing as an in. So use an in. Again, you may come across this code, especially if you're working at an institution where there are people who've been there for a while and they've written code and perhaps they've done it in the old style, either before there was a join keyword or they were brought into the join keyword kicking and screaming. Now we reach the exercise portion, so go ahead and try this out. Use a modifier in a subquery to list the authors' names for all authors with more than one book. You're going to need more than one table to do this, the subquery, so just use the modifier method and try it out and get it to work for yourself. This lesson is on using a subquery to test for existence, or using the exist operator. So what this exist operator does is it determines whether or not a condition exists in the subquery. This is a little bit different. We've been looking for values being equal to other values or greater than or less than any of those values, this sort of thing. This kind of test is a very different kind of test. And this kind of a test with the exist is known as a correlated subquery. Big word, makes you sound smart in a job interview. Learn it. So, what the exist word does is it tests for the presence or the absence of the empty set of rows. Alright, what does that mean? If you don't get any results, it's the empty set of rows. If you get any results whatsoever, you've got something existing, okay? So the inner query, that's the one on the bottom, if you use the exist keyword and the subquery returns at least one row, then exist will succeed. You can also ask if something is not exist. It's kind of an awkward way to say it, but you use the not exist clause. So you see if something doesn't exist. And so if the inner query returns at least one row, well, then it exists. So the not exist operator says that's failure. That's not true. It does exist. If you reverse this, the inner query returns no row. The exist will fail, but the not exist will succeed. It'll say, woohoo, we don't exist. This is almost getting philosophical. Let's go ahead and we'll look at an example here. So here is an example. Select distinct name from publisher P. Okay, I'm using P. I'm giving it an alias. Where exist. Now notice in the from clause, I'm just saying from the table. I'm not joining to anything. I'm looking at the subquery. I'm saying where exist. I don't say where exist equals anything. I'm just saying I'm looking for existence. So look at this query below, the inner query. It says select star. I could say anything in the select list. I could say select count, select, one of the columns. It does not matter what is returned in the select. For all our other queries, it mattered very much because we were comparing something from the outer or upper query to the inner or lower query. Some value, some column-to-column action going on. This isn't happening here. No column comparison whatsoever. It simply runs the statement below, right? And it says, did I get anything back? Did I find something? So, but look at this. This is very different. There's a join down in the inner query. Select star from book where, this is an implicit join too. This is getting weirder and weirder. Pub ID equals P pub ID. Well, this pub ID refers to book because it's within the query, but P pub ID is referring to the publisher table in the other query. What? This is what makes it a correlated subquery. So this behaves very, very differently than any other kind of subquery. Usually subqueries are cool because we run something down here, feed some information to the upper or outer select, and we go on our merry way. This doesn't behave like that at all. What it does is it does one row at a time test. So it gets a name from the publisher, and then it runs this statement once. It says, does that pub ID for that publisher and typebook equal business, do I have any of those? Yes, I do. Then I report that name. And then it gets the next row in the publisher table. And it does the same thing for the book on a row-by-row basis. This is like a Cartesian product almost. It can get really unwieldy if you're dealing with tables that have hundreds or thousands or hundreds of thousands of rows of data. They can run extremely slow. Unless you have a problem that you're trying to solve that you can't do in any other SQL way, highly recommend not using the exist or the not exist. Again, you will see code like this. There are times when it's the way to go, but those are rare, and you should be aware of existence. Go ahead and we'll look at another example. Here's an example if we did that statement before that was so complicated. We just did it as a join. Select distinct name from publisher join book using pub ID where the type equals business. Voila! We're going to get what we need. Much easier, so consider using a join instead of an exist subquery if you need to get that kind of information. Usually it's going to be easier. Let's move on. So in this case, if we do SQL, we not exist. So select title from book where not exist. Now we look at this correlated subquery. Doesn't matter what I return in the select list. From order items, where the ISBN on order items equals the book ISBN. So we're going to go through this a row at a time and test for existence for every row up here. Now we're working with small tables, so this will work fine. It's just about 20 rows or so. But in the real world, you're going to have larger tables and databases, so use this statement with caution. Let's go ahead and run one of these in the Oracle Apex area. Copy it, and we'll take it over there. So I've copied the statement over here. Title from book, not exist, order items. And I have an order items table that I set up from before. And there it is. How to choose a computer. Happiness in Doggyland. So that was a row we added after the fact in one of our exercises. So we have 13 rows that are returning that meet this not exist criteria. So we have books, that have no order. There's probably better ways to do this with a join or an in list, but this is one of the ways that will work. Back to the presentation. All right, now it's your turn to do an exercise here. Use the exist method that I just showed you and show a list of all authors who have not written anything. You may be thinking, wait a minute, we have authors in the author table that haven't written anything? Yes, we do. There could be all kinds of reasons for doing that. Someone gets hired to write a book and they haven't found an appropriate ghostwriter yet to write the book, but they're going to be the author of record, so they decide to enter that information in the table, but they haven't titled the book or gotten the details of the book worked out. So, again, databases do not have to reflect all types of reality that can be possible in a world. They only have to reflect the kind of things that a particular organization needs to track and in the way they need to track it. That's the only reality that counts, ultimately, when you're using a database for a particular organization. So, give this exercise a try, and I have the solution down at the end of it. If you pull this file up in your working files area, you will see that. This presentation is on assignment 15. Go ahead and use the SQL interactive tool of your choice. I've been using Oracle Apex. Use that to solve the following problems. All the questions should be able to be answered with a single SQL statement. Let's look at question 1. Show all the publishers and their cooking books that cost less than $30. Use the implicit join technique to join the tables needed. In other words, don't use the join keyword. Use table name aliases throughout the statement. When listing publishers, specify the pub ID and the name. Go on. So question 2, list all the books and their price where the price of the book is less than the book with the highest price. Pick the correct any or all modifier to solve this problem. And lastly, question 3, show a list of the authors who have written a book with another author and appear listed on the book after that author. Use a correlated subquery to solve this problem. Essentially what I'm looking for is where an author has collaborated with one or two other people and they're not listed first on the book. So that's essentially what this question is asking. This presentation is on the solution to assignment 15. So let's go down and look at question 1 here. And it was to show all the publishers and their cooking books that cost less than $30. I wanted you to use the implicit join technique to join the tables and to use table name aliases throughout the statement. And when you listed the publishers, I wanted you to use the pub ID as well as the name. So here, I'm going to jump down to the from clause as the first point of focus. We need to look at the publisher, which is an alias with a P, and comma book alias with a B. Now in the select list, name is needed just like that because there's only a name column on the publisher table. But pub ID must be prefixed with a P or a B. In this case, I want P to delineate it from the publisher ID or pub ID column in the book table. So you have to be specific up here. The title and price are only on the book table, so there's no ambiguity. So we have the price is less than 30, and here's the join. P pub ID equals B pub ID. And I ordered by 1 just to get it in the name. All right, let's look at the second one. List all books at their price where the price of the book is less than the book with the highest price. Pick the correct any or all modifier to solve the problem. So let's go down below. We want the distinct price from book. Normally, if I were using an in list or an equal sign, I would just say the maximum price, and I'd want something less than that. But since we're using any or all, I want to find titles, price, and book for a price that's less than any of these. So if it's less than any of them, it'll be less than the maximum one. It's kind of counterintuitive, but that's the way it works, and you can always refer to that chart that I gave you in the lesson to help explain what's really going on here compared to better ways you've learned to solve these problems. Moving on to question 3, show a list of the authors who have written a book with another author and appear listed on the book after that author. Use a correlated subquery to solve the problem. So we're looking for existence here. So what do we want to exist? This gets interesting. Well, first, let's show what we want to list. We're going to list the author, which is last name, first name from author. Gave an A. So now I want to see if that author exists on the book author table. And we have to connect them with this implicit join to the author ID and the book author to the author ID all the way outside from the other query. But the other criteria we add is the author number greater than 1? If you're listed on the book with more than one author, if you're 1, good for you. But if you come second or third on the book, your number will be greater than 1. If you write a book by yourself, your number will be 1, guaranteed. However, I didn't want those books in this criteria. So this will solve the problem. So if anything comes back, it exists and it'll pass the test. Remember that these correlated subqueries operate one row at a time from the outer query, then runs the inner query. Again, back and forth, back and forth. So it's a bit convoluted, but it is part of the standard SQL specification, so it's good to know.
Subscribe now and press the bell icon. Never miss an update.
This lesson is on the difference between Oracle SQL and other SQL. From a database management perspective or a database administrator's standpoint, there are significant technical differences in Oracle, Microsoft, MySQL, any of the various databases that could be installed. But from a SQL developer standpoint, that's you after this class, the differences are minor and they're fairly easy to learn. There are some syntax differences, and there's some single-row functions that are different or missing. They're in one database and not in another, or one database management system and not in another. So let's just do a for example. I'll give you some differences between Oracle and Microsoft's SQL Server. MS SQL allows you to do a select without a table. Oracle, you have to use that dual table, the dummy table we learned about. So if you want to run a statement just to do some math, to run an expression, divide 256 by 16, you have to do that from dual in Oracle, but in Microsoft you do not. You don't have to have the from clause. Oracle allows aggregate functions to be used with strings. Microsoft SQL does not. For instance, the min and max functions used with string data, or text data, another word for strings. Oracle allows you to use the join using clause, which, as you may recall, allows you to look for equality between column names that are the same between two tables. With Microsoft SQL, you have to use the join on, and when you specify the on, you have to explicitly name the columns and see them where they're equal. Oracle uses a data type for numbers called number. You've seen that. Almost every other database in the world that I've used, anyway, uses numeric instead of number, and Microsoft uses numeric. Oracle also is a bit different in using something called varchar 2. It really has become the standard. They had a problem when they progressed from varchar to varchar 2, making things backward compatible. They've surmounted that problem, so technically you could use varchar, but they recommend that you don't for consistency. So varchar for variable character length field or column is what's used for most text data in Oracle. With Microsoft, you're going to use just the regular varchar. Now here's some differences in another popular database, Oracle and MySQL. MySQL was invented before Oracle ended up acquiring it. First, Sun Microsystems company acquired MySQL, and then they were gobbled up by Oracle. So Oracle owned MySQL. MySQL is used in a lot of free web databases. If you're not like a large company, if you're an individual or a small company, you might use MySQL because there is a non-commercial version that you can use that works pretty well, and it's often used with web pages. Oracle allows us to use check constraints, where we check to see, say, someone's salary was less than $100,000 in our database. MySQL doesn't allow you to use the check constraint. MySQL allows multiple rows to be added with a single insert statement. I actually kind of like that. It's nice. You just say insert, you give the column names and values this, values that, so and so. You don't repeat the word insert. But Oracle doesn't do it that way. You have to use the insert, and you have to repeat it each time for every new row, other than using an insert with a subquery, which you learned. But in general, one row per insert. Oracle has an intersect set operator. MySQL does not. MySQL does have the union set operator, but not an intersect. Oracle again uses the numbered data type for numbers. MySQL uses the more traditional numeric. And again, Oracle uses varchar 2 for text data. MySQL uses varchar. So if you find yourself in a non-Oracle organization after taking this class, just Google the differences between the two. Most of it's going to be trivial. You'll be able to figure it out. In my experience, though, in getting employment, very often HR departments, they get fixated on your experience being exactly what the company offers. SQL is pretty close to being SQL across many databases with just these small differences that can be picked up by any experienced SQL developer. It's not a great leap, but sometimes they just want to see the actual brand name that they use. And as I mentioned at other times, Oracle has a very large market share. Remember that SQL itself is not actually software. It's a standard specification that all database management system vendors try to follow. They do it pretty well. They're pretty close. And so going from one to the other should not be real difficult should you find yourself having to do that. This lesson is on using SQL in a programming language. Now, SQL for the most part is SQL. I'm just going to give you an example using something a little bit different to give you the concept. I'm going to use the programming language PHP, and I'm going to use their MySQL database just to show you how a connection is made and how SQL is issued. You would do a similar thing with Oracle or Microsoft or any other database and another programming language. This is to give you a feel for it, just conceptually. So here's some SQL. Last name, first name from author. We know how to do that interactively. Let's deal with that in a programming language. Here is some PHP code. I'm going to first have a statement here where I connect the server name, the user ID, the password, in this case is blank, and the database is just test. So I pass these parameters to a special function that makes a connection to a database. And it returns the success or failure and a pointer to the database or a handle on the database connection into this variable. In PHP, variables start with a $sign, so $db is a variable name. I have an if statement here that checks if the $db worked okay, and if it did not, that's what the exclamation point means, it did not, it prints out a message saying, nope, unable to connect to MySQL. Let's continue with the code. Now, look how I've set up the select statement. If you look just to the right of these equal signs, this looks kind of what we would do interactively. Select last name, first name from author, where state equals California, order by last name, first name. This was intentional because when you're often using SQL in a programming language, Visual Basic or something else, you have to build up the entire SQL statement into a variable. It's a text variable or a string variable. So over here, this is a variable $SQL statement, and I'm taking the first part of the select statement and putting it into that variable. And then this dot equal says, add this. And then another says, add this, dot equal, blah, 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 blah. To the computer, this select statement is just one big long bit of text. But that's hard for our minds to wrap around, especially, when you're debugging interactively. By typing it out this way, you can see better what the statement's supposed to be doing from a human eye standpoint. Once you have that into this variable name, then you pass this variable name to another function, in this case this MySQL query, and it returns a result into the $result. This is the continuation. So we get the results as long as the results work. This is the not results. Didn't work, we display, or actually we store a message about it did not work, and we give an error message. Else it did work, and so we start putting into this variable called output display a heading, authors who live in California, and we build up an HTML table. Again, I'm doing something similar with the HTML that I did with the SQL. I'm building it up to the right of an equal sign, so it kind of looks like we typed it if we were typing the HTML in a raw text file. But in this case, we're taking it and storing it in a variable name. We come in to continuation. This kind of ends our code. We take that result and we interrogate how many rows we're returning the result. Remember that a result from a select statement comes back as a grid. It's got rows, it's got columns. So I want to know the number of rows so I know how many times to loop through this result grid. This is actually like a little grid. It's like a two-dimensional array. And we're going to go through it just like a spreadsheet. So we pull this back, we get a variable name which shows the number of results that came back from a row. And then this little statement over here called a for is a looping statement. So it's going to go around and around and do these statements over and over again until a little variable here called $I is less than the number of results. It'll keep operating. The first time in, it goes and it fetches array. What that really does is it gets the first row off the grid that's stored in result. And now we put it into an array, it's called. It's a list. It's just one row's information. And then this allows us to get the last name, the first name into just regular plain old variables, dollar last name, dollar first name, and then formatting HTML displays. So we're going to put the last name and the first name, and this is the beginning of a row and the ending of a row. So it'll print out in a little grid. And then we're going to do this over and over again for all the rows. And then when we're done with our loop, after this little curly brace, we go ahead and finish the table off in the display, and we end our program. SQL is usually issued from a program. But as you can see, programming is involved. It's more than SQL. You've got to know SQL really well to use SQL in a program. You need to learn it at least interactively so you know what you're doing. But then there's another leap that you have to do to take this code and systemize it by putting it into an application. The beauty of it being in an application, of course, is you never make a typo. Once you've put it in a program, you've tested it in a program, theoretically it ought to work forever. You would be gathering data that a SQL statement needs, perhaps from a web form or from a window, if you were doing Visual Basic programming, for example. And you'd pass that information through program variables to the SQL statement instead of typing them in interactively, and life goes on beautifully. So you still need to be able to work interactively to be able to test things out and make sure that you've got the SQL working correctly in that way before you bring it into a computer program. SQL ends up in an application. Forms are provided for the user to put input. Programs retrieve the user information. Logic is processed, and output is displayed. This lesson is on embedded SQL. There are special constructs that are not available with non-embedded SQL. I showed you in the last lesson using SQL inside of a PHP program. That isn't truly embedded SQL. I didn't use any of these statements I'm about to tell you about for embedding SQL. Embedding SQL allows you to use the SQL in a programming language kind of as if it were a part of the programming language. Back in the last example, in the last lesson where I showed you PHP, what I did instead is I put all the SQL in a string variable and I passed that variable as a special piece of data that went to a special function. And then it was processed behind the scenes. So it's kind of almost like working interactively, but letting the program do everything behind the scenes. With embedded SQL, we get a few more features. Now, you've seen a short example of this very early in Chapter 1, and we're going to go back and look at Oracle's PL SQL again to give you an example. So there's statements like open cursor, which is a kind of a funny way of saying there's a stored select statement that I gave it a name, and I'm calling the name a cursor instead of stored select statement. Anyway, you open the cursor and it runs the select statement. We can select directly into program variables. Or if we have a select statement that brings back many rows, we can fetch into one row at a time results of our select statement. So here is an example of PL SQL. This is a very simple PL SQL program. I have in the declare section up here, I have declared some variables, last name, first name, and I'm getting this stuff from the definition of the author's last name and the author first name in the author table. And it's pulling over the data type for that. In the begin end, which is where the processing happens, I'm doing selecting author, author first name, author last name, into. See, that's different. We don't have an into in interactive SQL because we're not going to display it on our interactive window. We're going to put the information directly into a variable. So I'm selecting it into V first name, V last name, from author, where the author is 108. Okay, so I've got this 108 is the author ID here. As long as I have that, then I know I'm going to get just one back and it's going to go into the into. So after I've got that information, I can write it here. This is what this put line does, is I can say name, that's a literal, and I can say first name, space, last name. So name, Steve Perry, for whatever. So that's a very simple example for PL SQL. Here's one that's a little bit more involved. This is where we're going to get multiple rows back from a select statement. So again, we have the declare area. We can declare variables as we do here, but we can also declare a cursor. So it's a cursor, give it a name, is, and we store a select statement. This is almost like a little view in the sense that you're giving a name to a select statement. Now, a select statement that selects first name and last name from author is going to bring back a lot more than one row. So we've got to deal with this. And the way to deal with it is with a loop. We have a loop and an end loop down here. So in the begin-end block that you see, the very first part of it says, if not author cursor is open. If we haven't opened it, which is really run it yet, then we open author underscore cur for author cursor, and that runs the select statement stored with it. The very first line under the loop is fetch. It fetches the author cursor into author record. This is getting complicated, right? So we go right into author record, and that allows us to deal with these pieces of data. Exit here, we exit when done, or rather when author cursor, or cur as we put it here, %, not found. It'll keep doing this loop, and it'll exit when we go through and try to read another row and it's not there, it'll pop out. We are there, we'll do that dbms output put line, and we'll write out the first name and the last name. A lot of complexity here in PL SQL to get this information out. But any programming language, really, you learn the syntax and you just use the way it's laid out for you, and you get the information out of the database. So again, Infinite Skills offers a class in PL SQL. So if you learn SQL here first, you're here at the end, it would be good to go on and learn that.